Hello, 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 hello.
হ্যালো, বলছি ওই ডাইরেক্টর স্যার একটা মেল করে দিয়ে ওয়ান এতে প্রেজেন্ট থাকতে হবে, ঠিক আছে?
Hello, hello.
We'll start now. The Bio E3 Way by the Department of Biotechnology. I now request
This
ILS
conference
to
is being
start the
recorded.
program.
Thank you, Dr. Kalaivani. Good morning, everyone. I hope I'm audible.
Good
Anyone can?
morning, sir. Perfectly audible.
Thank you. Thank you. I thank DBT for giving ILS the opportunity to come as an opening batsman on this World Bioproduct Day, which is celebrated every year on July 7th. This is a global initiative and emphasizes the significance of bioproducts, which are materials, chemicals, and fuels derived from renewable energy and biological resources in fostering a sustainable and circular economy. This day celebrates innovations in the bio-based sector and emphasizes the crucial role that bioproducts play in achieving a sustainable, low-carbon, and circular economy. This year, DBT, the Department of Biotechnology, is observing World Bioproduct Day with the theme Voices Across the Cities, a synchronized national hourly dialogue series. Through in which I think all the various cities are going to observe this. So at ILS, so we are planning to spend about an hour on discussing various initiatives that have been taken at ILS or Big ILS. So this bioeconomy, this is with the Bio3 policy, the Department of Biotechnology in India, which focuses three pillars: bioeconomy, environment, and employment. The bioeconomy pillar of Bio3 is highlighted through this event, showcasing how research and innovation can be transformed into market-ready solutions, thereby boosting India's share in the global bioeconomy. The environment aspect is addressed by promoting bioproducts that reduce dependency on fossil fuels, decrease in plastic pollution, and support climate goals. In next 2 or 3 minutes, my colleague Dr. Soma will take you through how have we planned to spend the next 1 hour through various programs. Dr. Soma.
A very good morning to all of you present here, as also in the virtual platform. It's my privilege to address you today on this occasion of World Bioproduct Day, a celebration that aligns closely with our collective effort for sustainable and bio-based solutions. We need to raise our awareness and recognize the remarkable potential of bioproducts in shaping the sustainable future. Today, we embark on a journey in our city in Bhubaneswar, where we are located in Odisha, and with the long coastal line, we reflect the theme of coastal biomass and marine byproducts, where we focus on whatever our oceans offer us, The marine ecosystem is with rich biodiversity across mangroves, coral reefs, seagrasses, and macroalgal beds, which make it an untapped reservoir for marine-derived bioproducts. So today we are going to listen about the coastal biomass and marine bioproducts from our director, the work that we are doing at ILS at present, and we will be having a panel discussion where we will discuss on the ecosystem for again coastal biomass and marine researches and bioproducts. Followed by there will be a talk from innovator organophonics who are working on probiotics for soil and aquaculture. And then we also will be hearing from the student innovators, those who are working on pharmaceuticals in space research. So let's celebrate the World's Byproduct Day, which reminds us that the ocean is not merely a frontier, it's a collaborator of innovation. Together, let's continue to advance science that is impactful, ethical, and deeply attuned to the needs of our region and the planet. Thank you.
Thank you, Dr. Soma, and team. Quite a number of people have been working in last couple of days to get this program planned in this such notice. I think a lot of activity also has have taken from centrally from DBT to uh, collect so many people through online platform. So what I'm going to do in next 7 to 10 minutes to tell few initiatives that have been taken at ILS, and from there we will move to further discussion to a panel discussion. I hope my slide is seen at the far end. Can anyone confirm? Am I audible and am I acha, visible?
Yeah, you're audible and you're
My slides are
visible.
visible.
Yes.
Yeah, thank you, Chandrabas. So as we just now mentioned, World Byproduct Day. So one nation, one day, 1 hour per city. Here we are from Bhubaneswar, capital of Odisha. I'm going to spare a few slides, couple of slides, talking about ILS, a brief history. It started way back in 1987 and 89. The first director joined, and as you can see on the right hand side, it is a bit nostalgic for many of us, which was a single building lying over here, and then we started recruiting people. The director joined in 89. First publication came in 1996. The campus foundation stone was laid in 97. And 2002, DBT took over Institute of Life Sciences from the state government, and it became a DBT institute. 2009, the first patent was filed. 2013, foundation stone of the campus 2 laid where the residential people are there and the bio incubation center is there. 17, the outreach center also started. 19, the first tech transfer happened. Most important point is this, that technology transfer happened and way back in 2019. 2020, the bio incubation center started or became functional. And now today we are here at 2025 with lots of building, but still we are falling short of space because the way we are expanding. And what are the activity we are doing in this small space is that ILS, whose mandate is for the betterment of human health and welfare, with the objective that it's promoting the basic and applied research in frontiers of life sciences. Broadly, the science that we do over here with about 26 faculties and technical staffs and other administrative staffs and about 150 plus students, PhD students and project assistants also. We work in the area of cancer biology, interdisciplinary biology, infectious diseases, and plant and microbial biotechnology. Of course, like a sinusoidal wave, these fields, the number of people working in this area go up and down depending on new recruits and scientists retiring. However, these are the four major focus area in which the scientists and the groups can be grouped into. Uh, we have a, good amount of facility and very cutting edge facility even in this small space. As you can see, most of these facilities are available through a platform called Sahez platform, where where faculties and researchers from the city and from other
Can
places.
you please unmute the mic? We are not able to hear.
Really?
It's heard here. I think you have some audio issue. Please try it.
Oh,
No,
thank
we are
you,
not
thank
able
you.
to hear.
So there must be a local issue, sir, at your end. So ICGEB, Trivandrum, all people confirming that they can hear. So I'm sure anywhere there is an audio issue, please look at your local audio issues.
Yes, yes, we are able to hear. From
Thank you.
NIBMG, we can also hear.
Thank you. Thank you. Appreciate it. So coming back, so in terms of facility wise, it is quite cutting edge, and not only the ILS researchers but people from outside. Uh, can you please mute somebody in the online platform? If you are not asking a question, please mute your mic. I'm sorry. Can the administrator also take care of this? Okay, so moving on. This is about the facility. Now let us talk something about the technologies that are developed here from the research that has carried out over here. So, fulvin as an adjunct drug for the treatment of cerebral and
हाँ?
severe malaria. So it is a FDA approved
देखो
drug.
दोनों select किया, दोनों में नहीं सुन रहा है.
I'm really sorry, administrator.
अनप्लग करके प्लग करो. NCCS can mute please. NCCS.
HDMI be unplugged. No.
Can you please? Uh,
NCCS
Yes,
can
we
you
can
please
hear you.
mute?
Yes.
आता है.
Since I am seeing the full screen over here, I am and also not the administrator. Can't. Okay. Thank you. So this is a very interesting story coming out of ILS. Dr. Arun Nagaraj and team has worked on a FDA approved drug, which is actually approved for antifungal drug. But now that we are seeing, it is working wonder for cerebral and severe malaria, and we are quite hopeful that this drug also solve quite a bit of malaria issue, which is endemic in Odisha's tribal regions as well as Africa and many other countries are facing this problem. The second story, which is about multi-drug resistance, a formulation which can inhibit the growth of multi-drug resistance. Dr. Tushar Beoria and team has worked on it. They have utilized FDA-approved drug, which has the efflux pump inhibitor to provide resistance against multi-drug resistance against staph aureus, which is an incredible story. So these are few technology I just named. I'm not going to take more time on this. There are few startup companies that have started at ILS. There are many, but the three that I mentioned over here are actually from the faculties of ILS. So Polyorbit Private Limited by Dr. Mamoni Das, RNA Biotech Private Limited by Dr. Amaresh Panda, and last but not the least, Dr. B. Ravindran, who retired from ILS as a director of the institute. He also started a company from the science that he has done at ILS. So it is about nitric oxide producing agent, NOCIP antagonist. So these are all individually interesting stories. I hope some other time we'll get to discuss about details on each of these scientific things. There are a few products also that have been developed at ILS. Magnetic nanoparticle based cell separation kit may sound that it is trivial, but no, there are requirement by the faculty, by the researchers, and this was seen by one of our startup companies, and they said, okay, why not we create such simple magnetic nanoparticle based cell separation kit. Uh, so, and then we also have antibodies for chikungunya virus. Dr. Soma herself has spearheaded this work. And RNA biotech, the one I mentioned just now, by Dr. Amresh Panda, also looked at the day-to-day need of the research laboratory and then tried to prepare kits, which is working really wonders, and it can challenge many established companies because the prices can be lower and the efficacy is better. Uh, and there are many companies, as you can see the logos on the bottom right, which are not started by ILS faculties, but then people over here, they took advantage of the ILS Bioincubation Center. So in the last 5 years, the bioincubator has supported about 44 startups. 51 IPs and trademarks have been filed. Nearly 10 crores plus fund has been raised, as well as many products, 69 products commercialized, 250 people have been employed, 147 programs going on, so on and so forth. So, in fact, the Bio-E3 policy has made our life easier because employment, environment, and all these things, economy, we are already working on it. So, this is going now to take a good pace over the years. Here is a glimpse of few products that have been developed at the bioincubator, and they are in the market. The wellness fragrances, neuro cosmetics, so on, and this is my favorite one, which gives a lot of happiness by drinking these beverages, instant tea, so on and so forth. Many things are there. Uh, I'm going to end my this talk with a initiative that has been taken here at ILS. We have a natural strength or advantage of having a large coastline, more than 500 kilometers, largest brackish water lagoon, rich marine bioresources, about 31, more than 31% of Odisha has a forest cover. One third of the state is in the hilly region, and several tribes are there. So, given all this biodiversity and all, we thought of entering into a new regime, new program, which is called bioprospecting resources from Odisha's deep ocean. So, where we are trying to get into not only Odisha, also southern part of India, the peninsula region and the Bay of Bengal, we are collecting samples from at various depths of the sea, but we have confined ourselves to the river estuaries where fresh water comes and meets with the ocean, and we are collecting samples from 0 meter, 10 meter, 20, 50, 100, 200, and from the Bentham. What we are trying to get, to look at the various microbial species that we can get. We're trying to isolate compounds, a lot of interesting molecules that we have got there, and which we are trying to look at the applications there. So, in a nutshell, if I can give a glimpse of what all things we are planning to do, we are looking at the biodiversity of marine microbes, multiomics of the marine microbes, bioprospecting those for human health and industrial application, developing an AI/ML pipeline for the data analysis. Odisha has recently started a program called OMBRIC. This is not the brick that DBT has started, but this OMBRIC Odisha Marine Biotechnology Research Innovation Corridor, where the institutes located in Odisha, either Barampur, Fakirmon University, Barampur University, the NIT Rourkela, all these people now engaging into a top-down research where the ILS is going to play a crucial role of having the biorepository and providing genomic solutions. We are planning to start an enzyme production program and a biomanufacturing hub at ILS with these focuses. I don't know how much time I have taken. Maybe I have overshot a little bit. These are some of the ILS outreach programs that we have conducted in last 2 years or so. So not only the research that I spoke just now, which is deep research, we also try to educate, excite the young masses from schools, colleges. Our faculties go to remote places where people cannot come here due to logistics issues. Then the faculties go there and then excite them about the prospects of biology, biotechnology, and similar area. So this has been showcased on various occasions in the Indian International Festival, Science Festival, and National Science Day, building entrepreneurial ecosystems. So that's all from my side. I think we will now go to the next piece of program. Can you? Uh, from DBT, is it okay that we move on, or if there are any queries or any questions that anybody want to ask, do ask through the chat boxes. That way it can be interactive and we'll try to address. But meanwhile, I think we will move to the next program, which is a panel discussion, spot on time. So Dr. Soma, you are going to moderate, or you are going to moderate? Shubho. Yeah, go ahead.
Good morning, everyone. It's my pleasure to welcome you all to this very special panel discussion as a part of World Bioproduct Day 2025, organized by DBT and hosted here at Break Institute of Life Sciences, Bhubaneswar. We are honored to be joined by three distinguished scientists of ILS. First, I am going to Dr. Sanjeev Sahu. Sir, for your, I want to ask you that what is your opinion on the potential of Odisha's coastal region to contribute to India's bioeconomic growth in the near future?
Yeah. So as you know, strategically, Odisha's location next to the Bay of Bengal, it gives a pleasure, So that, and also we have a 480 kilometers of, coastal belt with a diverse ecosystem with rich biodiversity. From Gopalpur to Diga, we have the Chilika Lagoon, and also we have a lot of mangrove forest, near to Tarkanika. So it gives a very high value added phytochemicals for by manufacturing for pharmaceuticals, cosmetics, and also the presence of this seaweeds and seagrasses. Also, it gives a additional value in the case of pharmaceutical industry.
Thanks, sir. It's very encouraging to hear that the local marine ecosystem can feed to the national level bioeconomic strategy. My next question to you, on based on building on that, what are your views on the use of marine resources in pharmaceutical research, particularly in the context of cancer biology?
Yes, as you know, chemotherapy basically used in case of for the cancer patients. But due to the high toxicity, the alternative, they are looking for some phytochemicals which has a non-toxic nature. And I am very sure, lots of work is going on. Since the phytochemicals constituents from these seaweeds, seagrasses, and also the mangrove leaves, due to that non-toxic nature, maybe it will be used as a supplement or value added to the existing chemotherapy for better treatment for cancer patients.
That's truly inspiring that the idea might someday lead to the next generation cancer therapeutic. Now I'm going to the Dr. Shoma Chattopadhyay. Dr. Chattopadhyay, what are your views on the use of marine resources in human health research, particularly in the development of antiviral and antibacterial agents?
Yeah, so regarding this antiviral research, till now there are not many compounds in the market, but there are a lot of publications where macromolecules or like microorganisms of marine origin has been shown to be a potential molecule, like from red algae or cyanobacteria from sponges and many other like plant also, even seaweeds. It has been shown that for HIV, for SARS, even dengue, different arboviruses, as well as for herpes viruses, it has been shown that they are showing antiviral property. But this has not come as a product till now, but it needs a lot of other effort to bring it to the market. But yes, there are potential.
Thank you, ma'am. The emergence of antimicrobial resistance certainly highlights the need for new naturally derived compounds, and marine microbes could be the gold mine for that. Mike, next, just shifting the gear slightly, that what is your opinion on the role of marine agriculture and marine derived foods in adding the nutritional needs of growing global population?
Yeah, I mean, marine ecosystem is relatively, less explored, and my biodiversity anyway is a big potential for our country. With this long coastline that we are discussing since morning, so whatever we have discovered till now, we have lot many things to be explored, and definitely that will give a huge source of food, not only for human being but for the feed for the animals as well as for aquaculture, and definitely that will boost the economy of the cultivars in and around the coastal area.
Thank you, ma'am. And you already introduced the marine algae like seaweeds, and also next I'm going for this similar type. Another question, which is not the application now, is little bit of basic biology and systematics of understanding our marine ecology. So now I'm going for Seema Pradhan. Dr. Pradhan, is there a role for basic biology, particularly genomics, in advancing our understanding of marine algae?
Yes, I believe there is a very big role for genomics to play. As Dr. Soma very rightly pointed out, there is a huge biodiversity which has not yet been explored. And I believe that the first step to exploring this biodiversity should be a good foundation of genomics. That will provide us the data about what are the biomolecular markers which can be used for identification, diversity assessment, and also, since the concept of junk DNA has become almost obsolete now, almost all part of a genome, even the non-coding part, has a critical role to play. And in case of seaweeds especially, there is very little genomic data available till now, which is a huge potential for exploration. So there is novelty in the research which attracts many people. And also there is a huge scope for application. So yes, I think genomics would be the way to go for a basic biology approach.
Okay, absolutely. Understanding the genomic architecture of marine organisms is the key to unlock the full potential. And I'm glad you emphasized that. So could you elaborate on how genomics can be applied to enhance seaweed cultivation or improve the production of bioactive compounds?
So we can go by two parts of this question. So first was your question on the application in seaweed cultivation. So in this context, since we know very little about the life cycle of seaweeds, what they need to grow, there is very little input into the seaweeds. They grow very fast. So we can use that area of exploration. We can explore what makes them grow so fast and apply it for seaweed cultivation, improvement of the cultivars. Then the second question was about improvement of the bioactive compounds. So I'll give an example here. The main product of seaweeds is carrageenan. It's a very huge potential of carrageenan in a market because it's a gelling agent. Usually it is used as a substitute for gelatin. It's a plant-based substitute for gelatin. So it has huge applications in food, pharmaceuticals, cosmetics. But the demand of carrageenan is so high, yet we have to import all those biomaterials from countries like Indonesia, China, and Thailand. India already has a huge potential for seaweed cultivation, as already pointed out by both of our senior scientists. So it would be a mistake to not tap into that potential and go for a multi-omics approach rather than just the genome. Genome can form the foundation of what we are looking for, and then transcriptomics, metabolomics, proteomics, everything has to go hand in hand to identify the particular genes that need to be manipulated and use it for betterment of the seaweed culture.
And if I may add, I think this panel has rightly ventured into a topic which is currently very hot topic. Uh, there is a high level meeting going on at the secretary level who are thinking as seaweed as a future feedstock. All the attendees of this uh, meeting, particularly, there is a good news. DBT and other ministries are going to come up with a call for proposals where people who are interested in seaweed biology might get a chance to showcase their particular skills in this area. So what you'd have, it would be like a relay race. So for example, how to grow seaweed in huge quantity. So that is a production. The second would be how to identify which seaweed has a more commercial value or more potential for other usages. And then there will be chemical engineers or bioengineers that would be required who can process them chemically or enzymatically. Then they can reduce the oligosaccharides, polysaccharides to oligosaccharides or monosaccharides. And then ultimately, I think the country is looking at it as a top end game as to how to produce alcohol from this seaweed or the feedstock or the animal feed or aqua feed. So this is going to be an exciting decade who are getting into seaweed biology. So Seema, well said. I think multi-omics is the way to go forward, not just the genomics, but rather the transcriptomics, the metabolomics, understanding the pathway. Maybe genetic, some editing technology would be required, which can bring it back to things that are already consuming those and not letting bigger saccharide to form. So there are many exciting questions are there.
Yes.
Sir, I'd like to also point out a new area of research here that is into the microbial associations with the seaweeds, because that has been a very unexplored area. The diseases that are affecting the seaweeds, because the production ultimately suffers because of those things. So there is a huge potential for microbial exploration also associated. So I'd like Dr. Shubhobrata to elaborate a little bit about the fungal pathogens and maybe about the endophytes especially.
So yes, as you said that endophytes is very new in case of seaweed biology, but endophyte are within the seaweeds, and it's a vegetative growth, so it's transferred from seaweeds to seaweeds. So at ILS, we are also looking for the different type of endophytes from different region of the Odisha and others part of the country. And we are excited because lots of endophyte we have already isolated, and we are going for their sequencing and their understanding. And as you know that it's very difficult to spray anything in seaweed because it's in a sea, so it's wipe out. So maybe in the future, we are planned or we try to develop some technology based on endophytes, which can protect or grow the seaweed and protect the seaweeds in the harsh conditions or different conditions. And that's why we need a knowledge, and we need as much as endophyte we can isolate and collect. So I've also wanted to ask Sahu sir, uh, we have some time. So, what do you think that those fishermen, those are depend on the fish, how we can motivate them to uh, cultivate the seaweeds and others like other state already doing that, but how Odisha can be motivated them? What should we do for this aspect?
Yes, it is a good question. So in Odisha, we have one or two startup like Brahma Kamal and all. They are growing the seaweeds. The main question is, in the rainy season, due to the heavy rain and changing the salinity, they could not do for 3 to 4 months. And once more, when they want to again to grow, they need the small part, from outside, which is very costly. In this regards, we have already started at ILS. Can we have a biobank, so maybe we can supply at the same time. At the same time also, we need a more or less to convince the farmers and give a orientation. So, and at the same time also we have to prove it is basically economically viable. So I think time is coming. We can
Or
do that.
it can be side by side with the fish and seaweed. Both can be cultivated in that way.
Yes.
Okay. Sir, I wanted to ask Director Sir. So must be there is some policy can be needed, or some specific plan national wise we need to promote the seaweed. So what is in your mind? How we can start?
Absolutely, I think you are spot on. Policies are needed, policies are there, policies need to be edited. I think this is a topic which requires interministerial discussion. See, when we talk about seaweed, it is just not in Ministry of Agriculture or with Ministry of Forestry, Ministry of maybe Fisheries. So very timely, people have realized. I think there is an interministerial discussion that is going on, that has happened recently, and the key people are talking at the top how to make clearances much easier, so that scientists who are working at the on the seaweed biology, they are not disturbed much. The main, I think, requirement would be at the production level, where industries or mechanized industries can easily produce a large quantity of seaweed. But once that is produced, processing them or doing a research, there are no hurdles at this point of time, I believe. But do you all realize that at ILS, not just we are going deep into the ocean, some of our startups also have gone up, taking biology into the space. So,
yes. So our next
speaker will be
speaker. So as a closing remarks of this discussion session, thanks to all our panelists for such rich discussion. From this discussion, we realize that marine biotechnology is going to be a strong pillar in establishing bioethics policy of our state and our nation. Thank you, DVD, for this national platform. Now we are going for the next part of our program.
So let's hear some exciting journey.
Yes, I request Dr. Shuma Chattopadhyay to for the next session.
So our next talk would be from an innovator. He is talking on pharmaceutical research and how we can do that in space. So Antariksh.
The speaker's name is Antariksh, and he is also working on space biology. So interesting.
Hi everyone. Honored to be honored to be part of this discussion. So we are Serendipity Space. I'm the co-founder and CEO. My name is Antariksh, and our mission is to accelerate drug development on Earth by processing pharmaceuticals in space or microgravity. For that, we are building small reusable satellites, which are about the size of a travel suitcase that you usually carry around in your trips. Which can go to space, autonomously produce pharmaceuticals and proteins in space and bring them back. And there is a neat story to be narrated here of why do we even need to think about going to space. Yeah. So the current state of all pharmaceutical companies around the world is determined by this staggering statistic, which is that to bring a drug from its birth to its maturity, It takes about 10 to 15 years, costs $2 to $3 billion, and even then the failure rate can be as high as 90%, which means that at any stage the drug development can fail. But when we started with serendipity, we were wondering what the reason for this statistic is. And turns out that we are not focused on clinical trials per se, but everything that comes before that. And when you think about everything that comes before clinical trials, the first step, which is the discovery of the drug compound, as well as optimizing it and developing it into a formulation. There are a number of scientific and industrial challenges that pharmaceutical companies face. Some of them are you often don't are not able to crystallize the drugs as well as the proteins, which are often known as undruggable targets. The second is that even if you're able to crystallize the compounds, when you move towards the formulation stage, you often face issues such as you are not able to control the particle sizes of the formulation or the solubility. And all of this actually leads to very low quality formulations, which have to be done with repeated trial and error for years. And this is where, around almost a decade and half the total cost of drug development goes into. And this is where we thought we could have an impact by basically collapsing this time and money that was spent on doing trial and error by doing more focused discovery and development of drugs. And the industry secret has been that over the last 30 years, I mean, it's not very common in Asia or maybe in the East, except Japan. But in the West, companies have often gone to the space environment to bypass some of these problems because zero gravity has no sedimentation, no convection currents, and no buoyancy. So as a result of which net new materials can be produced. And this is not only true for pharmaceuticals, that is also true for metal alloys, semiconductors, and fiber optics as well. So, this has been happening since the last 30 years, and I want to show you some commercial successes that have come out only in the last 2 to 3 years. And you can see that the first set of images over here, which are the blue ones, this is a monoclonal antibody drug made by Bristol Myers Squibb. Now, they were not able to get the drug, like the correct crystals of the drug in the right geometry, in the right size. But once going to space, they actually got much more uniform crystals, larger and structurally better. And the second set of images, which are the black and white ones, is these ones is the most actually the biggest success over the last 2 to 3 years, which is of a drug called Keytruda. Now, Keytruda is the world's highest selling drug. It does about $25 billion annually in sales every year. And, they were trying to make a subcutaneous formulation of this monoclonal antibody drug. However, they, were not able to make it because they had issues with agglomeration as well as viscosity, all of which were solved by going to space. And they brought it back down, and this is astronaut Thomas Pesquet actually mixing Keytruda in 2 bottles in the International Space Station. And what our plan is to build a reusable satellite which is less than 100 kilogram, which can go to space and then manufacture pharmaceuticals over there over a couple of weeks or a month as required, and then re-enter into Earth's atmosphere and then have a soft landing somewhere on the coast or on the land. Now, what is exactly the vision of the company is that we want to start out for the next 5 years to actually produce gram scale crystals of proteins as well as pharmaceuticals to basically, accelerate drug discovery and development. We want to use that revenue to fund the further manufacturing of a larger satellite, which can do kilogram scale manufacturing of APIs such as Keytruda. Now, this unlocks a huge market which was not possible before of pharmaceuticals that actually cannot be made on Earth currently. And we think that our projected impact is going to be something like 20 to 30% cost reduction in overall drug development, as well as a reduction in time to market of a drug by 3 to 4 years. And this is not us saying it. We talk to companies all over the world. We talk to Novartis, Pfizer, Bayer, Roche. And from that, we actually, and the companies that have actually done this in the ISS, the reason that they were pursuing this was that they actually expected, and in some cases, they actually got drugs which hit the market with much lesser time. And this is our team. We have a brilliant team ahead of us, Jivitesh and Monica. They're handling the technical side of things, and Monica previously worked at NASA as well. She's handling the space side of things, and I'm basically the salesman of the company. We have in our advisors, we have Dr. Subhabrata Sen, who previously worked at Pfizer India and Syngene as the scientific manager, as well as the director at Aragon Bio, as well as Dr. T. N. Suresh Kumar at ISRO, who has helped us get inroads with ISRO. Now, where we are in terms of our product is we have built a small autonomous pharmaceutical factory, so to say, which can grow crystals of proteins and small molecule compounds, and also do formulation such as crystalline suspensions. And just in the last 6 months, we developed this. We tested it in multiple labs across India, and we successfully produced simple proteins like lysozyme, apoferritin, as well as some small molecule anti-cancer drug compounds as well. And we have been lucky to be a part of Brick ILS Bio Incubator. They have provided us with tremendous amounts of opportunity and visibility, which is why we were able to get some of our customers even in India actually. And so this is our plan. We have already have an agreement with InSpace and ISRO, and hopefully whenever the next launch opportunity comes up, we will be sending our payload to space to autonomously manufacture pharmaceuticals in space as a technical demonstration. That's about it. Thank you so much for listening.
Thank you, Antariksh. It's very exciting research that you are entering into, or you have entered into already. And at the same time, it is very costly also. This kind of research that you are entered into. So, are you facing challenges of getting fund or to do this research, and how much fund have you generated so far?
Right. So we have raised our first pre-seed round worth a little more than $500,000,
Wow.
and to basically fund the manufacturing of the core technologies to build out the satellite. And of course, it is going to be a little capital intensive, but I'm pretty sure that the rewards that come out of it will dwarf the investments we raise.
And you told me that you missed the Axiom 4 boss because you started. The research that is going on Axiom 4 have started long back. By
Yes.
the time we were not even.
Yes. So we're less than a year old as a company functioning, and by the time we realized that there was opportunity for Captain Shukla to actually fly to the ISS, the research had basically been decided of what all experiments are going, but otherwise we would have been a part of this for sure.
So, okay, hopefully we see some of your ideas crystallized, and not only proteins also. Thank you very much.
Thank you so much.
ICGEB has raised hand. Are you trying to ask a question, ICGEB? Yeah. Please ask. Yeah, answer it.
Right. So basically, fortunately, there are two things like that have been established over the last 30 years, that the crystals, once they return, they actually retain their form and structure, because the medium in which they return, or like the apparatus inside which they return, it is ensured that it is viscous enough to not crash into the walls. And so the vibrations, the high G effects, everything that is required to be done, the crystals are not damaged. And that's the same logic that we are following as well.
Thanks, Ramesh. Okay.
Right. Yeah, brilliant question. Trust me, if we had the chance to do that, we wouldn't go to space, because going to space is tough. But the reason is that there's a reason it's known as a simulation for astronauts, because the maximum gravity level that you can reduce on Earth by any object, by any machine like a clinostat or anything, is 10 to the power minus 2 Gs, which is 1/100th of Earth's gravity. But what you actually need for any meaningful advancement in pharmaceuticals is 1 millionth of Earth's gravity, which is microgravity. So 10 to the power minus 6. So, and there is no, the laws of physics don't permit creating a microgravity environment on Earth. So that's the reason that we have to resort to space. Otherwise, I would have personally done it on Earth.
Request everyone to put your phones on silent mode. Request all of you to put your phones on silent.
Yeah. So should we go ahead with the plan as because one more speaker?
Yeah,
Started
you can
20.
continue.
Yes. So thank you, Antrix. If there are more questions, we'll get back to you. But let us go ahead as planned. You are here on this side. Okay. So we have with us. Yeah. You introduce. So Dr. Vishwaranjan Pradhan.
Yes.
Right. Yeah.
So he is the founder of this organophonics, and many of the students will be really encouraged seeing him because he is a PhD. He got his PhD from NICER, working with Dr. Palokai, and then he did postdoc at ILS with Dr. Shanti, and now he is having his own startup. Yeah, Kishore.
Fantastic. PhDs to postdoc to having own startup. It's a very interesting journey. Please share your. You want some slides, huh? Slides. See that? Right. You can go ahead while he's projecting slides.
Hello everyone. So good morning. So so coming to organoponics, so it is actually started in 2021, but the research and the ideas and everything. So it was much before around 2008. It was been established because I'm from near Chilka. Okay, so which is the largest saltwater ecosystem here in Odisha, and I have seen that around 9,000 acres around the Chilka is being cultivated with aquaculture, particularly for the shrimp farming, and over 15,000 acres for the fish farming. And so what we do, okay, so coming to the problem.
Next. Yeah, just click on here.
Yeah. So coming to the problem. So, means in Odisha, sorry, in India, around 20 lakh acres of area is being used for the aquaculture, which releases around 2,000 billion liters of water, which are actually nutrient rich, to the nearby water bodies. And in Odisha, around 2.5 lakh acres, which releases around 250 billion liters of nutrient rich water to the environment. And coming to the Chilka, so around 264 billion liters from the shrimp farming is being released, and which increases the eutrophication as well as the Phragmites growth in 1987 to 2024. Around 14% increase in the Phragmites in Chilka is because of the nutrition from aquaculture and from the sewage flowing through the rivers from the Bhubaneswar municipality. So we have come with a solution for the both of the things. So the first one is actually which are the microbial compositions. So mostly to recycle the nutrients, okay, which are flowing from aquaculture, from the sewage, as well as from the agricultural fields to the Chilka Lake. So super microbiomics is one such. So which is actually a microbial composition mostly for the soluble components, organic components, and STX is for the insoluble ones as well as the regeneration of the soil. And so pro microbiomics, okay, it is particularly for the aquaculture one, okay, so mostly for this continuation of aquaculture and recycling the soluble waste coming from the metabolism of the shrimp farming as well as coming from the feed and other nutrition given to aquaculture. And for the growth, okay, we are given this organo boost. And particularly the biggest problem is the ammonia nitrate and nitrate, okay, which are generated in aquaculture ponds, okay. So we have a microbial solution called NILSA, which effectively releases, recycles all these things, okay, into the planktonic system, both in the phytoplankton as well as the zooplanktons, and again, incorporate into the food system So increasing the decreasing the FCR and increasing the productivity. And the major problem in aquaculture around this area, it is in Vibrio. So we have a microbial composition, okay, which is called Vibdux. So which competitively suppresses the Vibrio growth and suppresses the white gut, white fecal systems, as well as the mortality in aquaculture. And to treat white gut, we have another product called Vidux. Okay, so which is again a gut microbial composition. And okay, I have a small video to play. So, what impact we have created? We have enhanced the socio-economic status of over 6,000 farmers in coastal districts of Odisha. Out of this, okay, around 2,000 farmers are from the around the Chilka Lake, and we have enhanced the shrimp productivity in Chilka Lake region by 2,500 ton in last 4 years, amounting around 75 crores. And we have a plan for the next 5 years to enhance, particularly from 9,000 acres around this area. So with decreased footprint by around 1,200 crores. And we have treated over 150 million liters of aquaculture water. So that was directly released to the Silka Lake, and which has this microbial composition, which can digest the sewage coming from the urban waste. And around, yeah, so that was the impact created in last 4 years. Thank you very much.
Thank you. Congratulations. From PhD to postdoc to now having your own startup, and you are also working in the area, the theme that Bio-E3 is biology for economy, environment, and employment. Environment, though I can understand, employment also I can understand. Yeah. I hope very soon also you will have that economy part, which will make you rich and famous. Okay, great. So I think we should move on with the talk sharing. Okay, with the program. If there are any questions or discussion needed, we can come back after this Bio-E3 policy, that city place that we are going to take. So what I'm going to do, I'm going to take the place here in the city of Bhubaneswar. And I do not know anybody else who is from Bhubaneswar, Odisha, who have joined through online can take the place along with me, and whoever wants to. So you people are ready to repeat after me. It is going to take some time. It's a long place. Let us stand up. Okay. सबके पास पेज नहीं पहुंचेगा तो शेयर इट, मेरे बाद रिपीट कर लीजिएगा. Are we good to go? Yes. Ready? Okay.
No, he says and then we repeat.
Okay. Yeah. So the place to advance the Bio-E3 policy for a sustainable future. Please repeat soon after me. We, the people of Bhubaneswar, in the state of Odisha, wholeheartedly affirm our commitment to the vision of the Bio-E3 policy of the government. A strategic framework to build a sustainable, inclusive, and innovation-driven bioeconomy, grounded in environmental conservation, economic opportunity, and employment generation. Recognizing our state's unique scientific, ecological, and cultural context, and the immense potential of our bioresources, we pledge to implement the Bio-E3 policy with the dedication and leadership guided by principles and priorities. Promote and actively collaborate on the bioproduct innovation. Unlock local and national potential. Establish and promote biotech innovation hubs that drive a regenerative circular economy. Enable bio
Namaskar and good morning, everyone. I, Kalaivani Ganesan, on my personal behalf and on behalf of the Department of Biotechnology, extend a warm welcome to the Honorable Minister of State, Ministry of Science and Technology and Ministry of Earth Sciences, Minister of State PMO, Ministry of Personnel, Public Grievance and Pensions, Department of Atomic Energy and Department of Space, Government of India, Dr. Jitendra Singh Ji, to DBT for the World Bioproduct Day celebrations, the Bio-E3 way. I now request Secretary DBT to welcome our chief guest with a memento. DBT, along with its public sector enterprise BIRAC and autonomous research organization BRIC, is celebrating the World Bioproduct Day as a collective movement marking the era of bio-based products. I now invite Dr. Alka Sharma, Senior Advisor and Scientist H and Biomanufacturing Directorate Head DBT, instrumental in driving the program in the department, to formally welcome the dignitaries and set the context. I request everybody to please put your mobiles on mute.
Thanks, Clavani. A very good morning to all of you. On behalf of Department of Biotechnology and BIREC, it is my honor and privilege to welcome our chief guest, respected Dr. Jitendra Singh Ji, Honorable Minister of State, Independent Charge, Ministry of Science and Technology, Ministry of Earth Sciences, Minister of State, PMO, Ministry of Personnel, Public Grievances and Pensions, Department of Atomic Energy and Department of Space, Government of India. Sir, we are extremely grateful to you for sparing your valuable time in spite of your extremely busy schedule today. I also welcome Secretary DBT, DG BRIC and Chairman BIREC, Dr. Rajesh S. Gokhale, all the directors, faculties and students from IBRIC Plus family, eminent speakers, all the participants joined online from various social media platforms and also in person, and my colleagues from DBT and BIREC. As you know, the purpose of World Bioproduct Day is to create awareness of the importance of bioproducts around us and how they contribute to the larger goals of environmental sustainability and climate action. Sir, I would like to share with you the World Bioproduct Day. The Bio-E3 Way is the first celebration on this day after approval of the Bio-E3 policy by the Union Cabinet under the leadership of Honorable Prime Minister. Creation of an enabling environment for bioproduct development is one of the key components of Bio-3 policy. The Bio-3 policy approved by the Union Cabinet under the leadership of our Honorable Prime Minister and released by the Honorable Minister is a visionary framework, and this marks a critical step in India's transition towards development of greener and sustainable technologies to enable circular bioeconomy for green, clean and prosperous India. So, unique feature of today's event is the launch of synchronized national dialogue series featuring voices across the cities, one nation, one day, 1 hour per city. The institution across the country are conducting hour-long thematic session on this theme. This initiative gives voice to regional strength, localized research efforts, and community knowledge systems, and is also designed to bring forward the perspective of young researchers, students, entrepreneurs, and local stakeholders. The entire day's proceedings are not just a celebration, but a demonstration of how science can engage society and how R&D policy can enable transformation. Sir, with this, actually, I now once again take this opportunity to thank Honorable Minister, sir, for your gracing the occasion. We look forward your guidance as we continue to strengthen India's bioproduct ecosystem under the Bio3 framework. I also thank all the participating institutions, startups, innovators, scientists, students, officials from DBT and BIREC, and all the participants for their active participation. Looking forward to having a fruitful discussion and interaction during the event. Thank you very much. Namaskar.
Thank you very much, ma'am. I now invite Dr. Jitendra Kumar, MD BIREC, for his remarks.
Honorable Minister, Sir, Secretary, Sir, and dignitaries present today on the World Bioproduct Day, the Bio3 Way 2025. Today I'm going to present some of the features that BIREC has initiated in our country, and that has led to the great, it being acting as a great enabler of the biotech ecosystem. If we talk about the BIREC programs and schemes support across product development cycle, which is lab to market support, we have incubation support, BioNest and EUA centers, early stage funding and translational R&D support, advanced stage funding, BIPP and SIBRI programs, equity funding, Seed Leap, ACE Fund, etc. We have mission programs, GCI, NBM, INSEPI, Make in India startup programs, niche area programs such as AMR, COVID solutions, clean cooking, Goargam, secondary agriculture, new drug development, synthetic biology, etc. We have networking, showcasing, and mentoring with featuring the flagship program Global Bio India, regional centers, First Hub, Path, etc. Validation and commercial support also we provide. And also we have a partnership, national, international, government, public and private agencies, public industries and investors. Due to these activities, India has taken a great stride in bioeconomy side. India's bioeconomy is scaling new heights. 2024 data is present here. India's bioeconomy has reached $165.7 billion in 2024, a growth of 9.7% from 2023. If we talk about India's biotech startup ecosystem, it has surpassed 10,000 startups in our country. There were only 200, 300 startups in 2014, and now within 10 years, we have reached 10,000, which is a huge surge. And I think we stand among the nations who have a great ecosystem of startups and innovation in the country. In 13 years, if we see, there are 100 plus incubation centers, 10 lakh plus square feet of incubation space, 15 lakh students and entrepreneurs have been engaged, 800 plus products in the market, 1,300 plus IPs have been filed, 28,000 plus proposals have been assessed, 4,800 plus startups and entrepreneurs have been supported, 6,350 crores of follow-on funding have been raised by more than 180 startups, 100 plus national and international partnerships have been achieved, 400 plus academia have been supported, 35,000 plus highly skilled jobs have been created, 10,000 mentors pool we have with us, 6,600 crores of total investments have been achieved, out of which 4,000 crore is from BIREC funding alone, and 2,600 crores have been co-funding by industry and others. So with this short presentation, I thank you all. We have some speakers also, and they will be talking about how BIREC has helped and what they are doing. But we can have a pledge first, I think. Oh, Secretary.
Thank you very much, sir. The architect of the Bio3 policy, ushering India's biotech renaissance, Dr. Rajesh Gokhale, Secretary DBT, DG BRIC, and Chairman BIREC, is requested for a special address.
Namaskar and a very good morning to all of you. First of all, thank you very much, sir, for joining over here today on this very, very special occasion. Actually, this is a global world product day. And this is becoming a very important feature to recognize the transformation potential of bio-based products such as biofuel, bioplastic, biopharmaceuticals, biofertilizers, and various materials that are going to lead to the sustainable part life of the world tomorrow. And I think this is the most exciting occasion because what we are looking at in tomorrow's binoculars is the future of tomorrow's world actually. And I think that's where this day becomes very, very critical and important of how we really come together and sustain. And on this occasion, sir, having you here makes it double jeopardy actually, because it just makes life so much more interesting when honorable minister, and also who has been practitioner as a clinician in his life, has actually uh, provides us this incentive and provides us this backing for taking this voices across the cities in synchronized way, so that it makes the dialogue series so much more incredibly important. So what I would like to do is actually what we are trying to say is the government of India has given a policy of BioE3, which is biotechnology for economy, environment, and employment, and to be able to enhance its reach to everybody. Actually, we have kind of have a synchronized one-day national dialogue series today in collaboration with BIRAC and BRIC. So these voices across the cities is a very important event actually, because what it does is showcase the regional innovations in bioproduct, valorization, manufacturing, and bio-based economy. And as you know, sir, each state has its own very unique uh, mindset, as well as their own bioresource, as well as their ability to be able to utilize science from their own perspective to make economic, societal, and environmental transitions. So towards this, the East session is actually very carefully designed to include not only scientific insights, but also grassroots innovators, students, startups, and many of these BIRAC's innovators are actually here in the room today, sir, actually. And I think there is also inclusion of youth voices, bioproduct showcases, and institutional pledge movements, which reflect a broader transformation where science is becoming a participatory, then rather than decentralized and mission oriented. So this is an encouraging model for embedding biotechnology in local development narratives, and I think everybody, the whole 8 hours of session today actually is going to discuss and talk about variety of features that will be dedicated on this rolling session to make one nation, one day, 1 hour, one city. So I think the core objectives are, as we've discussed, actually are value of bioproducts in driving zero waste circular bioeconomy. It captures the diverse regional success stories under the BioE3 mission actually. It mobilizes nationwide community of scientists, startups, students, and citizens, and positions India as a global thought leader in sustainable bioproduct innovation. So toward this, I will just showcase you how we've put this on a map of India actually to be able to say how does this, the whole day has progressed. In the morning, the coastal biomass and marine bioproducts are discovered in Bhubaneswar. It is followed by the BIRAC session today in Delhi where you are participating actually, sir. It is after this, there is a Nabi Mohali actually is going to discuss agri residues and bioproducts, which is going to be followed by ICGEB Delhi for enzymes as a key enabler of bioproduct economy. So this is followed by the one in STEM bioproducts and the second life of science and industry. So this will be followed by one in Pune, urban biomanufacturing and industrial waste utilization. So we have one in IBSD Imphal as well, actually the ethnobotany and forest-based bioproducts. And finally, the biopharma side streams as new inputs in Hyderabad. So it's a whole day-long event where all the 8 cities of the country actually are going to talk about the bioproduct and innovations and various aspects of activities that are going around. I think the whole purpose of this event is to connect ideas, people, purpose for a biopowered India. And that's where we think this facilitating dialogue between scientists, innovators, and students and startups creates a tremendous amount of excitement and motivation for the future of the country. As we have emphasized, the biotechnology's BBT's national mission and various programs aligned with BRIC and BIRAC is actually driving this innovation ecosystem. And it is encouraging citizen science, youth engagement, and grassroots innovation, which will foster a culture of circular economy thinking, emphasizing bioproduct valorization and sustainability. I think, sir, we'll stop here, but the conversations are anchored in local innovation and aligned with national vision, and that's how, therefore, they're framed in a way such that they're part of these independent cities, and different innovators are talking about it today, actually. And also, what we have done is that we have asked each one of them to take a pledge as an independent activity as well. So here, so we will take the pledge now, and you can stand up and.
सबको बांट दो ना यार,
सर सबके पास
अरे,
दिया हुआ
दिया है।
हाँ जी।
With English और हिंदी?
बोथ सर।
So I've been given English.
हिंदी भी दो सर।
जिसमें आपने बोलना है वही।
हाँ, इंग्लिश पहले शुरू करिए, फिर हिंदी। पहले इंग्लिश।
Twice?
If time permits, we can take.
We can take in Hindi.
हिंदी भी कर लो।
पहले हिंदी में कर लो।
एक ही बार कर लो। It's like taking is not done twice. Swearing in is not done twice. You are sworn in or you are unsworn.
We do it in one single language.
I request representatives from Jammu and Kashmir, Bhubaneswar, and Assam and Ahmedabad, Gujarat to come online.
Follow up first.
And all other representatives also from the states will take a pledge. सतत भविष्य हेतु बायो E3 नीति को बढ़ावा देने की प्रतिज्ञा। हम नई दिल्ली के नागरिक, भारत के नागरिक बायो E3 नीति की दृष्टि के प्रति
हम भारत
नई दिल्ली के नागरिक भारत सरकार की बायो E3 नीति के
अपनी पूर्ण निष्ठा और प्रतिबद्धता व्यक्त करते हैं।
प्रतिज्ञा व्यक्त करते हैं।
यह नीति एक रणनीतिक रूपरेखा है।
यह नीति एक रणनीतिक रूप है
जो एक सतत समावेशी एवं नवाचार आधारित जैव अर्थव्यवस्था के निर्माण हेतु पर्यावरणीय संरक्षण, आर्थिक अवसर और रोजगार सृजन को केंद्र में रखती है। अपने राज्य की वैज्ञानिक और सांस्कृतिक विशेषताओं तथा जैव संसाधनों की अपार संभावनाओं को पहचानते हुए हम इस नीति को नेतृत्व, समर्पण और सहयोग की भावना के साथ लागू करने की प्रतिज्ञा करते हैं। हम निम्नलिखित सिद्धांतों और प्राथमिकताओं का पालन करेंगे। जैव उत्पादों में नवाचार को प्रोत्साहित करेंगे, जिससे स्थानीय और राष्ट्रीय क्षमता का दोहन हो सके। जैव प्रौद्योगिकी नवाचार केंद्र स्थापित करेंगे जो पुनर्योजी और परिपत्र अर्थव्यवस्था को आगे बढ़ाएं। जैव निर्माण और औद्योगिक स्तर पर उत्पादन को क्षमता बनाएंगे ताकि स्वच्छ और सतत निर्माण हो सके। रोजगार सृजन और हरित कौशल का निर्माण विशेष रूप से अपशिष्ट को कम करने, पुनर्चक्रित करने और पुनः उपयोग करने के लिए जैव नीति और समानता को सुनिश्चित करेंगे, जिसमें सामुदायिक अधिकारों का सम्मान, जवाबदेह विज्ञान और न्यायपूर्ण परिवर्तन शामिल हैं। हम मानते हैं कि भविष्य एक ऐसी अर्थव्यवस्था में निहित है जो क्षय करने के बजाय पुनर्जीवित करती है, बहिष्कृत करने के बजाय सशक्त बनाती है, तथा प्रकृति के साथ सहसृजन के लिए भविष्य की प्रौद्योगिकों को अपनाती है। हम अपने राज्य और देश को एक ऐसी जैव अर्थव्यवस्था की ओर ले जाने का संकल्प लेते हैं, जो समावेशी जलवायु अनुकूल, नैतिक रूप से आधारित और वैश्विक रूप से प्रतिस्पर्धी हो। धन्यवाद।
We are honored to have in our presence today the champion of science and scientists in the country, Dr. Jitendra Singh Ji, Honorable Minister of State, Ministry of Science and Technology and Ministry of Earth Sciences, Minister of State, PMO, Ministry of Personnel, Public Grievance and Pensions, Department of Atomic Energy and Department of Space, Government of India. Over to you, sir.
Thank you, Secretary, Department of Biotechnology, Dr. Rajesh Gokhale, Dr. Alka Sharma, directors of the different institutes who have got connected to us right now. At the outset, I have to express my delight in being a part of the World Bioproduct Day commemoration, which is, as was being mentioned by the Secretary, is meant to celebrate the innovation, sustainability and the circularity of the bio-based products. But more than the subject of this, I am rather excited by the new methodology of this academics this morning, which is being practiced over here, and I'm sure it's going to be emulated by others as well. But I've myself been in the business of the academics for almost 3 to 4 decades. Yesterday I was in ICGEB, and the director, Dr. Mehti, told me that he had met me first time in 2008. So I said, I'm meeting you today. He said, no, you're the scientific chairman of one of the conferences, and I was invited as a faculty. So what I've been trying to say is that I'm quite ancient in this business, but in those days, of course, we didn't have these options. So it's a very beautiful hybrid model and a novel experiment spread over 8 hours, connecting 1 hour each to each of the centers that has been chosen, and it's also been very thoughtfully titled as Voices Across the Cities. And I was seeing the list of the cities very, I think, again, very diligently selected. You have from east Bhubaneswar, you have from north Mohali, Faridabad, Delhi, you have from south Hyderabad, Bengaluru, and you have like northeast Impal, and in the east you have Pune. And each one of them, as was being mentioned by Dr. Rajesh, is dwelling on exclusive themes like marine biomass, urban industrial waste, agri residues, etc. So which in a way also represents the diversity of India's bioresources as well as the potential diversity of the bioeconomy sources. So I think that's what in fact I was telling yesterday also. When we say the researchers from the West are coming to India, we take pride, but we don't realize they're coming for themselves, not for us, because we have there something to offer which they don't have. The other day we had a group of youngsters from one of the European countries. They wanted to do a health project. They asked me, sir, somebody referred them to me, and they said they sought my guidance. They asked me what disease should we work on. I said, you name the disease and I'll offer you one. So we have a wide variety, like a wide variety of seasons. You can experience a summer at the same time, also experience winter in one or the other part of the country. So I think that is a huge, huge resource, but unfortunately or incidentally, it was not being focused, it never occurred to our priority. And thanks to this government after 2014, because the Prime Minister's scientific bent of mind, and he also allowed us to proceed the manner in which we could proceed. That's how the Bio E3 policy, which Dr. Jitendra Kumar was mentioning, could see the light of the day, because Dr. Rajesh had to make repeated presentations, because this was something which doesn't occur very naturally to the political dispensation. But we could go ahead because the Prime Minister was forthcoming, and when we could put across this convincingly that it may not appear to be relevant today, but it will give us a leadership role tomorrow if we initiate ourselves early. So we are early birds in that, and so we got the okay, and that's how from just about 50 startups we are now almost 11,000. 10,000, so close to 11,000. So I think this is this a novel method of academy. We used to have breakfast meetings beginning at 7:30, but we didn't have this model. And I'm also glad that you have included students, startups, scholars, and industry leaders, which is most important. I've been always insisting that unless we have industry representatives, the exercise is only half done, because it's easy to start a startup, but difficult to keep it started. Midway it comes down. So to sustain it, you need early industry linkage in the form of not only technology partnership, but also financial partnership. Because technology partnership is sometimes doesn't sustain too much because it doesn't actually help them to make a long-term profit. And knowledge partnership is an alien concept in India, because I have worked across the world in all these different research groups. There, of course, there is an institutionalized knowledge partnership. Here it is not, because knowledge is given free of cost. You sit in any railway compartment, people will start talking to you about biotechnology. So the Gyan Bharna is not a and that doesn't pinch the business house. It starts pinching them. Even if you make them spend 100 rupees, they'll make sure that they get their back. And then that's how you sustain your project. And in fact, in most of our medical projects, we have done that. And I'm glad even here we follow the same pattern, whether it was nephritomycin. And we had a company which was actually at that point in time also looking for a launching pad where they were in the competitive market, they were not doing so well. So I'm glad that we have also moved on those lines. And BioRec, of course, is a success story in itself. I think the only other parallel, at least in the Indian context, was the in space. And this is a very institutionalized method of facilitating public-private participation. And as was being mentioned in his address, the biotech innovation and biotech manufacturing, which of course is also spread over biopharma, industrial biotech, agri-biotech. And agri is one area like health. Health, of course, we were there. We didn't. We were devoid of certain facilities till a few years ago, which are now available with us. That's how we've been able to make a mark in life sciences and also come out with cost-effective models of healthcare. In agriculture, unfortunately, we had a resource bigger than most of the other countries, but our priorities were determined by the Western data and the Western information. So we didn't have our own data. We didn't know. It's sometimes embarrassing to say that the entire GDP of India receives only about 14% of contribution of the agriculture sector, which should be other way around. And therefore, as I always say, actually what happened, the startup concept came from West, landed in Bengaluru. And that was an IT town. So everybody thought it's IT. It's not so at all. Our exclusive domain is agriculture. And therefore also I think we would have a lot of potential to explore, even from the point of view of generating bioeconomy, which also, and now we've already, at least now we are on the track. We were $10 billion about 10 years back. Today we are around 170 billion. So it's a huge jump to that extent. And of course, the BioE3 policy, as was being mentioned by Dr. Gokhale, and it would actually become a part of the entire ecosystem. So you have a BioE3 policy, you have the NRF, which has been given the Indian context name as Anusandhan, and you recently had the cabinet decision of allocating 1 lakh crore fund for research, R&D and innovation. So all these combined together, and if you look with a wider vision, it also would, some extent in that spectrum, include the NEP 2020. So that's why I said we need to have a larger integration, not confined only to the science ministry and science departments, so extra science integration, and then extra, which would mean beyond government, whole of nation, or which would also involve the private sector to engage. And when I mentioned NEP 20, actually this is not much talked about, not much realized, because most of us are not used to it. We've not experienced the value, the luxury of the NEP 2020. And those who are getting into this don't know how it was earlier. So going by the, everlasting theory, Einstein's relativity, we are not able to relate and they are not able to relate because they have not seen. And the easiest way for the students of biotechnology is that when your parents put you in class 12 with the bio subjects, they didn't want you to become scientists under Dr. Gokhale. I'm sure. I was saying that in the college also. You go home and ask. They put you there because they want you to be doctors and make a good fortune out of it. Have 2, 3 big cars and a big bungalow and etc., and earn good money. But once you got into this, and unfortunately, if you didn't get actually into a medical school, you became prisoner of those subjects. And now you are there, neither your choice nor your parents' choice. Your parents had put you with a limited choice, and this is something the youngsters have to share with the others. Your parents put you for some other reasons. They were not worried about your aptitude possible. They wanted you to be at good faith. I mean, you can't grudge them. Every parent would like that. They wanted you to settle well in life. They wanted you to be good practitioners of medicine. Somehow their desire remain unfulfilled. Now you realize, okay, it's not that. Let me then go in for something else. Let me go in for agri-science or even literature. But no, I can't. So now the course that was left was neither your parents nor yours. So everything happening by default. So the NEP 2020 is going to be a great game changer because this will give you people with aptitudes, scholars, and that's why of late the level, the caliber of the new, scholars joining us, the new boys and girls, is relatively better because earlier they were by default. They were there because they were pushed into being there. See, then they had to do graduation. They had to do graduation again in biology or some botany, something. Then they tried civil services, couldn't do that. Then they did post-graduation again, one of the 2 subjects, botany or zoology. Then after that, they tried some teaching job. They couldn't that. Finally, they did PhD. Then where to go? Go to Dr. Gokhale. But now it's not that. We have boys and girls who actually have an aptitude and who also have the temperament and capacity to learn, and they are good learners. So I think this is now one of the best times happening. And since it's always said that the next industrial revolution is going to be bioeconomy driven, it's heartening to see that India has already taken a lead. And I think we have also the challenge and an opportunity to create a green industrial ecosystem with all those factors that I have tried to briefly spell out, because otherwise we can go on and on. And that would also require creating awareness. And that's why I've been suggesting you have to reach out to the stakeholders in the language they understand, through the means that they understand. I hope I'm trying to make my point. So that's why I said, please make your social handles strong. Sometimes we think it's not like that. So, and you have a beautiful technology options now. So small jingles, small success stories, and what all is there. And please link it with the profitability, because that is how you will be able to attract the young scholars with aptitude and interest. Don't sermonize too much into academics. I mean, I've been myself a teacher for more than a quarter of a century. That's why I'm saying, if you sermonize it, you will not be able to attract them, because at the end of the day, they are children of the same society. So you have a good startup, you try to, give him the high virtues and morals of a very big research project. And after having spent 6 months in your lab, when he finds one of his classmates in the high school is running a BMW, he says, hell with your startup, I better do what he's doing. So, because this is all multifactorial, your career outcomes, even your death is multifactorial. So you have to create a milieu where your young scholar, young student, does not have this feeling of, that if I was not here, I could have been better. Because at the end of the day, he has to have that comfort zone to add value to the work that he is doing. So I think this kind of program, the World Bioproduct Day, could be also one of the you know messages and also one of the means to retreat ourselves and to recommit ourselves to this cause. And in a way, it is also our opportunity for all of us, those who are no longer students, that we have been given to experiment with a new kind of mentorship, which was not possible earlier, because maybe one generation earlier you didn't have this means of mentoring. So you can now sit at home and mentor people across the world. So with these few words, I must again compliment the entire biotechnology community of the country. In fact, it is something which is not should not be confined only to the scholars of biotechnology. Each and every Indian needs to have a biotechnology bent of mind if he has to extract something from it, whether it's a farmer, whether it's an agriculturist, whoever sitting wherever, because it's all over around us in one way or the other, whether we are in the business of being fishermen, whether we are in the Himalayas trying to look for herbs. So I think that is the spirit, that each citizen realizes that I am a stakeholder, I am a biotechnologist in myself. I don't need to have a degree. And we have proved that so many of our bio startups, particularly in the CSIR lavender projects, many of them are not even graduates. So I think that connection, and I'm sure this experiment which BIREC has done today of this circulating among cities would next time also involve the other stakeholders. So we let them talk. Let somebody from Bhubaneswar talk how they have, not necessarily the scientists, because you can't. And I hope every time don't leave all the talks to the scientists. Let non-scientists talk to scientists to tell us what is new for us that we should know and what is to be expected from us. Because otherwise, if we keep talking to each other, this is self-limiting. As Francis Bacon once said that the greatest harm to the cause of literature is done by the teachers of literature. So let the youngsters talk. Let that one session be like that. So you can keep changing the format of the session. One left only to the young students. They can talk to us. They can tell us what they want and what they want to add to us and what they want from us. Then another session could be of the stakeholders, farmers, those working in the marine areas, like that. So, and we can also then, make this more regular, institutionalized method of communicating with each other. So I must once again compliment you. You are initiating also a new medium of academics, besides, of course, biotechnology. Thank you.
Thank you, sir.
So now we have thematic talks from different innovators. The first one could be, yeah, please. All innovators and industry people, please come for a picture.
No, this was used in operations in Dur. But if you want to sustain it, you can't depend on operations in Dur, because then you will have to pray for operations in Dur happening every day. You should publicize this as a household kit, like you used to have Band-Aid or something. So this could be a part of the household medical kit, and it could be, in every house, every family. So that's how, because it's a homeostatic spoil. So I think we can promote it like that.
And I have made a biostar that is a replacement of charcoal, which we use in water purifier. So the difference between charcoal and biochar.
So students start. Students.
Yes, I was in BSc when I got my fund from Bioproduct. So Bioproduct has helped me a lot in making this kind of project, and they have supported me on every part of the project when I was stuck somewhere. So I have came up with this idea of utilizing the waste materials. I have made this biochar utilizing orange peel, which we just threw out. use them?
There is a group who have been guided by one of the scientists who was earlier working at the so they have taken this up as a vocation.
Needy, no? Needy.
No, not needy. This is a private.
That's a private.
I have engaged them for a pilot project in my course. So I said, you do in one of my biochar. And if it, proves to be successful, then we can also replicate it in other towns. So it could be in association with the municipal committees and corporations for both the sewage clearance as well as generating the circulation. So this could be a larger cost. But anyway, show that you are initiating yourself.
So main purpose was to absorb heavy metals. Thanks.
Sugar alternation.
Have you done some trials? Where? Not in the government. Whenever you place it there, people are looking for sugar alternatives. Fashion to carry it in the person. But what happens is that some other rival group will suddenly, go to the commercializing. We have seen all the time. So get it validated. The easiest way is you can have a GTP test done. You can have a GTP test done on a normal individual, in groups, and see the results. If you get it validated, then you make yourself secure from any possibility of controversies. Because what happens is nobody else will bother you. People will fight because they are looking for it and they say, it's a very big fashion. But one of your rival groups will create problem.
You have done before problem test.
You done. But from an
institution.
I neither take sugar nor sugar free. So you won't have I know. You can also give the merits of this being fiber rich.
So from Bangladesh, so I'm actually sugar producer the other side of so the new industry was made in that 50% project substitute production ratio to make bioplastic. Actually, we are working towards market creation and that's the biggest
I'm carried with me.
Meat as well.
Where the industry?
Where are you?
Based out of Uttar Pradesh.
Which town?
Balrampur, Lakhimpur, Gonda, yes, many same place.
And which is the industry you are linked to?
Sugar and ethanol were the largest producers of bioethanol in the country as well. We will be the first producer of bioplastic at an industrial scale. I think one of the first industrial scale projects will probably qualify under bioindustry. And we are going to be commissioning next year to be a world first in this. The whole project is powered only by renewable energy, which is also bio-based. And the whole project is first time in the world going from sugarcane to clear.
I don't think I'm going to hurt myself that. Thank you. I will spend some longer time with you. So how many of them were there?
We all are. I can't present my bioreactors because they are very large in size. There was the world's largest bioreactor.
Bangalore and Hyderabad have the ecosystem, so that's an advantage. 25 to 60% of the startups are coming from tier 2 or tier 3, means that the urge is there, the potential is there. We are not able to find that kind of people. So we'll have to get what they are
Growing some very
low.
very fast. They have in Mumbai. So here's the concept which we are experimenting with. Mid-size and good-size biotech companies in India should mentor 10, 15, 20 startups and help them to R&D quality.
That's exactly what I was saying.
We are doing that.
Yeah, they should rather also invest. Yes. And then it could be a business. They probably could become part of your team. They can be part of your team. You can mentor them your own way. So they also find a livelihood. You also find the employees as well of your.
Sir, I am one of the student innovators and I have built a carbon capture system which is low externalized and SO2 PM2.5 It's different from like traditional air purifiers and from fish because it uses carbon and CO2, which air purifiers are the good. And it is also like more better from trees because like what device we have built, it is as good as 15 tall trees and it is just the size of this 5 feet tree. Okay, it uses microalgae for sequestration purposes. And the design we have built it prevents biofilming of the product. So we are planning to do this, trying to install this on metro pillars and areas where trees cannot conceive.
Also, what is that? It's going to be a pollution.
Yeah.
Yeah.
That gave us a good
Have you got connected with these concerned
So I think they can convert the energy into the so biomass which is collected can also be used as nutritional component and appropriate another biofertilizers.
That is what is there.
Yeah, that is what is
there. But what is there? Going up that also. The both will be there.
Yeah. Yeah. And then you work as well.
Thank you for thinking of the students. I feel very young all because I'm not as young as I was. I'm a mother. I know 10, 15. Sometimes
The first talk is from Dr. Shirish Arya, co-founder ImmunoAct, and the topic of the talk is emerging areas emerging areas of cell and gene therapy and its urgent need and relevance for Bharat. Over to Dr. Shirish Arya. Yeah.
Yeah.
Can we have his presentation on the screen, please?
Good morning, everyone. Dignitaries, ladies and gentlemen, joining online and physically present over here. Thanks for giving us the opportunity. This presentation originally was supposed to be presented by Dr. Rahul Purvar, my colleague, but here I am, Shirish Arya, co-founder and director commercial here at Immunoact. Dr. Rahul could not attend because of some family issues. I just wanted to take you all through the journey of the India's first indigenously developed cell and gene therapy, from the discovery to the access that it currently provides. And the high point of this was the inauguration of the NextCar 19, our first product, which was done by the Honorable President. And this is the entire team. Next slide. Next slide. Next slide, please. All right. So, so I just wanted to cover why something like a CAR-T therapy or a cell and gene therapy in general is important, and what is its impact on the society overall. So we've seen a lot of drugs which come, you know, and they typically come from US or any other developed market, and then they come to India. And there's typically a 10-year lag, right? And the photo below shows you some of the examples like brentuximab. You know, when India won the first World Cup in 2011, and then 2014 when Rohit Sharma was there. So it's like a 10 to 12 years, just to give you an analogy of how long a drug introduction in India takes, and that's a big lag. So it is extremely important, like Honorable Minister was also saying, that we need to have an ecosystem, and we need to have a way in which we can develop some of these technologies, some of these products indigenously. So that the cost can be brought down. They are scalable. Their efficacy and safety is at par with the global products, and we are able to solve many of the problems. Cell and gene therapy in general have a tremendous potential, not only for oncology and disease and curing some of the very difficult to cure cancers, but also in autoimmune disorders, cardiac, and many other similar applications. We have launched this product at $30,000 in India, which is the cheapest, almost 90% less cost than what it is in the US. And recently our data was published in the Lancet Hematology as well. Of course, this was not an easy journey, right? There were many partners who were part of this growth. IIT Bombay, of course, where this research, some of the preclinical design work was done. Tata Memorial Center, where the clinical R&D was done. NCI, NIH USA, which was a knowledge partner, and BIRAC, which helped us do the clinical scale-up of this. Today, I'm very happy to report that we have created a major impact on the society, and almost 400 patients have been treated so far across 70 hospitals across the country. And the access has been provided to a very large economic strata across the country. So it's a fairly large journey from its preclinical development in 2012 at IIT, and then going on to now monthly treating 30 to 50 patients per month. And we are future ready. We are scaling up our capacities. We are scaling up our ability to produce more CAR-Ts, and not just for India, but also for the world. We are in advanced talks with multiple countries in that sense. Lastly, this is very early stage in cell and gene therapy. There is a tremendous amount of technology innovation that is yet to come, and we want to be part of that innovation. These are very early days. Despite its initial success, we are working on in vivo CAR-Ts. We are working on new applications for the CAR-T, whether it's sickle cell disease, and the Prime Minister, Honorable Prime Minister, has a sickle cell disease mission, which we want to be part of using this technology, thalassemia, hemophilia, and many other diseases with a very, very serious ailments in our country. So these are some of the opportunities that we are working on. That's largely from my side. Thank you very much.
Thank you, Dr. Shishir. So the next presentation is from Dr. Ravi Chandra Bira, founder Revelations Biotech. He'll be talking about FOS, which is the world's best prebiotic sugar alternative, indigenously developed and is cost effective. Over to Dr. Ravi. Can we have his presentation on the screen?
Good morning, everybody. So I'm going to talk about FOS Life, which is a prebiotic sugar replacer. So sugar pandemic is one of the major global problem that every food company or every country is fighting. Sugar is a necessary evil. It is there everywhere. It's cheap, ubiquitous, and it is extremely difficult for the food companies to develop a food formulation without using the sugar. So that is the problem. We cannot live without sugar, but then when we live with the sugar, there are a whole lot of problems, encompassing the metabolic syndrome. There are some chemical alternatives which are there for sugar, but then did not provide all the physical properties. Taste is a problem, and most of the chemical alternatives are linked to cancer. And natural alternatives are rare, costly, and very hard to scale. This is where the problem. And Revelations as a company has been working on sugar alternatives for many years, and we have come up with some interesting solutions. So the first solution that we're talking about is the FOS Life, that is nothing but fructooligosaccharides. These are chains of fructans with a terminal glucose. So what happens is we begin with sugar and we enzymatically convert sugar into these prebiotic chains. So when sugar is a negative ingredient, interestingly, the FOS, fructooligosaccharides, becomes a positive ingredient, which means, well, sugar is going to negatively impact the health, FOS is going to positively impact the health. So an interesting fact is that when we use a sugar alternative, when we eat sugar, we do not eat sugar just because it provides the sweetness. Sugar provides whole lot of physical properties like soluble binding ability, then the free bulking ability, moisture retention, flavor delivery, etc., etc. So all these properties are extremely important in the food matrix. Most of the sugar alternatives do not have these kind of physical properties. That's where they cannot be effectively used in food matrix. What it means is when people use the intense sugar alternatives like stevia, sucralose, or aspartame, they will have to naturally bring in a bulking agent like maltodextrins and all, which are even more bad in terms of rising the glycemic index and impacting the health. This is where fructooligosaccharides play an important role while providing the sweetness, while providing all the right physical properties which are very similar or better than sugar. And then additionally, they provide a host of health benefits like low glycemic index, anti-diabetic effect, low calories, and a great dietary fiber effect, prebiotic effect, and they support mineral absorption and lipid metabolism. So these are all non-carcinogenic. These are all clinically proven benefits that FOS offers. So this is where we have a great value proposition. Well, sugar continues to be grown and made in India. We can convert good amount of that into FOS, and then we can really have a positive impact on lives of people. So these are all the applications where sugar can be, where FOS can be used. Wherever sugar goes, the whole list of like cookies, biscuits, granola, infant formulas, peanut butter, water, jam, jellies, wherever Indian sweets, wherever sugar goes, FOS can very nicely replace these things, and consumers will not even feel any difference in taste compared to sugar, because this product tastes very similar to sugar or honey. So what is that we are bringing to the table? We have created a disruptive innovation where traditionally this is a very lengthy process of 48 hours from sugar to the FOS enzymatic process, and from sugar to the final product it is about 5 to 6 days process. What we have done is we created an enzyme technology by which we can really do this thing in half an hour. From sugar to FOS we can just reach to the FOS in half an hour, and from sugar to the final finished product we can just achieve it within 1 hour time. What it means is unbelievable scalability. Sugar goes into the plant, gets converted into FOS, and comes out within 2 hours. This is the rapid speed at which we are scaling up. Right now we have about 10,000 metric tons, and with the support of Bioproduct, we are going to take it to 30,000 metric tons in next 1 year time. These are all the applications where the companies who are using my product in their food matrix. These are some of the examples. Cereals, you can see a lot of examples. So the Sofit is a Hershey's product. They have been using it. So it takes a lot of time for these companies to try and just test this ingredient to replace the sugar. It takes typically anywhere between 1 year to 3 years. And they have done, all these companies have done these trials for about 3 years, and then they have successfully replaced sugar in their products with Phos Life. So these are all F&B products. So this is the Mercedes ice cream, one of the largest ice cream manufacturers in South India. So they across all the range of ice creams, they have replaced sugar with Phos Life. These are gummies and Chyawanprash. And this is the retail product that we have recently launched as a tabletop sweetener. So what it means is people can get the same feeling like that of eating sugar, but then the product will not get into the bloodstream. And then this product, when it reaches colon or intestines, it exerts a good prebiotic effect. This is available on Amazon, Flipkart, and all quick commerce as well now. So these are all clients currently who are using this product. So these are the images of our plant. So we are not stopping here with Phos alone, which is a sweet fiber, a sweet prebiotic fiber. We have already developed and scaled up a protein called brazin, which is about 1200 times sweeter than sugar. We have made it in a few hundreds of kilograms scale, and we are scaling it up to a few tons now. Isomorphose is a weight loss sugar. It is the isomer of sugar, but then it's clinically proven to bring down the weight and impact fat oxidation. We also have a zero calorie rare sugar called allulose. We have developed all these processes because when you actually look closely into the food matrix, different food applications needs different kind of ingredients. So our product range is always all about bringing down the sugar and improving the health quotient. So all these products are at some stage. Phosphate is already commercialized. Brazil will be commercialized in next 6 months. Isomorphose will be commercialized in another 3 months. Allulose will take about a year for us. So this is all about Revelation's efforts in bringing down the sugar and fighting the sugar pandemic. Thank you very much.
Thank you, Dr. Ravi. We'll move to the next presentation from Dr. Praveen Kumar, who's founder KCAT Enzymatics. He will talk about the enzyme technologies that they've developed for industrial, medical, and environmental challenges. And they've been incubated at the Bangalore Bioinnovation Center, which is supported by BIRAC. Over to you.
Thank you so much. First of all, I would like to thank the government of India for such a wonderful initiative. I'm very excited. I think sky is going to be the limit now. Dignitaries on and off the dais, thank you so much for giving this opportunity. We are a group of scientists who are fascinated about protein design. I think this is the best time in history to talk about protein design because it received the Nobel Prize in 2024. And we are a group who engineer enzymes for biocatalysis and therapeutics. Biocatalysis is a process of making chemical entities using enzymes as catalysts. Unlike most of the pharmaceutical, nutraceutical, and agrochemical companies make their chemical entities using chemical catalysts and chemical processes, which are hazardous, not good for the environment. Chemical processes does not give good yield, and they are not good in making chiral molecules. On the other hand, enzymes are natural. They give excellent yield. They are cost effective, and they are champions in making chiral molecules. However, the very moment you take an enzyme from a living system and put it in a bioreactor for producing a pharmaceutical molecule for a specific cost window, these enzymes don't work. One of the formidable challenges in science today is engineering enzymes. That's why you have a handful of companies across the globe who work on this process because there are many failure rates. Towards this end, we have developed a technology called as 7D grid AI technology, which is very efficient in engineering enzymes. Using this, we have developed enzymes for making anti-Parkinson's drug, anti-diabetic drug, anti-epileptic drug in a very cost-effective and eco-friendly manner. Apart from that, we also developed enzymes for fluorination. Any material that you use and most of the pharmaceutical molecules are made up of fluorinated molecules. How does chemists make them? Chemists make them using harsh chemicals. They themselves call that we use dirty chemistry to make fluorine molecules. But we have the first in the world to make enzyme which can fluorinate molecules. Apart from that, we also have developed enzymes for therapeutics. We have developed enzyme which can be used as treatment for inborn error, metabolic disorder, and enzymes for as antibiotics or antibacterial agents. Apart from that, we have developed a machinery of proteins along with that enzymes which can make ultra pure RNA, which means you have RNA, extremely pure RNA without any side effects, which can be used as vaccines. Putting all these products together and a couple of other products in the next year in our company, we want to make India the hub for specialty enzymes because it is completely monopolized, and we want to break this monopoly and make India the hub for specialty enzymes. Developing eco-friendly processes in this part of the globe, we want to extend our arms across the globe and make this world sustainable and resilient future. Thank you so much for the opportunity.
Thank you, Dr. Praveen. Next speaker is Dr. Vivek Mishra, founder and CEO of FibroHeal Wound Care. They've developed a product called Fibroplug, which is innovative topical hemostat. Dr. Vivek Mishra, over to you.
Good morning, everyone. Thank you, Bioproduct TBT, Rajesh sir, Jitendra sir, and the whole dignitaries for having me here to express the journey on this wonderful World Bioproducts Day 2025. We have always been supported by various schemes from DBT, Bioproduct, and others, and we are proud that we have been able to translate an idea, concept into a product and bring it to the market. As a company, we work around wounds to heal various types of acute, chronic, traumatic, post-operative, and hemostatic wounds. And Fibroplug was one spin-off where we realized that we don't have a product addressing to blood clotting coagulation area. India imports most of it at a very, very high, very, very high prices. And one challenge that was CRPF Grand Challenge in 2019 gave birth to this idea, which was later, we formed a collaboration with Indian Institute of Science, Bangalore, supported a student under PMRF, Prime Minister Research Fellowship, and we got a patent on that. And finally, the product was commercialized in 2024 during Global Bio India. The crisis we face today is 17 deaths happens every day on Indian roads, Delhi and Chennai leading it. That's a huge number. And most of the cases, hypovolemic shock, the loss of blood is one of the biggest challenges. And bleeding can be prevented with some efforts. And this was the thought process with which we came forward and Fibroplug was born. Next slide, please. What is the science behind Fibroplug? So it's a silk chitosan composite, 3-layered system, where you have a layer of silica, which acts as the first step to deliver the charge and triggers the coagulation cascade, followed by chitosan, which is able to hold, which has mucoadhesive property and able to hold, weight up to 20 times its weight, and silk, which acts as a non-adherent layer. So ease of removal and cascade don't get dislodged. And this is used from few minutes to few hours till the patient is stabilized. So if you are able to prevent the bleeding, you can save the life. That itself, with that concept, we move forward. Next. Next. Yeah. I've just given one real life impact. There are many images, but you see this is a case where the finger is chopped on the left hand image and right hand Fibroplug is used. Within 40 seconds, blood was coagulated. And these are some of the clinical data what we found out over a period during the clinical setting when we worked around. Next. The journey, what I mentioned, was 18-19 during CRPF Grand Challenge. FibroHeal participated. We were runner. We did not win it, but the interactions gave a lot of insights, and that led to this. And this is an image taken during Global Bio India 2023 when we formally introduced the product. Next. I'm also proud to share that during recent conflicts, we supported the country So the support what we got from various government settings, including BIREC, TBT, and various other people, we were able to, we feel proud that we are able to do something for the country from the money we received. And these are some of the images what we realized. We were doing it in silence, but people came to know good work never, good work comes to the surface. People got to know, and these are some of the examples. When the product was launched, I mean, CNN and everyone came to our factory, and it was a different thing to deal with. But yes, I mean, it's a happy problem, and we supported more than 16 defense hospitals across western and northern borders during the time of need. Next. So coming to, for a product which is coming from farmers, we have been discussing about circular economy, regeneration, repurposing since morning. We took a pledge also. This is a live case of circular economy. Chitosan is produced by people living in the coastal areas. Silk is produced by the farmers. So we are impacting the life of the farmers. We are impacting the life of the clinicians by making products which are able to arrest bleeding quickly, able to help them recover the patients fast, and in the meantime, it's completely biodegradable. It hits the sustainability and ESG goals what we are looking at. So these are some of the ranges what we have based on the type of injuries. Next. This is the patent. The patent is jointly owned by Fibrohil and Indian Institute of Science, Bangalore. These are the range what we have tailored for bleeding emergency based on the conditions. If it's a gunshot injury, it's different. If it's an accidental, it's different. If it's a bomb blast, it's different. And if it's a normal cut wound or first aid, it's different. Next. Now coming to our 1 cent in the area of economy, environment, and employment, what we have been discussing. So economic part, we are able to reduce the import dependency by giving a quality product which, if not overshoots the current import substitution, it matches the import substitution. It reduces healthcare cost, and it has potential to be exported to various countries. Environmentally, it's a completely natural biomaterial which is biodegradable and sustainable manufacturing processes, and able to generate employment. We are discussing about various students who are participating in the things. We are able to create support the workforce, who are being educated in this biotech workspace. Indian R&D able to generate a lot of research and manufacturing jobs, and able to develop the skill sets for the people also in the process. Next. So this is 30 seconds video. I would request you to play this video, please. So with this, thank you very much. Thank you for all the support, and we look forward to contribute support and create an impact. Thank you.
Thank you, Dr. Vivek. Next, we move on to the talk from Mr. Ravindra Patel, who's founder of Omni BRX. They've been developing novel single-use bioreactor technology platform for production of vaccines, biologics, and stem cell therapies with overall reduction of cost and time of process development. Over to Mr. Ravindra Patel.
That's the one. Absolutely. Yes. So I'll quickly jump directly, not head down, but yeah, okay. Thank you. Thank you for inviting us, and listening the OmniBRX voice on the bioethics policies and on the auspicious day of World Bioproduct Day. Sorry. So a little bit about OmniBRX. We are a bioprocess technology development company incorporated in June 2016. Mainly focused on developing novel technologies in the bioprocessing, mainly the single-use bioreactors for vaccines, viral vectors, and biologics, including monoclonal antibodies. As of now, we have 19 patent applications has been submitted, and 12 of them are granted. We are backed by BIRAC and supported by BIRAC DBT in multiple ways. Like we started our journey with BIG grant for our 5-liter cell BRX product development, and then we also got some funding from TIFAC, DST. Then again, 2 NBM grant has been awarded for developing bioreactor products in the field of vaccines, viral vectors, and MAPs. And then a couple of more investments and funds we received in the arena of 5-6 years. Our installation base is like almost 80, more than 80 installations. Most of them are national installations, but we do have some installations in US, Korea, Japan, and other countries as well. Our manufacturing plant is in Ahmedabad, Gujarat, and we have a full-fledged cell culture R&D laboratory also in the area of Saltage in Ahmedabad. So anyone from the audience can always welcome to visit our facility and use our facility as well anytime. As a product segment, we have a mainstream which is adherent cell culture bioreactor platforms called CellBRX, which is again single-use bioreactor platforms for vaccines, viral vector production, stem cells, and exosome production as well. And few of the hormones can also be produced. So anything you want to produce using adherent cell culture, you can produce it by CellBRX. In fact, this is the world's largest bioreactor systems available on the planet Earth, with 1,500 meters square of surface area. That's a huge surface area, right? Another product line which we have is the suspension cell line bioreactors, which are mainly for MABs development, manufacturing of biosimilars. Even the CAR-T and CAR-NK cells can also be expanded in the mini BRX single-use third tank bioreactors with its novel proprietary impeller systems, which we have developed. Both of these products are being helped and supported by BIRAC through MBM projects, and we are very happy to share that. Now, we converted that CellBRX product into a IST platform. What it means is it's the world's first integrated, automated, and closed loop manufacturing platform for viral vectors and vaccines. So there is no open interventions, after inoculating the vial in the first reactor to the harvesting the final production bioreactor, having a vaccine bulk in these kind of bioreactor train. The mini BRX 250 ml single-use bioreactor system is a high-throughput platform for process development and optimization of bioprocesses like the MAB development, biosimilar developments, and all. It has 8 parallel reactors independently controlled for fed batch and profusion bioprocessing. You can get more information of all these products on our website. As a product launch pad, I would also like to brief you about the STIR-BRX products which are coming in 2026, which will be the world's largest bioreactor platform for suspension cell lines as well, with our novel impeller systems, our proprietary patent pending impeller systems. We will be also we are also working on a kind of biomanufacturing platform called multi-BRX. Again, the world's first kind of wild to harvest biomanufacturing thing, which is having a patent backing, and also plan to launch in 2027. With our cell culture R&D lab, we are already supporting 4 Indian startups to develop their processes, and so we are working with in their collaboration. We are just helping without any monetary advantages, and we are helping them to scale up their processes in our proprietary bioreactor platforms and all. And the final goal is to also have digital twins available in the open access market, so that the academics and industry can simulate that bioprocesses in the software itself before actual experimentation in the lab bench. By 2027, we will be having that platform ready for all of our bioreactor systems. Now, how OmniBRX gets aligned with the Bio3 policy, right? So, in the front of economy contribution, we have developed and we are developing innovative biomanufacturing platforms that increase the production efficiency of the bioprocesses. We have significantly reduced the import substitution of these capex and opex of the bioreactor and bioprocess technologies, mainly coming from US and Europe. And scale-up services are also being offered as a very, very economical rate. Environment, yes, since it's a single-use technologies, we save a lot of water and steam in the biomanufacturing plants. No SIP, CIP is required for these kind of technologies. We can save up to 90% of 94% of plastics and reduce the plastic uses for vaccine manufacturing if someone wants to use the large-scale cell bioreactor platforms, right? So it's a huge plastic reduction as well for the environment safe. On the part of employment, if our proposed biomanufacturing facility and our expansion facility for single-use bioreactor manufacturing happens, by that we will be having more than 200 skilled jobs being created in the field of biotechnology. We will be also launching some special training programs and workshops specially focused on bioreactor-based biomanufacturing with our state-of-the-art cell culture laboratory in Ahmedabad. And we will be having some great collaborations with the institutes and academics as well on that front. Where we are going, it's the last slide. We are expanding our Make in India disposable single-use bioreactor manufacturing site in Gujarat, in Ahmedabad. We are also developing and commercializing new novel kind of bioprocessing technologies for low-cost, scale-efficient biomanufacturing. And we are also gearing up, we are also preparing ourselves to establish the world's first 100% paperless next generation biomanufacturing facility using our innovative biomanufacturing platforms powered by indigenous products from India. And that aligns the self-reliant biotech mission, Bio3 mission of Atmanirbhar Bharat. And that is being driven, and the ultimate goal of doing that is to provide absolute transparency to the clients and to the users and to the consumer of the product, which the biomanufacturing will be taking place. And the data integrity is also something very important point which we want to emphasize in that biomanufacturing facility. So to meet the Bio3 mandate of ours, we need biomanufacturing that is agile, that is sustainable and affordable at large scale. Right? Yeah. So thank you so much for listening to us. And
thank you, Mr. Patel. Now I would like to invite Dr. Vishal Varke, who's Director R&D, Cell Biology and Hydroponics at High Media. He'll talk about the affordable serum-free chemically defined media and feed supplements that they've developed for therapeutic proteins. Over to Dr. Vishal.
Thank you very much for the kind invitation to present information and data here. So the grant that we received from DBT and BM was to develop chemically defined serum-free media for biosimilar production. And this was a seed grant that gave us a big boost. And using this, we developed the media and we have developed platforms. And this is what I'm going to also showcase as I move forward. So as you can see, I have underlined CDSFM is chemically defined serum-free media. That's for biosimilars and mAb production. But inadvertently, and as a part of this, we were also able to work on vaccines. And we have developed some media for vaccines which are serum-free. I will touch upon that. And cultivated meat. So we are touching two areas. I'll just quickly go over the history of the company just to give you a brief idea, and then I will again resume the talk. So we are over 50 years old. and we are amongst the top 3 media manufacturers in the world. And we have a 60 to 100 ton per day manufacturing capacity. This is way too big than what is expected right now. But we just realized that unless we have scale in this country, we cannot compete with China, because most business was being taken, and it is being taken away by China because they have scale of operations. And it's a chicken and egg story. So one has to first take the leap and put the scale. So we have done that. And we have more than 30,000 SKUs. So 6 thrust areas, everybody knows. Area number 2 and 3, I'm going to touch upon. 3 is precision biotherapeutics. That was the grant we got to develop serum-free media for biosimilars. But in doing that, we have very well positioned ourselves with functional foods and smart proteins. So the problem statement is there was a need for affordable, there is a need for affordable large molecule biotherapeutics, MABs and others for cancer, other life-threatening and chronic ailments. There are myriads of large molecules that have to be made affordably. This is the biggest challenge. Once the capex is taken care of, the operating costs are what pinch. In the operating costs, primarily you have the resin and the media. The resin you can use 100 times, so the cost comes down. Media is used once. And to really get a very high yield, you need to use perfusion. As Ravi Bhai also has shown, perfusion-based technologies are needed. But in perfusion, there is one caveat. The tap is on at both ends. From one side, the media is flowing in. From the other side, the media is going down the drain continuously, 60 days, 90 days, whatever be your period of perfusion. And that hurts because these media are very expensive. So a lot of people cannot afford to use perfusion as a technology because the media is very expensive. So what we have done here is, the problem statement again, there is a severe dependence on foreign companies for cell culture media. And during COVID, we know for HEK 293, we weren't given the media. So we struggled at that time. So now with the platform that we have for CHO cells, we have prepared, and for vaccines, all these different cell types, the media is under progress, and BHK 21 is ready. Production scale constraints, again, I mentioned that affordability can come with very large scale, bulk scale. For example, in China, you have amino acid plants that make 100 tons of a single amino acid per day. So 100 tons of an amino acid per day, you can imagine what the scale is. Only one amino acid. And these plants will make only 2 or 3 amino acids, not more. And because of that economy of scale, they are able to crash the price and control the market. Even the other countries are buying from China and then selling all over the world, putting their own label on it. So this is a problem. So we thought we will address this, and the scale is there. And what has happened is we have developed a broad developmental platform. So once the platform or process is ready, it can be replicated for multiple applications. And one very important example is smart protein. So because of the NBM BIRAC grant, we set up these platforms. Do I have a minute or two? I'll quickly run through it. It's okay? Okay. I'll summarize. Sure. So this is the media that we have developed. Developmental platform along with the media. We have now also the clones. We have started developing clones in-house. Pembrolizumab, daratumab. All the infrastructure, bioreactors up to 50 liter. Then there's the analytical platform, which can do proteomics, metabolomics, and all kind of analytics. I'll quickly run over it. All machines. There is a UHRMS also. A production platform. As I mentioned, the large scale and 60 tons per day. This is a US FDA compliant plant, and I'm on my last slide, almost second last slide. So can you please play this video? This is a, sorry, yeah, it's embedded in there. Volume. Volume. So a part of the BIRAC grant, NBM grant, was also used to build this facility. No, the video can play.
Next. So this is the last slide. What I want to say here is that with the smart proteins coming up, if we need to replace meat and create functional foods and smart protein, we need large volumes. And we have actually today a media that is approved by US FDA with a food master file, FMF 1002 number. This is an Australian company, Wow Foods, that is using our media for quail meat. And it has been approved by Australian FDA and other FDAs. And one company needs 20,000 tons per annum. So this is the kind, because it is, if it is food, then you need to have it in bulk.
Dr. Vishal, sorry. Yes, sorry to interrupt. We have other speakers waiting and we have a whole day program, so we have to.
Okay, this is absolutely the last, because what I'm saying is all these can be now developed using the platform. And thank you very much. Sorry.
Yeah, thank you. Thank you so much. Next speaker is Ms. Avantika Saragoi, and she will speak about the bioethanol and PLA plastics that they will. Over to her.
Thank you so much. I promise to keep it extremely short and save you some time. So good morning, everybody. I don't have a presentation, which also helps. Good morning, Secretary Sir. Good morning, all the esteemed dignitaries here and fellow bioeconomists. I speak today on behalf of Balrampur Chini Mills, a company which is deeply rooted in the agricultural economy and now is at the forefront of India's bioeconomy. For 5 decades, we have supported 5.5 lakh farmers across Uttar Pradesh, operating 10 of our integrated sugar units. But in recent years, we've been deliberately shifting from not just being a sugar producer to becoming a driver of green industrial transformation. Let me begin with bioethanol. It is a pillar of India's energy transition, and at Balrampur, we are proud to contribute meaningfully to the Government of India's ethanol blending program. With a capacity of 1,050 KL per day, we are the largest producers of bioethanol in the country, and we help reduce crude oil imports and also directly benefit the farming community via this. We save about $5 billion US in forex, and we save about 20 million tons of CO2 emissions annually as a contributor into the bioethanol ecosystem. This has already proven how agro-based innovation can deliver energy independence, climate resilience, and rural prosperity all in one stroke. But we're not stopping here. We are now also moving into materials, biomaterials. And in 2024, we took a big, bold step and a big leap of faith into what we call Balrampur BioYug. This is our brand name for our PLA, which is a bioplastic, which we will produce from sugarcane in Uttar Pradesh as of 2026 end. It is a 2,850 crore investment in a single facility of 80,000 tons production per annum. We will also achieve 2 global firsts with this project. The first being that we will produce PLA directly from sugarcane in one facility. This has never happened in the world before. Every other producer is producing the bioplastic by buying sugar or buying lactic acid. We will go from sugarcane to PLA all in one place. The second global first is that we are completely powered by renewable energy, which is also bio-based. So we are going to be running the plant on bagasse and sugarcane and paddy trash. Why PLA? So PLA, of course, is 100% bio-based and 100% biocompostable material, and it can be used to replace a lot of single-use plastics which are currently even banned in India. So it is a perfect replacement for items like bottles, straws, cups, cutlery, medical devices, textiles, and it also serves people and the planet. So this will also allow India to build a robust, circular and a bio-based economy with agricultural strength. So we are here to actually demonstrate that from innovation to industry is a need. And I think that other colleagues have also mentioned that till we do not get the scale, I think it will not be possible to achieve anything big. And I think this is a great event today here because we are going from innovators like yourselves to to looking at industrial scale impact like other colleagues here as well. So thank you so much for this opportunity. And thank you so much to DBT.
Thank you, Avantika. We are towards the end of the program of BIRAC, and we also have among us 2 students who've been supported under EUVA program of BIRAC. And first, I would request Mr. Chinmoy Dar who's an undergraduate student at Delhi Pharma University. He'll very briefly talk about his innovation.
So
Chinmoy,
good morning,
you have
everyone.
2 minutes.
First of all, yeah, I'll cover it. So good morning, everyone. First of all, I'm Chinmay from Jivot, and this is next. Yeah. So I'm Chinmay from Team Jivot, and this is my team. Next. So the problem which we are addressing is rising cases of carbon dioxide emission year by year. So these causes various problems, for example, health issues and other problems. So how are you going to solve this issue? Planting many trees cannot solve this problem. As a statistic data says, you have to plant 1.8 billion trees in order to solve this problem right now. Technically, realistically, we cannot do that. So how are you going to solve this problem? Next. Yeah. So we have built a carbon capturing system which sequestrates COX, NOx, and PM 2.5. Yeah. PM 2.5 from the atmosphere. So how does it work is there is an inlet at the bottom. It pumps air inside into the sterilized centralized microalgae chamber, where algae goes under the process of bioremediation, and it mitigates all the pollutants, and it produces oxygen, which is released from the top, and it also produces biomass, which you can extract it from the dosing from at the front and can use it as an aqua feed, fertilizer, and it has nutritional values also. This is our journey. We firstly synthesized a novel microalgae strain which can be used for our product specifically. Then we treatmented the design and tested it in various climates. So the USP of our product is basically compatibility and its minimal energy footprint. So we cannot plant that much trees, but a single 5 feet biobulb design of 600-liter model is able to sequestrate as much amount of carbon as 15 to 20 tall trees. I am talking about eucalyptus trees. Also, it uses as less energy as charging your electronic device. So, and we are also building and also planning to incorporate solar panels into this design, which can be used for public spaces, which will make it this product an entirely carbon negative. So the entities we're targeting are corporate entities, obviously, which seeking corporate CSR needs, home and educational institutes, where we use these products as an alternative to air purifier, because air purifier only prevents the VOCs. That doesn't sequestrate carbon. We are also targeting agriculture sector and nutrition supplement sector, because the microalgae which we are using is as good as it contains around 66 grams of protein in just 100 grams. It's much more than your chicken, your fish, and your dairy products. So these are the competitions we have participated in and we have achieved so far. So that's all. That's all for me.
Thank you, Chinmoy. Over to Vaishnavi.
Good afternoon, everyone. Present here, respected sir, madam, all my colleagues. So I am Vaishnavi Sharma from EUVA Center, Career College, Bhopal. So as we are running out of time, let the PPT run and I'll talk about my product like this only. So the problem which we have identified is about heavy metals, how the heavy metals are being run off from the industries and how they are affecting the wildlife there, or the flora and the fauna in the water bodies. And also there was another problem, that how the fruit peels are just wasted off like this in the environment, and there is no proper disposal of those fruit peels. So we have came up with an idea that why not to utilize these fruit peels to do something in the benefit of the flora and fauna of the water. And then this is how we have came up with the idea of biochar. So basically, our main aim was to produce biochar at different temperatures. So just to identify which temperature is best to produce the biochar, which has high quality. So basically, the main property of biochar is to be porous. More the porous the biochar is, more it will absorb heavy metals. So the best temperature which we have figured out was around 450 degrees Celsius, and the process which we have used was pyrolysis. So pyrolysis, as the name suggests, it is the process in which we heat or we burn some object in the absence of oxygen. So it does not have any oxygen inside it, no moisture, no oxygen, nothing. So it is a replacement of charcoal, we can say, because biochar is purely organic and is developed as compared to charcoal on a very low temperatures. So the applications of biochar first would be the smart water purifiers. We can enable this biochar in the purifier in place of charcoal, and we can also inbuilt AI and ML in this. And after that, it's also promising solution for soil as well, apart from water. It can be used as fertilizer as well, then it can be used in cosmetics as well. Then there's one field, nano composites, which is emerging very much in current world. So we can use biochar in that as well. And then after that, water filtration. So these are all the collaborations which we have during our project. This is our achievement. The first one is the MSME registration. The second is patent publication. We have already published the patent with the help of BIREC, of course. And these are our awards. We have won several awards in several national and international conferences during our projects. So these are our publications. We have published some research papers. Now, what are our future aspects? The first is to commercialize and scale up the biochar production. As we have produced the biochar as a very level, we have to commercialize it. We have to scale up the production of biochar. After that, we have to do some advanced characterization so that we could be very sure that yes, this biochar is able to absorb heavy metal very properly. And after that, we have to evaluate that how can we regenerate that biochar. Let's say we can regenerate that candle which is already there in water purifier. So how we can regenerate this biochar as well. After that, we can customize some filters as well, and then after that, we have to make some marketable product form. So at the last but not the least, I would really love to thank BIREC for providing us such an opportunity to showcase our talent. See what happens. I think everybody, let's say young minds have a lot of talent in India, I must say this, but it is just you need a right platform to showcase your talent. And I thank Chaya ma'am, Manish sir, everybody from BIREC, Jitendra sir, everybody from BIREC, that they have provided us this platform to showcase our talent. And here we are with our product, and we are really very proud of this product. And last but not the least, I would really love to thank my mentor also, because without her support and motivation, I could not be able to do anything. And with this, I would also like to thank my career college, my chairman sir, director sir. Without them, we would not be able to do anything. And this is our pictures working in BIREC EUVA Center. So that facility is also provided by BIREC. And at last, we just thank you all of you, my family, my friends, everybody to provide support during the whole program. Thank you so much.
Thank you, Vaishnavi. Here, I would also like to mention that both these student teams started with their projects in the labs and have now registered companies.
Yes.
Yeah. This is so now we come to the end of the BIRAC program, and I would like to hand over. I would like to thank everyone who joined us for this program today. And please stay tuned. We have very interesting talks lined up throughout the day. Now I hand over to Dr. Balen for taking this forward.
Thank you so much, Bharat, for arranging fantastic talks and a lot of innovation product demonstration cases you have we could listen here. So, in the interest of time, I request Navi to take over the program for next 1 hour. Rather, I will request Navi Director Dr. Ashwani Parikh sir to start with introductory remarks. Thank you so much, sir. It's over to you, sir.
Very good afternoon to all of you, respected Dr. Gokhale, Secretary Department of Biotechnology, dignitaries on the dais, and many people who have joined from various parts of the country online. It's really a pleasure and honor for us to sit together and discuss the importance of this Bioproduct Day. And I'm Ashwini Parekh, coming from National Agri-Food Biomanufacturing Institute. This is situated in Mohali, Punjab, and rightly so because this is where the Green Revolution started. In next 1 hour or so, we'll give you a glimpse of what we have been doing at our institution and contributing to the word bioproduct estimation. And I'm going to talk specifically about agri residues to bioproduct. For any institute or any organization to be able to work in that direction, what is foremost is important is the enabling environment. And when it comes to enabling environment, we completely agree that infrastructure plays a very, very important role beside the ideas. And here I'm going to show you one slide which talks about the capabilities of this National Agri-Food Biomanufacturing Institute in terms of infrastructure. Maybe have the next slide, please, where I would like to mention to you that in addition to kind of high-end equipments we always feel happy that we have been entrusted with having the first biomanufacturing institute. It was inaugurated by Honorable Minister a couple of months ago in the month of October. And you can see some of the pictures from that very phenomenal day we had the inception of this first biomanufacturing institute at Mohali. Next slide, please. We also feel happy that we have been moving steadily in that direction. We contribute to agriculture and secondary agriculture and valorization. And to do that, we have good infrastructure in the form of BioNest, which we are starting now. And we are very happy that we have good facilities related to converting this whole institute into a biofoundry. And the focus here will be that how we can make valorization of various byproducts which are generated from agriculture, how we can increase the farmer's income, and how we can make the good product coming out from various byproducts which are generated during that part. And to reflect upon these, since I'm somewhere else today for a meeting, I would now like to request Dr. Shrikant Mantri to give you some flavor of the various technologies and the product which we have generated at National Agri-Food Biomanufacturing Institute. Over to you, Shrikant.
Yeah. Thank you so much, sir. I thank Professor Parikh for setting the stage for this event. Let me start by giving you a glimpse of explorations at NABI in context to contribution towards bioproduct development, focusing on the celebration of today's theme, agri-residues bioproducts. We all have heard today to the Honorable Minister, Sir, Secretary, Sir, about celebrating the World Bioproduct Day, especially Bio-E3 Way. Let me also emphasize that the bioproducts promote zero waste systems, they promote green jobs, and also they promote the local innovations, which is the key to sustainable and circular economy. I start with giving you a snapshot of the state-of-the-art world-class research facilities in our campus. This is DPT Seeds facility, the specialized platform for enhanced and efficient delivery of seeds for research. In this facility, we can simulate different environments and use different wavelength of light to accelerate the plant growth and study the effects. It was remarkable that this facility, when it was started to being developed, it was developed in just 100 days, starting from the groundbreaking to having the facility on the campus. And it was eventually inaugurated by our Honorable Minister. Then let me tell you briefly about the supercomputer campus we have on our campus. This is the facility that was commissioned in 2021. And this is one of the 14 supercomputers installed by Government of India under National Supercomputing Mission. This facility has the capacity of 838 teraflops, and it uses around 156 servers which run in parallel to accelerate the analysis. So we use this supercomputing facility to accelerate all the day-to-day analysis of transcriptomes, epigenomes, proteomes in our projects. Using these world-class research facilities and infrastructure, our faculty have developed numerous bioproducts. Let me tell you about few of them. The details of some of these products will be provided by the respective faculty during their subsequent talks about the bioproducts. So we have bioxylitol, which is a low-calorie sweetener. It is known to prevent the gum diseases. Then we have some edible coating created by our faculty, which is through the lignin base, and it is the edible coating developed by using agricultural byproducts. Again, from the lignin, our faculty has developed biofertilizers and biopesticides. Some of the natural insect repellent products have been developed in our labs. Saffron colored dye, a natural saffron colored dye has been actually developed by one of our faculty, and it is also now available on Amazon for purchase. Then we have whey beverage, cocoa butter substitute. It is derived from mango seed, and a low calorie sweetener, allulose. Then there is a product called Be Smart. It detects the foodborne bacteria. There is a strip on which you can actually load or touch the food item, and then it will actually detect which microorganisms are present. You can put that strip take a photograph of that strip, and the app will actually detect which microorganism is present in your food. Then curcumin doped with whey protein. Then there is a thermochromic badge to detect the changes in temperature, and also a color-based arsenic sensor, which detects at 0.05 parts per billion levels. Some of these technologies, like Professor Parikh mentioned, that we have now a biofoundry facility which is coming up in Nabi. So in this biofoundry facility, some of these products will be scaled up. So this is one of the product which we will be scaling up, that is xylitol. So this is a low calorie based sweetener. Then there is a smart protein based on corn protein meal and dairy based whey. So we have plans to scale up this particular technology also. Then we have agri-waste based coating materials developed from the lignin. So using this coating, the shelf life of the fruits can be actually extended. Then we have, like I mentioned previously, some biofertilizers and pesticides which we have actually created using the agri residues. These are again from the lignin sources. Then from the agri residues, we also have levulinic acid production. So it can be used as a bioplasticizer in food packaging. So we have plans to scale up this technology as well. Then a lot of natural colorants are currently popular because they don't have side effects like that of artificial colorants. So we have faculty who has actually researched and created such water-soluble natural dyes. And some of these technologies are currently under development, specifically the functional food-based bioactive peptide development and smart alternate protein development. So these, we are currently doing research on these technologies, and eventually we would like to scale up these facilities. In the interest of time, some of the slides I will skip. Being a computational biologist, I would like to actually also emphasize on some of the supercomputing enabled tools which we have developed, which are actually used in natural product research to discover novel natural products. And these natural products can be used as antibiotics or antifungal agents and anti-cancer agents. So what we have done, we have collected the metagenomes from the publicly available databases, and we have analyzed them to detect biosynthetic gene clusters and created a database out of it. And then now you can mine this database to identify different patterns which are available. Like suppose you want to identify antibiotic against a specific organism. So which are the probable areas where you should profile and collect the metagenome? So this particular kind of data mining is possible using such resource. Then now we can do a lot of machine learning, but to do machine learning, there should be a very good amount of curated data available. Then only you can use that data as a training set. So there is a minimum information for biosynthetic gene cluster, a database where all the biosynthetic gene clusters for which a natural product biosynthesis pathway is known and the compound is known and its bioactivity is known. So such database exists. And what we have done is we have done the literature mining to identify such compounds which are not part of the database but are part of the literature. So extensive literature mining was done to add more entries into the database. And then eventually, using all this information, we have created a neural network model to detect the bioactivities of these biosynthetic gene clusters. So I'm very happy to tell you that we have seen very good training and testing accuracies. In case of CIDR4 activity detection, we are already reaching more than 90% accuracy. So this tool can be used to detect the bioactivities of biosynthetic gene clusters. So with developing all these bioproducts, we are also very well connected with the industry. And these are the names of some of the industries in different areas where agri residue has been converted to bioproducts. And some of the technologies have already been transferred to these industries. And we have also signed MOUs and signed technology transfer agreement with different agencies like that. For low calorie sugar tech, we have transferred the technology. Then we have very active collaboration with BCIL to do all this policy technology transfers. When we have transferred the biofertilizer technology, butter substitute technology, and we are actively doing the industry academia connectivity. And with that, I would like to wish you all a happy World Bioproducts Day. And then I would now invite my colleague to take over for the remaining program. Thank you very much.
Thank you, sir, for that wonderfully insightful session. A very good afternoon. I, Meher Danish Khan, am honored to welcome all the esteemed dignitaries, distinguished scientists, dedicated researchers, and passionate peers who have gathered here today in person and virtually from across the country to celebrate the World Bioproduct Day BioE3 Way. At BRIC Navi, we believe that science is most powerful when it is aligned with a purpose. Our mission is to pursue cutting-edge research that not only fuels the scientific ecosystem, but supports a sustainable, environment-conscious future. Now, without further ado, I would like to begin with the next segment of today's program, which highlights innovative bioproducts derived from agricultural residues. To begin with, we have Dr. Joy K. Roy, who will be presenting on low glycemic wheat and resistant starch for industrial applications. The stage is all yours, sir.
So good afternoon. So this is the product which we have developed. There are a number of approaches we are following to develop the low glycemic wheat line here. So we have developed a low glycemic wheat line which has the 25 to 30% lower glucose response in the mice. So we have used the agricultural biotechnology approach where we have done the EMS mutagenesis in the wheat grain and in the genome. And after that, we have scanned the line and then we have developed the lines. So you can see that in grain, more than 70% of the grain component is the starch, and which is highly digestible. So these are the two biopolymers, amylose and amylopectin. So amylose is the linear chain, which is less digestible, and we can increase this content in comparison to a second component, which is amylopectin, which is highly digestible. So either of both the component we can modify it and we can develop the low glycemic wheat line. So we have this starch for the amylose. We have increased the amylose content. Generally, it is 25% in the wheat germplasm, but here we have developed more than 50% amylose content in our EMS mutagenesis lines. So this is the variety which we have used, is the C306 variety. This is the best chapati variety. It is a very old variety, more than 50 years old variety, but still it is in production by the industry. So most of the industry, they use this variety for the best chapati quality. like this is also called MP wheat or Sabarmati wheat also. This is, and so we have used that variety to change the amylose content in that. So we modified that through the EMS mutagenesis, and then we have grown this in the field and try to screen the lines, and from that we have selected the low glycemic wheat line, and that we are growing in a larger scale in the multiplication for yield trial. And we found that this is yield is better than the parental wheat varieties. And we can see that we have used the in vitro and vivo method to check the glycemic index. So we can see here that we have used the control like glucose, and then in comparison we have used the C3 variety, and you see the two variety. We have tried a number of EMS mutant line, but two of them is the promising. It is up to 25 to 30% lower glucose response than the parental line. And these two variety we are commercializing through BCIL. Already 3 companies has approached us, and we are trying to, so there are certain conditions by those companies. We are trying to address those issues through the BCIL. And once we have, then we can transfer this technology to these 3 companies. Thank you very much.
Thank you, sir, for walking us through your incredible work. Given today's growing emphasis on mindful consumption, your product will be a boon to the industry and its consumers. Moving on, it is my pleasure to call Dr. Jaita Bhaumik for her talk on lignin valorization technologies for bioplastics and crop protection. Thank you.
Good afternoon, all. Thank you, DBT, and BIRAC for organizing this wonderful way, and happy World Bioproduct Day, the Bio-E3 way. So, what is our lab's contribution from BRIC NABI to this great initiative in process? So, our lab has developed lignin valorization technologies to address multiple problems, and we have tried to develop lignin-based bioplastic and crop protectants. I'm going to give you detail now. So, lignin-based bioplastic to replace household plastic. So, what problem we are going to solve now? We are going to, as you can see from the image, a picture tells 1,000 words. So, health issues, environmental hazard, all coming from this plastic pollution. Let's try lignin as a solution to this tremendous problem. Lignin is a natural biopolymer, and it's an ideal bioplastic precursor. Looking at the market, you can easily tell that the next 5 years, the number of the total market is going to be doubling, and which gives us immense confidence to work on this field. So here is our solution, the lignin-based byproduct or lignoplast, lignin-based bioplastic. So how did we get to this lignin-based bioplastic? So we have used agri residue such as wheat straw, and then converted and then extracted lignin in good quantity. The pure lignin was then easily converted by adding up with some other biosafe polymers, and this bioplastic was safe for using to enhance the shelf life of different fruits and vegetables. And the features we can tell that biodegradability, antimicrobial activity, UV blocking activity, and the shelf life enhancement for the perishable items. So an Indian patent has been filed, and many industries we are in discussion with to bring this product to the market someday. Next comes another big problem. You can imagine how much chemical pesticides and fertilizers are used throughout the globe. So as the picture tells again, soil pollution, water pollution are the major problems across globe. So for that, lignin has again come to the rescue. What lignin does, it acts as a biosafe material to entrap some plant-based extracts to give them stability and then remove chemical-based crop protectants. Again, looking at the market is going to be doubled in next 5 years. Here is the byproduct, a product of BRIC NABI. It's an agri-waste-based bioplastic using lignin. So the strategy here we followed was lignin converted into nanomaterials, which is also biosafe, and then that was used to entrap some plant-based extract, which are normally unstable. So this stability gained by lignin entrapment, it is a plant-based biopesticide, no chemical was used, and this is very effective against multiple microbes. And most importantly, this is a controlled release delivery vehicle of the pesticide, biopesticides, and and it gives long-term storage stability. So we are happy to state that our products of Brick Nabi is already in the field. It's really happy moment for Brick DBT as well. So field trials have been conducted, and which shows that good effect on cereals such as rice, and then vegetable crops such as brinjal and cucumbers. And as we hear from this farmers, from their statement, that the plant protection was longer due to the long period of the release of this biopesticide, and then the release was slow and it was highly effective for longer duration. So as expected in Bio3 policy, these products should be going to market someday. So we are happy and thankful to BCIL, who has helped us to be connected with multiple industries who are working hard to bring this product to the market. So scale up is in progress. And then these two products, we hope that will be, this lignin-based bioplastic and biopesticide will come to market and this work will be justified under the Bio3 policy. Thank you, everyone.
Thank you, ma'am, for that elucidating presentation. With the alarming rise in microplastics being detected literally everywhere, the need for biodegradable alternatives has never been more urgent. Your work is essential in addressing this global challenge. Moving forward, I would like to call Dr. Kaushik Mazumdar, who will be presenting his talk on edible coating for enhancing the shelf life of fruits. Stage is all yours, sir.
Okay, good afternoon, everyone. And today I'm going to talk about the technology which is related to the edible coating technology for the improved shelf life of fruit crops. So this is a brief summary. As you know, India is the second largest producer of the fruit and vegetables in the world after the China, but it poses very high post-harvest losses. It has been estimated that nearly about 1 trillion rupees, that is 1.8 billion USD, in 54 fruit crops. It's a recent study is annually by when the food crops is this much of loss has been estimated annually, and because of the limited availability of the cold chain facilities, so development of edible coating is a high priority in this research area. So what we have done under the achievements areas, so we have developed actually the various carbohydrate based, this is a biopolymer based coating material, and which is from agri and food processing byproducts, so such as wheat straw, oat bran, and potato peel. So these are some of the byproducts which is either related to the agri waste, or they are coming from the food processing waste. So this coating formulation actually we have applied on several food crops, like we have applied on apple. So, and we are able to extend the shelf life of apple up to 30 to 40 days at a room temperature. Similarly, we have applied this coating material. So if you can see here in these images, so these are this is the uncoated apples, and this has been the coated apples, which is after 30 to 40 days. Similarly, the peaches, which is a very perishable food crop, which is have a very limited shelf life up to 2 to 3 days. So after applying this coating material, so this is uncoated peach, we are able to extend the shelf life up to 6 days. Similarly, the banana is a food crop which has a very limited shelf life. And so here we have applied this coating material, and we are able to extend the shelf life of banana up to 9 days at a room temperature. So this is A is the uncoated banana, and B is the coated banana. Similarly, this coating technology was also applied on guava. So here we are able to increase the shelf life up to 6 to 9 days. And based on the safety studies, it is telling our observation is that this coating material is non-toxic and safe for the consumption. And the tentative cost of the coating material is, if you apply the 1% of this coating solution, so it will cost only 50 paise to coat 1 kg of apple. So it's a very cost-effective technique, and it could be used in a farm level. So one of the one of the major advantage of this coating material, it's a plant-based material. It is derived from the agri and food processing waste, which is it could be used as an alternative to commercial wax. So currently the commercial wax is whatever is coming in the market. So the commercial wax is a shellac. It's a lac-based derivative. So it's from a non-vegetarian source. So we can actually have developed this coating material, which is in our lab, which could be used as an alternative to this commercial animal-derived waxes. So during a few years, we have able to establish the linkages with the several industries. So one of the major industries is the DECO UPL. It's a premium post-harvest management industry, and the Sigler Technologies Private Limited. And so with this help of these industrial linkages, we are able to done the field trials. So this is the study which is done by the DECO. So here they have applied this coating formulation of 1 to 2%, and they have shown it. This coating material has a very high efficacy in terms of maintaining the quality of the apple up to 3 weeks at a room temperature. So if you can see it, after the 3 weeks when you cut the apples, so it is from the inside, it is fresh and it has quality has been maintained. So similarly, the another study which is by another industry which is a Sigler Technologies Private Limited. So they have applied this coating material on oranges, and they were able to extend the shelf life of oranges up to 15 days and up to room temperature. So here you can see this is the uncoated oranges. So you can see from these red arrows, switches are there. So this is the kind of the indication that the deterioration in the quality has been happened. So after 15 days, you can see there is no quality deterioration in case of our coating material, which is coated with a 1 or 2% solution. So the estimated, this coating material not only able to extend the shelf life, but it was also able to prevent the decay. So in case of a room temperature, if you can store these oranges up to room temperature up to 15 days, so around 38% decay has been observed. So here is after 15 days, no decay has been observed in case of after this coating application. So far we have also filed the 2 Indian patent application, and which both have been granted. So next. So this is the pilot scale style, which has been done by one of the industries in the commercial line. It is in a pack line. So here they have on tons level, they have applied this coating material on kinnu, which is it's a kind of a food process which belongs to the orange family. So now can you run the video? So this is in industrial scale setup. So where the coating formulation has been applied on around 1 tons of the oranges using this commercial spraying system. So this spraying system is generally they are used in industrial scale. So company has took the material from us and then applied in their facility. So here in the ton levels of fruits they have done this trial. So this trial has shown that this coating material could also be used very effectively by using the commercial scale sprayer. It has a good property, so which could be used in terms of for a commercial spray application. Yeah. So that's also finally actually I want to tell you we are now with the help of BCIL we are further discussing in the process of discussion with these two industries. So we are hoping to add that we will be able to bring this product into market for the shelf life extension of the several food crops. Thank you all.
Thank you, sir, for sharing your fascinating research. Food wastage has been a long pressing issue in our country, and your innovation offers a promising solution not only by minimizing spoilage, but also by doing so in an eco-friendly manner. On the same note, I'd like to welcome Dr. Shivraj Neele to give a talk on natural colorant from biomass farm to industry.
Good afternoon to all of you. It's honor to present our research on natural colorant on the occasion of World Bioproduct Day. Now India is moving towards development of bioproducts through Bio E3 policy that provides employment, then economy and protection of environment. So basically in our research, we are focusing on natural colorants. These are very important. Recently, there are few news about ban on artificial colors. So we decided in NABI to focus on natural colors. These are alternative to artificial colors. We know that these colors are very appealing, like artificial colors to children's, to many consumers. But we have to think about the side effects of these artificial colors. So that's why the FDA from USA, even some European agencies and many governments, they are targeting to ban these artificial colors. So for that, we have to develop alternative by using natural colorants. For natural colorants, stability is very important. So in our lab, we are focusing on extraction of different biocolorants by using agri residues, agri byproducts. So you can see there are many sources of natural colorants like carotenoids, anthocyanins, betalains, curcumin, and polyphenols. We are very familiar with curcumin. We use daily as a colorant in vegetables, like preparing different dishes, and that's why the Indian people they don't have Alzheimer like frequently. So here we want to focus on carotenoids from microalgae, anthocyanins from red cabbage, betalains from prickly pear and coxcomb. So basically, we want to focus on the underutilized fruits like prickly pear and coxcomb that is widely used as a food colorant in traditional way in like Himalaya and Kashmir. So, and finally, we want to focus on some bioactive compounds from like bio-waste. You can see this is our lab work. Recently, I joined as a scientist in Nabi, and within 2 years, like 2 years span, we focused to develop some bioactive products from prickly pear, natural colorants that is more stable at room temperature and also stable to light and pH. So we developed natural gummies by using this color, and we compared natural gummies with artificial color and natural color. And we did the sensory evaluation, and also we checked the consumer acceptance. Then we developed natural color from red cabbage that is widely cultivated in India. Then we also developed natural colorant from microalgae, because India have like large sea resources, but that is not utilized still. If you compare with China, Korea, and Japan, we're still lagging behind to utilize the marine resources. So we are focusing on marine microalgae to develop natural colorants, and we like developed energy bites that is very appealing to like children's. And here we want to focus on how to develop these gummies, these energy bites, by incorporating different sweetness, because that should be low glycemic. That particular energy binds and gummies, they should have low glycemic index. That is very important. So we want to develop gummies and energy bites for diabetic patients. And here we want to target again like citrus pomaceae, citrus peel for extraction of methoxyflones, and red ginger to extract polymethoxyflones. These are like different bacterial compounds which are having strong effect on cancer and male fertility. Basically, we want to formulate different herbal formulations and natural colorant by using these bioresources to target cancer, diabetes, and also we want to develop a prebiotic source for growth of probiotics, that is enhancement of gut microbiome modulation. So these are like different products we have developed in Nabi, and these are like recently we submitted patent to like Indian Patent Agency. I hope these products will be available in market soon. So thank you. I am grateful to DBT for organizing such a innovative event, that is World Bioproduct Day. So thank you, Nabi, for providing this opportunity. Thank you all.
Thank you, sir, for that remarkable presentation. Visual appeal plays a crucial role in how foods are perceived, and having a natural substitute for synthetic colorants is indeed a significant step for both conscious consumers and the industry. With that, I conclude this session and pass on the mic to our next host, Aman, who will be taking you through the rest of the program. Thank you.
Thank you, Meher, and good afternoon, everybody. I firmly believe that within the premises of Brick Nabi, some truly impactful and forward-thinking research is taking shape, especially in the realm of sustainable biomanufacturing. As emerging scientists, it is imperative that we stay informed about these innovations driven by our peers across different laboratories. This segment, the Youth Voice on Agri Residues to Bioproducts, serves as a perfect platform for such knowledge sharing. Today, we will hear from our research scholars, each representing the work of their respective principal investigators, showcasing distinct and innovative approaches to valorizing agricultural residues into high-value bioproducts. To begin, I would like to invite Ms. Priyanka, representing Dr. Nitin Singhal's lab, to present their work on B-Smart, bacteria sensing through mobile aptamer recognition technology.
A very good afternoon to all of you. And I'm Priyanka Garg. I'm here to represent the Nano Bioscience Lab of Brick Nabi, which is led by Dr. Nitin Kumar Singhal. With the support of DBT, we have developed a device that can detect the multiple bacteria within minutes, and the device is named as V-Smart. V-Smart is bacteria sensing through mobile aptamer recognition technology. So we are hoping that this device is a great solution to the problems we are facing in the segment of health and the food safety. As we are all aware that the food safety is a concern nowadays, and the traditional methods available to detect these early pathogens are time consuming and costly. So we have developed this device to counter these limitations of the traditional devices. As we take this device to the commercial level, this device will have the price of less than 500 per sample. This is very least expensive compared to the other POCs available. And the industry we are focusing on: food and dairy industries, household, raw fruits and vegetable industry, aviation industries. Let's come to how the our device works. So we are working on the principle of fluorescence quenching and regaining. So we are using aptamer, which is a which is DNA like molecule, and we are using the geo, that is graphene oxide. So aptamer is specific to bacteria, and it is attached with the fluorophore. So whenever the aptamer binds to the geo, the fluorophore attached to the aptamers quenches its fluorescence. And whenever the bacteria specific to that aptamer binds, incubated with the solution, the aptamer detaches from the geo, and it structurally binds to the bacteria. So this binding and unbinding event leads to the fluorescence regaining. This fluorescence regaining can be then observed in the under the fluorescence spectroscopy. Further, these technologies need to be devised in a POC sensor. For this, we have developed a microfluidic chip in which multiple bacteria can be detected. So after incubating the aptamer graphene oxide solution with the bacteria, we insert this chip in the B-Smart device and click our pictures through a smartphone. So these images are then processed via in-house software application to qualitatively detect the bacteria, and which bacteria is present, it will tell you that. We have already filed a patent regarding the same and have two publications related to this technology, and two other patents are also in the process. We are at a TRL 6 level, and we are working on the speeding up the commercialization strategy to take this product in the market. And I am proud to announce that this technology has been accepted for EIR program and will be funded rupees 50 lakhs by the venture capitalist working in this area. Thank you. That's all from my side.
Thank you, Ms. Priyanka. Next, I invite Ms. Loreni from Dr. Amit Kumar's lab to present on agro-waste valorization to functional xylo oligosaccharides.
Hello, everyone. It's a pleasure to present our initiative, Waste to Wellness, which focuses on the sustainable solution for agriculture residue utilization using Himalayan microbial enzymes. India's position as an agricultural leader generates millions of tons of agro-waste. These underutilized agro-waste are rich in hemicellulose, xylene, a promising substrate for biotransformation. Our goal is to transform these agro-waste into value-added product using robust microbial enzymes sourced from the Indian Himalayas. Each year, India generates substantial amount of agro-waste rich in xylene, such as rice straw, sugarcane waste, and corn cob. Unfortunately, most of these waste are either burned, resulting in environmental pollution. Our work aims to address this challenge through the use of microbial fermentation and enzyme technology to convert this residue into xylo-oligosaccharide, a value-added compound of industrial and functional significance. Xylo-oligosaccharide is a rapidly growing product in the global bioeconomy. Its commercial market is expanding increasingly due to the interest for functional ingredient
leading to sustainable production. To tap into this potential, we isolated xylanase producing microbes from high altitude region of the Indian Himalaya, followed by strain selection, process optimization for enzyme production, and partial purification of these enzymes for efficient biomass conversion. Our selected strain, Bacillus altitudinarius XYL17, produces a highly active xylanase capable of converting agarose-derived xylane to xylo-oligosaccharide. We further assess the functional bioactivity of these resulting products, such as its antioxidative and prebiotic potential, confirming its suitability as an ingredient in both functional animal feed and nutraceutical formulation. In conclusion, our work demonstrates a low-cost, scalable, and environment-friendly approach for agrowaste valorization with strong potential for commercial application in the feed and health industries. Thank you.
Thank you, Ms. Loreni. I now welcome Dr. Soumya from Dr. Meena's lab to share their research titled Bioxylitol from Agri-Residue.
Good afternoon, everyone. On the occasion of World Bioproducts Day, I am happy to share our work on the biovalorization of rice straw into xylitol. So, with India being the diabetic capital of the world and the persistent problem of rice straw burning, which causes severe health issues, the present innovation addresses two national issues at once with xylitol production. So, xylitol is a low-calorie sweetener with 40% less calories than the normal table sugar and having a low glycemic index. So, at the commercial level, xylitol is produced using a catalyst which is not only carcinogenic but is also pyrophoric. It uses a pure stream of xylose in a process which is entirely energy and cost intensive. So, in this work, we've developed a process which is not only green but also sustainable, using rice straw as an agri-residue as the major feedstock. Our method avoids the usage of toxic chemicals and requires less energy and uses a robust yeast as the microbial cell factory for xylitol production. Xylitol is a non-fermentable anti-carcinogenic sweetener and also sugar alcohol, which is also hygroscopic, has a supercooling effect, is antioxidant, and is also humectant. It has a GRS status and is approved in more than 50 nations for the use in the food products. Xylitol can be used in the treatment of dental care infections, in osteoporosis, inflammation, otitis, cancer, etc. It has a beaming market of $1.11 billion US, growing at a CAGR of 5.6%. So, this makes xylitol truly a value-added product with major industries, for example, the confectionery, chewing gum industry as its major consumers. So our process starts with the pre-treatment of rice straw to generate a xylose-rich hydrolysate, which is then fermented by the yeast M. caribica CP02 to generate a xylitol-rich liquor, which is then crystallized in downstream processing to generate crystals. So putting it all together, we can get 35.64 grams of xylitol crystals from 1 kg of rice straw. However, our process can be replicated on other agri-residues, for example, bagasse and corn cob also. So the process has been statistically optimized and scaled up to 14 liters. We've also worked on the biopackaging of xylitol to integrate the biodegradable materials for food packaging. The technology has been licensed and the patent has been filed for the process. So the key highlights of the process are that it is green and sustainable. The insoluble barium sulfate salt that is generated has direct commercial value. The acidophilic isolate is resistant to inhibitors present in the rice straw hydrolysate. And the detoxification process that we have adopted increases the fermentability of the rice straw hydrolysate. So the work exemplifies the waste to wealth mission of the India's BioE3 policy while promoting sustainable development and bioeconomy through this high impact innovation. Thank you.
Thank you, Dr. Soumya. Now I invite Ms. Wrinkle, representing Dr. Vanish Kumar's lab, to present on thermochromic badge, a detective for thermal surveillance.
Good afternoon, everyone. Myself, Wrinkle Chopra, and I'll be presenting a sensor, a thermochromic badge, a detective for thermal surveillance. So this sensor is basically change its color on the basis of temperature. So we all have gone through a pandemic recently, and at that time we got to know what is the value of vaccine. So we all people got vaccinated, and those huge requirement was met because of this pharmaceutical industries. So this pharmaceutical industries prepare these products on large scale और उसको store किया जाता है so that on the basis of requirement or need हम उसको utilize कर पाए. Likewise, there is other huge industry which is food industry. So frozen foods को भी large quantity में produce किया जाता है and store किया जाता है so that on the basis of requirement हम उसको use कर पाए. But both the industries जो cold storage का use कर रही है, they are highly temperature sensitive. अगर फ्रोजन फूड या फिर फार्मास्यूटिकल प्रोडक्ट्स के स्टोरेज में अगर कोई टेम्परेचर मिस हैंडलिंग होगी तो प्रोडक्ट जो है वो डिग्रेड हो सकता है या स्पॉइल हो सकता है. फॉर एग्जांपल अगर फार्मास्यूटिकल प्रोडक्ट्स स्पॉइल हो गया या डिग्रेड हो गया इन दैट केस या कंजप्शन ऑफ फ्रोजन फूड जो कि गुड क्वालिटी में नहीं है, इट विल लीड टू नेगेटिव इम्पैक्ट ऑन आवर हेल्थ as well as on economy, because in 2024 this food storage and cold storage market supply value was around 170 billion US dollar, and it will about to reach 430 billion US dollar in 2030. So to neglect this problem occurring with temperature change, there are many products available in market like digital devices, color changing pigments, thermochromic pigments and liquid crystals, but there are many bottlenecks with each products. Like some products are costly, some products are not able to monitor the temperature after some time क्योंकि वो restricted है real time monitoring को change करने के लिए. So to target this problem हमने एक thermochromic badge बनाया है जो with time अपना color change करता है. अगर हम किसी वैक्सीन के या फिर फूड के बैच के साथ अगर इस सेंसर को रखते सो -20 पे वो सेंसर ट्रांसपेरेंट कलर शो करेगा, बट जैसे ही टेम्परेचर राइज होगा इट विल चेंज इट्स कलर फ्रॉम ट्रांसपेरेंट टू रेड. सो ऑन द बेसिस ऑफ कलर चेंज वी कैन गेट टू नो दैट आवर प्रोडक्ट इज सेफ और नॉट. सो दिस whole reaction is irreversible, so there are no chances of data manipulation. Once the color is changed, the product is not safe for consumption. Other good thing about the product is that this product will cost 0.20 rupees per ml when we synthesized. So if we reduce the quantity from 1 ml to 0.1 or 0.2 ml, the production cost will be decreased 10 or 20 times. So I would like to recommend to use this kind of products to be healthy, to take care of your health. Thank you.
Thank you to all the presenters for those insightful contributions. We will now proceed with the pledge ceremony, a symbolic yet sincere reaffirmation of our collective commitment to the principles of the Bio-E3 policy. I'd request Dr. Jaita to come up on the stage and proceed further with the pledge ceremony. Thank you, ma'am.
All please rise for taking the pledge. So I'll start and you can say after me. We the people of Mohali in the state of Punjab wholeheartedly affirm our commitment to the vision of the Bio-E3 policy of the government, a strategic framework to build a sustainable, inclusive and innovation-driven bioeconomy grounded in environmental conservation, economic opportunity, and employment generation. Recognizing our state's unique scientific and ecological and cultural context, and the immense potential of our bioresources, we pledge to implement the Bio-E3 policy with the dedication and leadership guided by the following principles and priorities. Promote and actively collaborate on bioproduct innovation to unlock local and national potential, establish and promote biotech innovation hubs that drive a regenerative and circular economy, enable biomanufacturing hubs and industrial scale-up for clean and sustainable production, generate employment and build green skills, especially to reduce, recycle and repurpose waste. ensure bioethics and equity across all aspects of bioeconomy, development, respecting community rights, responsible science, and just transitions. We recognize that the future lies in an economy that regenerates rather than depletes, employers rather than excludes, and embraces future technologies to co-create with nature. We pledge to lead our state and our nation toward a bionic economy that is inclusive, climate resilient, ethically grounded, and globally competitive. Thank you.
Thank you. Thank you, Nabi. Now we come to ICGB, and I invite Dr. Sonti to start with the proceedings.
In ICGEB, and we hope in the next year or two to be able to come back to this forum and tell you about the innovations that have come up through the biofoundry. So the Bio E3 policy aims to make bioeconomy a key driver in towards our journey towards making India a developed country by 2047. So today, from the ICGEB side, we've been asked to focus on enzymes and biofuels. So we'll have a presentation by Dr. Shams Yazdani on enzymes for bioethanol production. Then Dr. Naseem Gaur will show a bioproduct showcase about our products developed at our yeast strains and our biorefinery products that we've developed here. Then we have some very exciting presentation by two young researchers at ICGEB, Dr. Prachi Navarkar and Naukarkar and Preeti Rai, who have recently come back from the Kennedy Space Center in Florida, USA. This is the NASA center where they have helped our astronaut Group Captain Shuvanshu Shukla, load his experiments onto the International Space Station. They are actually happening there right now. The experiments are happening there right now. And we are very excited to hear Prachi and Preeti's experiences from how they have prepared for this particular project and how they have actually helped this project go into space. And then we'll have Sirish Srivastava bringing us back down to earth and talking about a very important problem that we all have about food waste. And Sirish has been and his student have been working on a very interesting project on developing novel microbial formulations for valorizing food waste into biogas. And finally, we will end with the pledge that we will take at ICGEB on behalf of the citizens of New Delhi. Thank you, and I request Shams to please come and make his presentation.
Thank you, sir. And let me start by thanking DBT for celebrating the World Bioproduct Day and giving us opportunity to share our work on this platform. I'm going to speak about our journey or enzymes for bioethanol production, especially second generation bioethanol production. But I guess the same path could be followed for enzyme development for any other bioproduct that we are interested in. So just I'm going to just quickly start my talk by giving you the hint about the climate change and the climate change that has been talked about several times today. They're majorly coming due to the fossil fuel usage. And, you know, overall, we are adding new carbon dioxide in the environment, almost 35 billion metric tons, and we need to take care of this by shifting our dependence on the fossil fuels to the biofuels. And it's all well said nowadays that all the new diseases that we are seeing, there's somewhere or other climate change is involved in that. So if you are able to, you know, counter the climate change, it will be like prevention is better than cure. So biofuel is important because it is a carbon neutral, without any doubt, but if we are working on hydrogen, it can be even carbon negative. We are not adding any extra carbon in the environment. Right now, whatever biofuels that are available in the market, there are biofuels. Most of us are using petrol that are blended with ethanol. They're all coming from first generation biofuels. Even there are a lot of innovations that need to be done in the first generation biofuels. For example, the molasses fermentation, yeast we import from outside. All that innovation will still have to be done in our country. However, it is also well said that, you know, we can't go beyond certain amount of ethanol from the first generation biofuels because of the food versus fuel issues. We need to shift to the second generation biofuel as soon as possible to gain further insight. The major difference between first and second is in the second generation biofuels, we use residues, agricultural residues, the non-food part of the plant, and these could be there in almost all the grains that grain plants that we use, for example, rice straw, wheat residues, the corn residues, the sugarcane bagasse. They are all made up of lignocellulosic biomass that can be a feedstock for second generation biofuels. So in India, we are producing a huge amount of agricultural residues, more than 500 tons every year, and 500 million tons, and most of them are being wasted. We are not using it efficiently, and most of them are actually burnt, and that is leading to a huge emission of black carbon, carbon dioxide and methane, and that's the reason why US identified reducing the burning of agricultural residues as a priority to help slow global warming. So lignocellulosic biomass, as the name suggests, they are mainly composed of lignin, hemicellulose, and cellulose, and there are processes in which these lignocellulosic biomass can be converted to ethanol. For example, lignin needs to be loosened out through the pre-treatment process, thermochemical, and then there is an enzyme that will be added to saccharify these cellulose and hemicellulose into sugar, C5C6 sugar, which can be fermented ethanol. Now in the ICGEB, we are actually making effort at several fronts. Major front had been to identify enzymes that can saccharify these lignocellulosic biomass, and normally these enzymes are expensive. I'll tell you about it. And the next is also we are working on C5C6 fermentation, because normally yeast can't ferment C5 sugar, and Dr. Naseem will speak about it. Now, regarding the enzymes, just wanted to let you know that under the Prime Minister Jeevan Yojana, India is going to set up 12 commercial second generation biofuel plants. Now, each of these plants are going to need huge amount of enzymes. By nature, cellulase enzymes are needed much more to hydrolyze the biomass because they are not very efficient. Now, if you look at the current need, there are 50,000 tons of enzymes are going to be needed every year, and these are approximately going to be costing 2,000 crore worth of rupees. And all of these enzymes at the current scenario are going to be imported. So therefore, it was a great need for us to start inventing the source of enzymes. Now, so far, why India needed to import all the enzymes? Mainly because these enzymes are not very effective in digesting biomass, and so far indigenously we're not able to develop it. And mainly these crystallinity comes from the cellulose chain, and cellulose chain are arranged in such a way that it makes a very strong hydrogen bond, and therefore making enzymes to really difficult to digest. So there are core enzymes like cellulases and hemicellulases that are known to digest these biomass. However, these core enzymes are not one or two. There could be in the hundreds. And therefore, it's difficult to heterologously express some of these enzymes. We need to figure it out, a host that can really express cocktail of these enzymes. And that's where we came to know that India is a hub of many, many diverse things. We heard about any disease that you name, India is there. But we should also know that 8% of the total world species exist in India. And therefore, there's a huge reservoir of biodiversity that exists in India. So we went to the nature to find out if there are some enzymes produced by the microbes that we can use for the lignocellulosic biomass. We screened a large number of microbes, and we have fortunately funded by DBT via the Bioenergy Center a high throughput robotic system for screening these, and then we select the particular microbe and see how they can be further manipulated for the better enzyme production. So there's a very unique concept that we said, because we wanted a host that produces enzymes not only just for a high activity but rather biomass degradability. So we took a very unique methodology, what is called weighted sum matrix score, to take care of all these unique features, and eventually selected one of the best in our hand, that was L42 strain, initially characterized as Penicillium phenucleosum, but later on, after genomics and proteomics, we found, let's say, Telleromyces pinophilus. Now, The proteomic also identified this as a very, very unique composition of enzymes that were not reported before. A very balanced cocktail that led to a very, very high efficiency conversion of enzymes. When we shared this lower right graph enzymes to Indian Oil Corporation, they said that these enzyme efficiency were very close to the imported enzymes at that time. And this composition, because of the uniqueness, were also granted US patent. Now, after knowing that it's a very good host, we actually developed genetic engineering tools to further enhance the capability to produce more enzymes. And engineering any natural isolates are very, very difficult task because they are inherently able to tolerate most of the antibiotics used in the laboratory. But still, we were able to crack the code and were able to engineer this particular host. And eventually, we got rid of many, interventions, like, for example, got rid of the catabolite repressor, overexpressed some of the key enzymes that were responsible for hydrolyzing the crystalline cellulose, which was the key stuff about it. And then main target was to show whether we can scale up these enzymes in a similar efficiency to the larger scale, because a lot of work has been done in the laboratory, but they were very difficult to scale it up. Now, again, with the help of DBT, we had a multi-vessel 500 ml reactor, 20-liter reactor, but then we had a facility to scale it up to the 15,000-liter reactor with a very, very successful scale-up journey. Then the next part was to test the efficiency of enzymes with the real biomass. And that we did it with the help of Center for High Technology, as well as through the PRAJ. They provided the real pre-treated biomass that was produced from the 2G ethanol Panipat refineries, and we tested with the help of commercial enzyme as a benchmark, and we found that our enzymes were working as good as the commercial enzyme. So the current aim for our work is to produce enough enzyme that will be needed to provide a commercial scale 2G ethanol plant. Now that's a huge task because commercial scale 2G ethanol plant really needs 5 to 10 tons of enzyme every day. And in India, there's hardly any facility that will make that kind of enzyme. So we are trying to see if we can, for example, I've given 2 examples here on the bottom. Numaligarh refinery plant, which is actually made to produce 180,000 liters of ethanol every day. They are going to need 10 tons of enzymes of 200 FPO per ml, and that will need for us in a quantity that we are producing, in a titer that we are producing, we need a reactor size of 160,000 liters to produce that volume. Same thing with the Panipat refineries. We'll need a huge reactor size to produce these enzymes. It's difficult to find those kind of reactor size at this moment in India, and that's where we are seeing that in the biomanufacturing policy, the new ventures can come up who will be able to set up this kind of reactors to produce enzymes. At this moment, we are trying to do a multiple runs. We are talking to industry so that we can provide a multiple runs and provide the enzymes for both Maligarh refinery and Panipat refinery in the within the 1 year. The whole idea is, can we do at least 20% enzyme substitute? I mean, I told you that we need a 6,000 crore worth of enzyme imported. We at least do a 20% import substitute in the next 1 year, and more later year. So I'll stop here by acknowledging the journey of mine with all the students that are involved in this. It was not possible without their help. There's a large number of students that were involved. I'll just name some of them who were the key players. The backbone of this was Tulika, and Ayushi and Adil had been the fermentation people, and the previous alumni, Funsu, Shola, Anmol, Kanika, Omo, they were all helpful in the building of the strain that we were having at this moment. I must thank with all the collaborators as well as the funding agencies. I'll stop here. Thank you very much.
So thank you, Dr. Shams.
as we know that biological enzymes are central to our transition to a bio-based sustainable economy. Similarly, ICGEB is also very active in working with certain specific microorganisms, where we also are leveraging them to produce bioproducts which can have far-flung effects. So we have Dr. Naseem here, who is actually working on certain specific forms of strains, certain strains of yeast to produce 1G and 2G ethanol, and also certain specific oligosaccharides. So I invite Dr. Naseem to actually give a brief presentation and showcase certain of his products and the work.
Thank you, Rais, for the nice introduction, and I would like to congratulate DBT and BIRAC for celebrating the World Bioproduct Day. To begin with, a lot of background Dr. Shams has already discussed and speakers from NABI. So I will directly tell you that what we are focusing in ICGEB from last few years, that we are developing technology which can make the bioproduct from mostly from agricultural waste residue, or the enzymes which are enzyme and other microbes which are required for the valorization of the biomass. For example, microbial strains, they can convert the valorized biomass to different type of product, and enzymes which can hydrolyze the biomass to fermentable sugars. And the bioproducts that mostly in ICGEB we have been focusing on right now is mostly bioalcohol, which is one of the major tasks for us to produce bioalcohol, whether it is 1G or 2G bioalcohol. Then we have made the xylo-oligosaccharide technology to make XOS from the hemicellulosic fraction of the biomass. We have developed a bioproduct xylitol, and we have also made technologies to make biodiesel and beta-carotene using alternative yeast strains. So why our major focus is bioalcohol? Because India aims to blend 20% ethanol under BioE3 policy, and by the fiscal year 25-26. In 2024, the average ethanol blending was around 15.4%, and India's ethanol production capacity has grown up to 16 billion liters in 2024. Out of these, ethanol, which is currently being blended, 52% of ethanol is produced from molasses, and 48% of the ethanol is produced from grains. As in the previous talk, it was mentioned that we cannot completely rely on first-G ethanol production from molasses and grains. We are also working to make ethanol from the second-generation feedstocks like rice extra, wheat extra, and sugarcane bagasse. We started development of these microbes which can convert these feedstock, whether it is a 1G feedstock or 2G feedstocks, to ethanol. And for that we did a huge bioprospecting study in which we isolated sample from different locations in India and different geographical locations and different stressful conditions, as well as samples from different depository in India, and we did the bioprospecting. Then we further evolved these strains which are suitable for ethanol production from 1G ethanol and 2G ethanol production, either through laboratory adaptation or through synthetic biology and metabolic engineering approaches. And one of the strain that we selected through these applications was tested for ethanol production from molasses. A comparative study was done with different yeast strains which are currently industry is using for ethanol production from molasses, and we figured out that our strain is produced better ethanol yield and productivity as compared to the currently industry used strains. We also did a third-party validation for the selected strains, and then finally we did the industrial trials at 840,000 liters for the molasses fermentation. In this fermentation scheme, the yeast culture is grown from test tube culture till 160,000 liters. The culture is replicated to increase the biomass, and the fermentation is started at 840,000 liters. And in this fermentation trials, we we got a comments from the industry that the ICGEB yeast require less fermentation time as compared to the currently employed yeast strain. And the advantage of this less fermentation time is that it could lead to reduced potential operational costs such as lower resources consumption and all that. And the alcohol percentage also was slightly higher. However, the efficiency was not very high as compared to the currently employed strains, and it was comparable to that strains. Now moving to the second feedstock, which is grain, there are currently two different types of technologies being employed in the industry. In one technology, they use a non-GMO yeast and the grain celery, which is hydrolyzed using through amylases, external amylases, converted to ethanol. And in another technology, they developed a genetically engineered yeast which can secrete the glucoamylase so that the enzyme requirement is reduced and also the process fermentation time is reduced, and then they make the ethanol from the grain. So in the first case, we tested our strain for ethanol production from this cooked grain celery with substitution of additional enzymes, glucoamylase and alpha amylase, and in a comparative study, ICGEB yeast performed relatively better as compared to the other strains that we have access and currently company is using for ethanol production. However, for the glucoamylase yeast, we have developed a genetically engineered yeast which secrete different glucoamylases, and after secreting these glucoamylases, we have seen that the ethanol production is slightly increased as compared to the strain which does not produce glucoamylase. And similarly, we have also now testing how much enzyme less is required with this glucoamylase secreting yeast strain. So future plan in this for these yeast for 1G ethanol production, either from molasses grain, that lot of industry is now shifting towards the dry yeast as compared to the wet yeast, because during all this process from culture tubes till 160,000 liter, there are chance of contamination and which reduce the sugars, so the ethanol yield and productivity is reduced. So we are focusing on now developing active dry yeast formulation which can directly use for the fermentation of ethanol from molasses and grain. Moving to the 2G ethanol production, you know that 2G ethanol is produced from lignocellulosic biomass, which is a mixture of cellulose, hemicellulose, and lignin. ICGEB has developed enzymes which can do the saccharification to convert this biomass to the glucose, xylose, and arabinose, and we have also developed genetically engineered yeast which can consume pentose and hexose sugars but not completely utilize it. Now we have developed a biorefinery in which a complete biomass can be utilized for production of ethanol, as well as we have developed other bioproducts like xylo-oligosaccharide and xylitol, and we have xylitol. In another approach, we have developed a biorefinery in which we use oleaginous red yeast which can consume both pentose and hexose sugars and can make xylo-oligosaccharides, beta-carotene, biodiesel, and the dried biomass can be used as the field. So these are the yeast which has Saccharomyces cerevisiae. This is like white yeast and red yeast we have developed for different technologies, and these are the different bioproducts we have made. Dry yeast we are working on to make the dry yeast, ethanol, xylo-oligosaccharide, and xylitols. So dry yeast has a big market, and a lot of companies are using dry yeast for ethanol production, and there are potential competitors in this field also. And with this, I would like to acknowledge the people who has worked hard to make these technologies, and then thank you.
Thank you, Dr. Naseem. Now we'll take all you to space. So we have two young researchers who have for quite some time been working with space biotechnology. To continue our discussions, let me invite Prachi, who will be sharing with her experiences with respect to her research project in space biotech. So this is under Youth Voices BioE3 in Space, ICGEB's initiatives. Yeah.
Thank you. All right. So namaskar and a very good afternoon to everyone present. Director ICGEB, sir. distinguished guests, our respected colleagues and friends. I am Prachi Naukarkar, and I consider it is a profound honor to stand before you today to share the story of Indian scientific ambition taking flight. Story of our space microalgae in IND experiment, wherein we are studying the impact of microgravity in ISS on edible microalgae. It's a landmark project born out of a powerful collaboration between ICGEB, NIPGR, and proudly supported by the Department of Biotechnology, Government of India. So it starts where starts with the microalgae, which is the basic, most fundamental form of life. These are nature's microscopic marvels, tiny aquatic plants that photosynthesize, and they harness light and CO2 along with some basic nutrients to produce their own food, which is the biomass, and forming a vital part of our planet's ecosystem. But why are these so important? Why are they gaining so much importance here? First, because of their rapid growth, which is less than 26 hours for some species. Microalgae, they can be cultivated year-round in high densities and in controlled photobioreactors, where they efficiently convert waste CO2 into essential oxygen. Secondly, they are astounding environmental resilience. They are survivors. We have found them thriving in extreme environments, with highly saline oceans to highly polluted rivers with agricultural runoffs, some ponds with industrial runoffs, even wet soils. So this toughness makes them exceptionally well suited for the harsh conditions of the space. So the power of microalgae for space is, we look towards extended missions on the Moon and Mars. Creating a self-sustaining environment for our astronauts is key. So microalgae can offer a revolutionary solution. They can be integrated into a closed-loop life support system, which space agencies have been working on. They generate edible biomass and provide a high-protein, rich food source for the crew. Thereby, they may help in reducing the payloads. They replenish the air by converting the crew's exhaled CO2 back into breathable oxygen. And for that, they can be compactly cultivated in small reactors, and they can be grown in closed spaces, saving valuable space and mass on the spacecraft. So our experiment, the space microalgae IND, is designed to investigate how unique and edible microalgae strains isolated in India and characterized in our own lab here at the ICGEB adapt to the microgravity environment of International Space Station. Our scientific objectives are threefold. One, to conduct a comparative assessment of the growth and physiological changes that space causes with compared to the ground, and to perform an in-depth omic study to understand molecular and genetic responses to space flight and microgravity environment. And through this, to achieve targeted gene identification to pinpoint the genetic factors that can help terrestrial or space biomanufacturing of high-value products, and also improve strains for further future space missions. So the next part of the presentation is very close to my heart. It details the journey from our lab to the launch pad. My role was to prepare the space microalgae IND experiment samples for its historic flight aboard the ICGEB-4. It's called GRACE now. And this involved meticulous work in the payload processing facility at the Kennedy Space Center, where the air vibrates with both rocket fuel and human ambition. I was to perform the sterile integration and strain viability checks on the algae cultivation bags. The precision is the key here, because every tiny detail counts up here, up there, and that has to be validated on the ground. Second, the most crucial phase was the science briefing, where I had the privilege of detailing our experiment protocols to the crew and the integration partners, which help us navigate all our experiment through the crew and make sure that it is executed flawlessly about the ISS. The handover was the final part of the flight-ready module to the ICGEB-4 representatives, and it was a joyous moment filled with a profound sense of responsibility and also national pride. Now, as I watched the Falcon 9 rocket ascend, I am carrying out our word towards the stars. It was a testament to our team's vision. The progress that we are actually monitoring through regular meetings and contacts through the space agencies and the integration partners reminds us that every journey to space begins with countless hours of dedication from those of us who remain earthbound. Finally, this monumental feat was only possible through the spirit of collaboration. I extend my deepest gratitude to the Ministry of Science and Technology and the Department of Biotechnology for their unwavering support all throughout. And a sincere thanks to all our institutes, the ICGEB, the NIPGR, and the ISRO, and our international collaborators, NASA, Redwire, and Action Space. I believe that there are little experiment. The space microalgae is more than just science. It symbolizes the new era of Indian research, where we are not just reaching for the stars, but are actively working to live amongst them. Thank you so much.
Thank you, Preeti. So to continue this session on our space biotech, let me invite Dr. Preeti Rai, whose group is also working on certain strains of cyanobacteria, and whose experiment is currently running at ISS.
Good afternoon, everyone. So my name is Preeti Rai, Dr. Preeti Rai. I'm working with Dr. Shirish Srivastav, and our experiment cyanobacteria on ISS was sent to International Space Station on 25th of June as part of ICGEB mission. So I had the privilege to visit NASA along with our PI and my mentor, Dr. Shirish, and my colleague, his PhD student, Kartika K. So here I'll be sharing some of my experiences for NASA. To start with, first of all, I'd like to thank our director, Dr. Ramesh Sonti, for his help and for DBT to provide me this platform to share my experience. So if we begin with cyanobacteria, they are the tiny plants, and they are like the very first photosynthetic organisms. They are the one who oxygenated Earth's atmosphere, and that's how the animal life has become possible on Earth. And some of the cyanobacteria has been studied, and they are really food protein rich, and they have a very good essential amino acid composition, and they have really good antioxidant property as well. So if we talk about the challenges, I've listed two of the challenges at ISS, where the CO2 concentration is 8 to 10 times higher as compared to what is present on Earth. And the other problem is there is lack of carbon and nitrogen recycling. So cyanobacteria can be answered to both of them. Like we can use urea to grow them, which is a very major part of human urine. And the high CO2 is an additional effect where it can grow better. Cyanobacteria can grow better at high CO2 concentrations. And they can produce a protein-rich, well-balanced essential amino acid biomass for the astronauts here. And when I'm talking about the antioxidant activity, I'm talking about this phycocyanin pigment. This particular one was isolated, purified in our lab, and they have the UV protection property as well as very good antioxidants as well. So if coming to our specific objectives, we have sent 2 different species, and we are growing them on 2 different nitrogen sources. One is on nitrate and the other one on urea. We will be comparing their growth in microgravity and their responses in proteomic and biochemical level. This is what I wanted to share with you at our short NASA trip. The very first picture is our sample which we sent to NASA. This was our mother culture which we eventually used to prepare our payload for integration to ICGEB mission, all the media components and everything. The second picture, this one is the lab we were allotted inside NASA premises. This was a well-equipped lab where we had everything possible for our setting up all our experiment and everything. And I'm really, I was amazed and with the scientific spirit of NASA people. They were always there to help. Although they made this lab, everything was available for us, but even if we are there at late nights or on weekends, they were there and to help and with happy faces they were there. And when coming to this is the lab where we did all our experiments. And our team, as you can see, Dr. Shirish and Kartika is there. And definitely I cannot forget our group captain, pilot astronaut, Shubhanshu Shukla, who is doing this experiment right now in space. This is a photograph from a send-off event for these astronauts. And this was a special moment to see an Indian up there. And it was really a pride moment. And I thank you all, and it was a really honor to see this, our tricolor flying over there. And this is a photograph from same event. So thank you all for hearing. Thank you.
Thank you, Preeti. Now, this was what we're doing in space. Now, we'll bring you back to Earth. So, the food waste is one of the biggest challenges world over, especially in urban areas. Like in Delhi only, the reports are like there are multiple tons of food which is being wasted daily. So what we should do with that food, or how we can use it, in a nice way. So we have Dr. Shirish here, who has designed, something so that we can actually valorize food waste to actually create biogas out of it. Yeah, may I invite Dr. Shirish here.
Good afternoon, everyone. And first and foremost, I would like to thank the DBT for this opportunity to present our research, and also for celebrating the World Bioproduct Day. And I'll be talking about some work that we have done in valorizing food waste into biogas and some other products, of course. And in this work, I would want to also highlight that a lot of this work has been done by my PhD student, Amina Muhammad Ali from Djibouti, who is an ICGEB BiotechNet PhD candidate. Now, I would like to begin this presentation by a quote from Annie Leonard, who is a sustainability advocate. She says that there is no such thing as away. When you throw something away, it must go somewhere, right? And many times in India, we see a lot of our food waste and other waste lying out in streets, making pollution and foul odor and all. So we wanted to do something about this. And actually, food waste is, as Ray's rightly mentioned, food waste is a major problem all across the world. If we talk about Delhi, we generate about 14,500 tons of municipal solid waste every day, and out of which 43% of which is food waste. So every one of us is on an average producing half a kg of food waste per day, which corresponds to over 2.3 million tons a year. For India, if we talk about, we are talking about, again, millions of tons of food waste every year, but more importantly, the economic loss from that is estimated to be about 92,000 crore rupees. Again, going one step further, globally, about 1.3 billion tons of food is wasted annually, which is roughly equal to a third of all the food produced, with economic loss estimated to be about $1 trillion per year. The impact is not only loss of nutrition for a lot of kids that are out there, but also methane release from landfills, which is a major greenhouse gas. And it is estimated that the global greenhouse gases produced by food waste alone are equivalent to the greenhouse gas production by India. So definitely we need to do something about the food waste. What we think is food waste is not a waste, but a potential resource. We know that methane is produced naturally in landfills due to anaerobic digestion. Why don't we replicate the same process in our lab to get a sustainable source of biogas? Of course, food waste is rich in carbohydrates, proteins, and lipids, which can be as a good medium to grow bacteria for anaerobic digestion, especially if you're talking about cooked food waste. It's easy to process, fast to digest, so rapid clearance and higher product formation of methane can happen. Not only methane, but we can also produce other products from digestion of food waste, for example, lactic acid and volatile fatty acids, for other biotechnological applications. Now, coming about why biogas is a good solution for food waste is that first and foremost, it's a low cost, low complexity technology, easy to set up. It generates biogas, which is mainly rich in methane and also contains some carbon dioxide, which can be directly burned to recover energy. We have all seen examples of that. But more importantly, these days we are going one step further and purifying it and using it as, for example, compressed biogas for vehicles to replace CNG, and also to generate power and sell it back to the grid. So the process can be economically viable. And also very, very importantly, the process of anaerobic digestion also generates a nutrient-rich liquid that's called digestate that can be diluted and used as a liquid fertilizer in agricultural practices. So our approach to food waste valorization is, these are the real, for example, food waste that Amina had collected from our canteen. She collected it, and then what is very important here is we developed an in-house inoculum which can now be used for two separate processes. We can use in anaerobic digestion, like this is our laboratory setup where we have set up small scale reactors to optimize the biogas production. And we are analyzing biogas production through biogas analyzer. And we can also do our traditional fermentation to produce lactic acid and volatile fatty acids. So our achievements in this research is that not only we have developed an in-house inoculum for improved biogas production, we have also optimized the process parameters so that now we are getting biogas with more than 70% methane content. Now, typical biogas that you get generally contains 45 to 65% methane, so our methane production has also increased. We have also developed an in-house enzyme cocktail that reduces the time for methane production. Now, with the volatile fatty acids, we are able to produce about 45 grams per liter of lactic acid in just 2 days from food waste, and more than 30 grams per liter of total volatile fatty acids in about 2 weeks. So what is our next step? We want to take our research to society. So one is, of course, we aim to set up biogas plant at ICGEB to valorize all the food waste that we get and circularize our food waste to biogas in a digestate, but also to probably go further and set up biogas plants across the institutes in Delhi, and then for large-scale biogas plants for solid waste treatment. So with that, I'd like to thank you all for your attention.
Thank you, Dr. Shirish. Now we all stand up and we'll have a pledge. We all take pledge. And I invite Director Dr. Ramesh Sonti, can read out the pledge, and we all, with our hands up, will repeat after him.
We, the people of New Delhi, in the state of Delhi, wholeheartedly affirm our commitment to the vision of the Bio-E3 policy of the government, a strategic framework to build a sustainable, inclusive, and innovation-driven economy, grounded in environmental conservation, economic opportunity, and employment generation. Recognizing Delhi's unique scientific, ecological, and cultural context, and the immense potential of our scientific and biological resources, we pledge to implement the Bio-E3 policy with dedication and leadership, guided by the following principles and priorities. Promote and actively collaborate on bioproduct innovation to unlock local and national potential. Establish and promote biotech innovation hubs that drive a regenerative circular economy. Enable biomanufacturing hubs and industrial scale-up for clean and sustainable production. Generate employment and build green skills, especially to reduce, recycle, and repurpose waste. Ensure bioethics and equity across all aspects of bioeconomy. Development, respecting community rights, responsible science, and just transitions. We recognize that the future lies in an economy that regenerates rather than depletes, empowers rather than excludes, and embraces future technologies to co-create with nature. We pledge to lead our state and our nation toward a bioeconomy that is inclusive, climate resilient, ethically grounded, and globally competitive. Thank you. Back to DBT.
Sir, thank you ICGEB for bringing in the enzyme component clearly and how it could be important for taking forward the, initiatives under the Bio3 policy. So with this, we will move to the INSTAM Bangalore, and without wasting time, I will request Director INSTAM, Dr. Manisha Inamdar Madam, to start the program with introductory remarks from you. Thank you so much. It's over to you.
Any presentations you say?
Good afternoon. Can you hear me?
Yes, good afternoon, ma'am. Please.
Yeah. Good afternoon, and it's a true pleasure to stand before you today. Our theme is the second life of science and industry, and this really invites us to reshape the future, or in other words, regenerate, which is in fact the mandate of INSTEM. And so, as you all know, bioproducts are materials that can be made in a renewable way from biological resources. And this second life that we speak of is an area in which INSTEM has been really proactive in investigating the deep science related to this by the way of stem cell science and regenerative technologies, developing these technologies that can impact clinical research, that can lead to medicine and impact society. So for this, we have various programs, especially to start at the beginning to build capacity, capability in this area. We have the ESCORT program, which is the program enabling stem cells and organoid research and training. This really has been a major emphasis at INSTEM and has been really well received around the country, because if one has to talk about bioproduction and renewing from biological materials, one first needs to understand how to handle these materials, how to handle the cells and the various reagents required in a manner in which you have quality, you have control over this quality, and then of course you have expansion or regeneration. So starting off on this, we have built other programs, especially focusing on, let's say, women's reproductive health, the program called Birth, where we are trying and developing ways which will help for better bioproducts that give women better choice in their reproductive health. And we also have recently set up a center which was reviewed by the Honorable Minister, Dr. Jitendra Singh, a couple of months ago, which is the Center for Research, Application and Training in Embryology, which will again develop or enable developing innovative therapies in early human development and embryology. So these are just some of the examples, but we've developed a wide range of technologies at INSTEM, not just in the bioresource space, but combining our expertise in chemical biology, have several biomaterials, novel drugs, medical textiles, and of course, cell and gene therapies. And today our program is designed to give you a brief glimpse of all of these various ways in which we are sort of on board with the theme of the BioE3 or the BioE3 way, which is for economy, environment, and employment, to sort of have an impact in these areas, promote science, entrepreneurship, and build really the next generation of scientists and researchers. And for this, of course, like I said, we have training, taking it forward. We have a lot of innovation, multiple products launched into the market, and really going from the lab to the living room. So from startups, to classrooms and back. So this is what my colleagues will talk to you about today, and I will hand over to Professor Praveen Damula, who's the Dean of Research at INSTEM. Thank you very much.
Thank you, Dr. Manisha. Next, we will have a brief presentation, like a way to showcase our success in recent success in bioinnovation. To present that, Dr. Rubin and Dr. Mohan is there at CSCR Vellore and a center at Center for INSTEM. Gurvin, these are yours. Can you start sharing your presentation?
Yeah, sure. Can you see, sir, my presentation?
Yes.
Okay, so very good afternoon, everyone. First of all, we would like to thank the opportunity given by Department of Biotechnology, Government of India, to present our efforts from in last 7-8 years to develop gene therapy for hemophilia A by using stem cells. We have been working on this product, and we have recently conducted phase 1 clinical trial. So I will take you through the journey that I was personally involved, where we manufactured this product, and we actually took these products from lab to the clinics in the patients. So actually we have been working on this from last almost 6 to 7 years, just to show you the amount of effort that has been put into this. let me introduce what this problem is that we are working on. So, as you know, the hemophilia is a genetic disease. It has two types. One is the factor VIII deficiency, which is called the hemophilia A, and then you have factor IX deficiency, which is hemophilia B. And you know that these patients needs actually frequent infusion of either factor VIII or factor IX. So in terms of classification of hemophilia, you can see that there are 4 types here. So the one which are the most affected are the severe hemophilia patients, which you can see at the bottom, which has less than 1% of factor VIII. And then you have what is called a moderate, 1 to 5%. And then you have the what is called the normal, which is like 50%. So our aim here is actually to develop this gene therapy product for patients who has factor VIII less than 1% and they are highly affected by this disease. So as you can see that these patients actually take 2 to 3 times injection per week, and they also can develop inhibitors against these recombinant proteins that are infused. So the goal of our therapy is to actually increase these factor VIII in the patients. The patients can themselves produce this factor VIII, and they don't need to take any injections for their day-to-day life. So there is actually a great unmet medical need in this country where we need to have these drugs developed, the gene therapy drugs developed for people who can't afford these factor VIII or factor IX infusion, which are like very expensive. And I also mentioned that these has to be infused on a regular basis. So what are the efforts going on worldwide? There are number of clinical trials that are going on as far as gene therapy for various genetic diseases is concerned. So there are trials which are based on adeno-associated viral vectors. So you take the gene and put them into AAV vectors and infuse directly the vector into the patients. And there's another effort where people are trying to take the cells out from the patients, modify them with lentiviral vector, and then infuse them back into the patients. So there are like products that are being developed on AAV-based gene therapy, especially for hemophilia and other disorders. But there are limitations, various limitations of AAV-based gene therapy for specifically for hemophilia. So actually there are the people who, when we looked at the patients from hemophilia A patients in India as well as in other countries, that we can see that large number of patients are already having pre-existing antibodies against these adeno-associated viruses. So if they have the antibodies already, when you infuse this AAV viral particle, they will be neutralized and they will not be effective. And also the AAV-based viral vectors has a very small packaging capacity, and it's also quite hard to make these adeno-associated virus because they are actually inside the cells. You need to light the cells and then purify the virus. And the other thing is also that these AAV-based gene therapy for hemophilia, we cannot be given to children because this is episomal in nature. That means it doesn't integrate into our genome, and their liver is growing. So over the time it gets diluted and it will not be effective. The other thing is that when you infuse AAV virus particle, there is a strong immune response, and this immune response also needs to be managed by using steroids and other things. Whereas if you use lentivirus based therapy, we can overcome these problems of pre-existing antibodies against AAV and then immune response, as well as they can be used for children's, the pediatric patients whose because the gene is integrated into the genome. So what we have done is I'll take through the product that we have developed over the years, the effort that we have put, which is actually a lentivirus based gene therapy for hemophilia, and this is the first time in the humans that has been done. Other people have done with adeno-associated virus based approach, but we at INSTEM and CMC are the first one to do the lentiviral-based approach for treating hemophilia A patients. So the concept here is basically to take the hematopoietic stem cells. So we are combining the expertise that we have at INSTEM and CMC expertise of stem cell culture expansion. So we actually isolated these hematopoietic stem cells from the bone marrow by mobilizing them. By using the GCSF, we can mobilize the CD34 cells into the peripheral blood, and we can collect these cells. And then we have to transduce with the lentiviral vector, and then those cells will differentiate into monocytes, and we have a monocyte specific promoter here that will produce the factor VIII. So this is the lentiviral vector construct that we have used. We have a factor VIII gene with a CD68 promoter, which allow these factor VIII to be produced and secreted from monocytes. So before taking this product into the clinics, there are a lot of preclinical work that was done, and this was also done with collaboration from Emory, where we actually took the stem cells from the mouse, transduced them with the lentiviral vector, which will integrate this gene, factor VIII gene, into the hematopoietic stem cells, and then it will produce the factor VIII in vivo. So you can see that with a vector copy number of 1, these mice were actually producing almost normal level of factor VIII. We also did another study where in the immunocompromised mice, where human HSCs were taken, and they were transduced with the lentiviral vector, and they were transfused in these mice, which are hemophilia mice, and then we can see that these hemophilic mice were actually producing factor VIII in sufficient quantities. Then we moved on to the clinical manufacturing of this product, which is our specialization that we can do in the GMP facility here at CSCR. And what we did is basically it had two components of treating patients. The first part is where we mobilize these stem cells by infusing GCSF and plerixafor into the patients, and then we do a apheresis where we collect these mononuclear cells, and after that we do purification of hematopoietic stem cells, which are CD34 positive, which undergoes activation in vitro, and then they are actually transduced, and then they undergo all the quality control parameters testing. And in the second part, once the product is ready, it has been tested, and it is ready for infusion, we take these patients, which are actually, they undergo conditioning regime, where you destroy the bone marrow cells from these patients and create a space for the genetically modified cells to be infused, and so that they can home to the bone marrow and they can transplant and start producing factor VIII in this case. So this is the approach we took, where we used a system from Miltony, which is called the Clinimax, which is used to, you can see the product hanging in red color on the machine, and then we have CD34 purification by using these machine in large quantities for the trial. We followed a very robust process of making these product, and also the in-process control that were used to actually test our product for different parameters before putting into the human beings. So our actually drug product that we have developed is basically CD34 cells, which are modified by lentiviral vector, which has factor VIII gene, and this is the product that can be infused in these patients. So we conducted a phase 1 clinical trial with making this product. So our objective was to look at the safety and the possibility of doing this in humans, and also assess the some of the efficacy parameters. The main inclusion criteria for these patients were that they should be severe hemophilia patients. Like I said in the beginning, that they should have less than 1 IU per deciliter, the factor VIII. That means they should be severe in nature, and then they also should have a history of exposure of at least 100 times with factor 8, recombinant factor 8, and we know that they do not develop the antibodies against those recombinant proteins. So these were the two main criteria, and then we also can include, as I said, the patients which actually has the neutralizing antibodies for AAV. They cannot be used for AAV-based gene therapy, so we can use for the lentivirus-based gene therapy. And we have actually put a lot of effort to get this done. Like we have obtained various approvals for clinical trial and for manufacturing of this product, and also from different licensing authorities like our CDSCO and state licensing authority. So this is actually our data that we collected these cells from 5 patients. We obtained a very good number of up to 591 million CD34 cells. And our viability of the cells was more than 95, 96%. And then we did a transduction where we also obtained, we did a cryopreservation of the transduced product. And again, after thawing, our viability was again more than 95%. And our vector copy number was from 1 to 2. And after transplant, this is the actually outcome. You can see in these all the patients in terms of engraftment. You can see that all these patients started producing neutrophils from the transplanted cells within 10 to 12 days. And you can see that they also started factor 8 production. And you can see that the factor 8 production ranges from 1.7 to almost 40%. And this is what we actually published in New England Journal of Medicine, where we showed that these patients can be treated by using this gene therapy product, which is based on hematopoietic stem cell transduction. And you can see the 3 patients on the top, which are showing very good factor 8 activity, were actually, we also standardized our protocol with transduction enhancer, which shows very good activity in the range of 40 to 50%. And then the first 2 patients that you can see on the bottom, those actually are the without transduction enhancer. So we actually also found a much better protocol where we can transduce our CD34 by using transduction enhancers, and we can raise our factor 8 production almost to normal level. And you can see in terms of the outcome in the patients, you can see before gene therapy, they had a spontaneous bleed, different number of bleeds, different patients. And the interestingly thing is that all these has actually stopped bleeding, and the bleeding was 0 in all the patients. So there are a large number of products that have been actually being developed for different, as I said, for genetic diseases. But you can see there's only one product, which is AAV5 based. It's called the Roctavian, which is 2.9 million USD, which is almost like more than 24 crore for one injection. And even other genetic disease products are very expensive. So what we are trying to do is use an approach which is affordable, and we can develop these products at InStem and CMC to at lower cost to benefit our patients in our country. So what is the unique thing about our product is that it can overcome the neutralizing antibodies, which cannot be done by using AAV-based method, and then it is actually suitable for pediatric patients, as I said, that it can be given to children whose liver is still growing, and this can also overcome the problem of immunosuppressive therapy that is given to the AAV-based gene therapy, which is not required in the lentivirus-based gene therapy. So we'd like to acknowledge all the people who have contributed, our scientists, our clinicians at CMT Vellore, and our collaborators from Emory University, and a great support from Department of Biotechnology, who had supported us to take these things forward. Thank you. Over to you, Dr. Parveen.
Thank you, Gurbin. Are there any quick questions, like either online or offline? I'll take a minute. Or if you want to ask a question, you can even type a message as well. So meanwhile, I just want to summarize, like, typically if you see in biotech industry, right, like it's not like a one innovation or one breakthrough will take your entire technology to the market. You need to have a series of innovations that takes each step. At each step, you need to make to the bring to the market. And this shows, like, this is a perfect example what we are experiencing, right? After they developed their first breakthrough technology, but that wasn't like actually sufficient to conduct entire clinical trials in a large scale, right? So that's where, as a great process innovation has been done at instance ACR, that led to successfully complete the phase 1 clinical trials. So that shows us, like, its innovation doesn't just start at one step, or doesn't stop at one step. It has to be done, series of innovation need to be done. So that's a great example. And thank you, Gurbin, for that entire summary. If there are no further questions, maybe we can go ahead with our panel discussion. And I invite Professor Minaj to connect this, being moderator for this panel discussion.
Hello, good afternoon, everyone. Thank you for coming online and also offline. Today, as we are celebrating this World Bioproduct Day, I must start first thanking the DBT for organizing this wonderful event, and which is also in line with our Bio E3 policy, which has been recently announced by the Government of India. So we just heard a wonderful talk from Dr. Gurbin about their efforts at Instance CSCR and CNC Vellore about making a product which is actually benefiting the society. So let's also hear from our Instem scientists here what they have to say about the bioproduct and their efforts in making new bioproducts which is going to benefit the society. So with this, I would like to invite Dr. Praveen Vemula and Dr. Sunil Lakshman, who joined the panel discussion. Yeah, and also Dr. Arvind Raman. So if I may request the panel members to introduce themselves. I'm Dr. Arvind Raman. I work on muscle homeostasis and sexual degeneration.
I'm Professor Praveen Vemula. I work at the Institute of Technology.
I'm Sunil Lakshman. I work with cells on pathology.
Thank you very much for joining us today. So I would like to start with asking Dr. Praveen about his efforts in making products at Instem and also how these products are taking into the market. Can you please elaborate on the idea behind that and also the process that goes behind that?
Thank you very much. Yeah. So just to summarize like what you just for our lab, like fundamentally at the Instem, like our philosophy is like, once I like focusing on doing the deep science research developments of these technologies, but at the same time, like, bring them to the market for the field. I think that's what we are doing and focus. Whatever the technology we develop, whatever the knowledge we develop through that, like, that has to be disseminated to the market. So, and being that philosophy is like what consciously we took a decision for our lab is like, where focus will be focused, like what we say. Because we do not have like the one single area, one area of interest. Rather, it's a need-driven problem what we select for, like where you identify huge unmet need, where you can, the shortlisting of problems in our lab, what happens is, even if you success 50%, that should have a huge impact in the findings. So That's the way like we will solve the problems and identify the problem. And the technology what we develop, it's a wide array of technology from drug discovery and drug delivery, medical textiles and devices and so on. Just to give you one example, to like you are aware of like developing technology to protect farmers, which is like the farmers are being like the backbone of India, and they primarily suffer with the side effects they cause when they get exposed to the strain. That's why we, almost like 6 years, we worked on this technology, which is like not only very efficient, but it's also completely user-friendly and it's completely affordable and reusable and so on. That's why we developed this anti protective suit, which can efficiently deactivate all of the cybercriminal content. And that has been launched by Honorable Prime Minister in December 2024. Since then, thousands of farmers are being used across the country, and we have seen phenomenal feedback from these farmers. And what we are seeing is that we are seeing the 100% success rate. One person used one time, they are not staying with our region then because they see the instant results. So that's just to give a the kind of work that what we are doing at ICGEB and which makes an impact on society. And another just so one quick example what we want to tell is like this is like a not one-off example work. It's not an accidental discovery, but at the same like this is constantly instilled in all the researchers as well. Develop the technology that can actually solve a real life problem. And to enable that, I think it's like very fertile ground, like and policy structures, administrative support to transfer that technology to one, like being like having really robust IP policies, like how to find like the best IP, how to protect it, and also enabling like PIs and students and postdocs who forms in our companies. And subsequently, like, you need to have a robust IP licensing process. The tech transfer is important. I think they do really well, that's all. And cumulative all these effects are like showing the results now, like multiple technologies coming out of these. Maybe I'll take this liberty and I would like to ask you like to share one of your examples, like maybe your nanobody invention that could be used for the diagnosis or maybe people of such.
Okay. Well, thanks, Ravi. Yeah, so I think I will just highlight what Ravi just mentioned, that ICGEB has this robust policy of IP and also technology transfer that enables all the scientists and including the PIs to hold form company, hold shares, and also do innovative work outside their academia. So thanks to the leadership and also the predecessors who have set up a policy like this, I also benefited from this, and we took out a nanobody platform technology which can be used for developing novel biologics and also therapeutic products or diagnostic products. So I think like the potential is huge when we're talking about this in a world bioproduct day. People think about conventional IgGs as a way to think about nanobodies. But the nanobody platform technology can be used to make mini antibodies, which has a purpose of re-engineering becomes much more available. So altogether, I think like it has a completely different class of applications which can be made use of. And that's something that we are actually working on both in our lab in ICGEB but also in the industry. So I think we should quickly move on, and then like I would also ask Dr. Alvin, what is his experience on? Can you elaborate on this idea of bioproduct and what kind of translation research he's aiming or preparing for his lab? Okay, so people who are online, are you able to hear us clearly, or if anyone can confirm, that would be great for us.
Now it's better. Now it's better.
Great. Thank you very much. Can we continue that? Yeah, please sir.
Thanks for the question, Vinod. I think it's a really good opportunity to again highlight how what an enabling environment you have to leadership and to explore new frontiers in science. I think apart from my lab's direct work, I think I really want to highlight that this environment has enabled now instant to push frontiers of where sensor science and biomanufacturing is going to go. As many of you know, we are actively working with ISRO and NASA and the space program to conduct stem cells work, especially specifically skeletal muscle stem cell work in space. Right now, Group Commander Shukla is really leading the charge here in terms of enabling us to do this. Now, I really want to highlight this because we know it's a national mission now to make sure that we are helping the country move towards space biomanufacturing and really develop microgravity as a real unique opportunity for our country to be. As many of you know, microgravity, the lack of hydrostatic pressure, the lack of convection, the lack of weight itself, gravity itself, really gives you an opportunity to make very special biomaterials. And this is just a frontier we are only beginning to explore right now among other countries. So this is something that I am truly excited about, that we have now opportunities to start thinking about space and space-like microgravity as a way for biomanufacturing, completely new biomaterials humanity has not even thought about yet. But in that context, I want to specifically mention that as we try to accelerate this area of research, and there's a huge need for it, instead of playing a pivotal role in trying to simulate microgravity on the ground. Now, of course, at all times we're experiencing microgravity, but there are some very innovative technological solutions which can give you as best as possible on this earth to give you time averaged microgravity. And we are in the process, we have built it in the process of patenting it to extent. It's a product called InnoStem, where this is going to be validated for stem cell use and really high-end cell culture biomanufacturing use. I just want to say this is not a small feat in terms of there are some talented bioengineers in the lab who are trying to make sure that we have a robust system that we can with confidence say is simulating microgravity on Earth. Also want to say that a space like this also enables us to work directly with ISRO to try to validate these kind of instruments. So I'm seeing an amazing future ahead of us, for all the young scientists here, that maybe in a scalable way we'll be able to simulate microgravity on Earth using instruments like ours that are being built. And through that, maybe you and Praveen and others can start thinking about, and we, and really all of us can start thinking about different kinds of biomaterials, biologics, that not only for making special properties on Earth, but also as we get more ambitious and try to build our own space station and we're trying to enable space health for our astronauts, we can even make a pivotal contribution in that. So I'm really excited about that future. Thank you, Arvind. I think space is the next frontier, which should seem to conflict. But now, I understand that there might be some questions, but let's hear from Dr. Sunil also about his efforts, and then we'll open up for questions. Dr. Sunil, can you please explain us what is your idea of bioproducts and what is the efforts going on?
Thank you, Minaj. So it's very clear that in the next few years, the biggest technological growth is going to be what we call green chemistry and biological chemistry, which means we now start using the cell as a factory to make complex molecules. To do this, we need deep scientific knowledge on understanding metabolic networks, how to rewire them, so that we can now take a cell A and ask it to do things at a scale at which it would normally not do. And by doing this, you can make high-value biomolecules, and this then can be scaled at a much larger scale. So this requires you then to start thinking of efforts by which you could engineer the entire genome while optimizing metabolism and make the cell adapt to chemical requirements that it would normally not prefer. And that's really the space where we're starting to think a lot more about in re-engineering the metabolism of cells so that they would produce outputs that are relevant to the context, which means you could use this to make new biomaterials, make small molecules of natural origin, but you could no longer rely on some rare plant that you have to grow at 10,000 feet altitude to cultivate.
engineer this whole pathway in a cell factory. We can also do this with small scaffolds to build different types of collectors of cells and so on. And this then is really going to be one of the features of biotechnology. It's already happening in many parts of the world. And we would really like to see this component take off in India because this has tremendous potential.
Great, thank you very much. Now I would like to ask if there are any questions from audience here at our center and also online. Please send us any message here so that we'll be able to get back to you on the questions you have. But while you're getting your thoughts, I just wanted to ask the panel members here. Now, you have mentioned about your efforts on making bioengineered products, bioproducts, which are clearly beneficial for mankind or to the earth. Now, can you elaborate, any one of you, what kind of efforts are going on in the area of stem cells related to biomaterials? Maybe you can mention something about that.
Yeah, so I think I give examples to the biometric context because when you say stem cell based discoveries and technologies like tissue engineering is one of the major area like where a combination of both deep understanding about the cell biology and the materials can be combined. Because we're given, like, just to take an example, like organ transplantation, right? Like given that, like your demand for the organs is so high, and there's always long waiting period for the donors. So people have started exploring how we can engineer an organ in a niche which can be transplantable, right? So, and that's where you have equally your sensor biology knowledge that's be combined with the deep material science, where you can give the scaffolds, develop innovative scaffolds, and give that microenvironment with the right biological cues it can give and the physical cues it can provide, so that sensor can be differentiated into the kind of your targeted organ it can be generated. There's a lot of earlier success have been happened, and I think whether these are ready, they're yet to transplant in human, they're not there yet. But the early success, what we are seeing as this changes tremendously drug discovery programs which impacted. This is the first stage success, I would say, because often developing drugs and doing the extensive safety and toxicology studies required a huge number of preclinical animal trials and so on. That can be reduced with the human as well. So, and also costs also can be reduced significantly. And people started using this entire knowledge about where the tissue engineering was organ on a chip based models, which actually driving the innovation in the drug discovery programs. And for the transplantation, we have another example. For example, modern tissue engineering people have come up with the ghost organs transplantation concept, where you take actually organs from porcine models and so on, decellularize and repopulate with the stem cells, which can was an organ and transplanted. And in this area, you see the Wake Forest Institute as a pioneer, and the first synthetic ghost organ for the use of fetus transplantations have been done routinely and very highly clinically succeeded. That's why I think the interdisciplinary where multiple disciplines meet and share the knowledge on this innovation.
Thanks. Well, I think the panel members have given us food for thought. I would like to ask question. First is Dr. Manish.
Thanks very much. So the panel has given us some really wonderful insights, and that's I think everybody has learned a lot from that. I have a specific question for Dr. Sunil. All of us have studied biochemistry at least at some level, and I'm sure everybody appreciates how complex these pathways of controlling and regulating enzymes or metabolism are. And what we learn is that everything has to be tightly controlled. How some examples practically of what we might?
This is actually a truly wonderful question. So just to kind of summarize that, essentially, your textbook knowledge says every step in biology is tightly controlled or regulated. But it's very clear that when you're dealing with large chemical processes, it is actually not, the outcomes are not driven by every step that is tightly controlled, but by pushing collective directions of flux. And so, in the engineering cells line, the old approach used to be to overexpress one enzyme or two enzymes. And over 20 years or so, it failed. It really didn't do much to the cell. That's because of this exact reason that outcome control is not at the level of a single individual gene or enzyme. And so, to beautifully summarize this, essentially what we need to do now is reorient entire programs and cells. And people are thinking of doing this in two different ways. One is to drive combinations of transcription inputs with varying success, so different combinations of transcription factors that you control using controllable switches. And the second is to drive flux through pathways by engineering exogenous pathways that will change the cofactor pools available and so on. And it's still early days, but the second approach seems to be yielding much more dramatic or visible outcomes in terms of overall cell outcomes. So this is actually a very exciting current area of research, but there are now some several really nice specific examples that have come out where they're reprogrammed cells. So using this kind of an approach, and this is happening at different scales. One is specifically trying to reprogram, say, stem cell differentiation outcomes and so on, which is a very exciting area of research. The second is in this other aspect where we are trying to make cells to make molecules that they wouldn't otherwise make. And in particular, these are for small natural molecules that have been proven in context of regeneration and reprogramming of cells, which you can't chemically synthesize easily. But you divert flux now in exogenous cells, say, in a mammalian cell or other eukaryotic cells, to overproduce this by re-engineering flux towards this pathway. So you use this as a way to make these molecules now at an available scale that can be used in anything more than a lab environment. So both of these outcomes are now proving to be very exciting, and this is the cutting edge where especially institutes like ours are poised to go towards and set up those technologies and abilities to do that at scale with biotech.
Yeah, please. Just to add to that in the cultivation process, so when you talk about the stem cell in particular, any in general cell therapies, right? The scalability, scale-up process, one need to keep it in mind, right? Like, because any cell therapy, if it's not scalable, it's not viable. And as you know, it's from T20, T25 to T75 class when you move on from it comes. And making this clinically large scale production is one of the biggest challenges. So when you talk about cell therapies, it's as much as biological problems, it's engineering problem as well. I think at the same, I think that it's also great effort we need to put it to see like as we develop in technologies or this, even early discoveries in cell therapies, like how one can develop robust scale-up processes, can set it up. I think that is one great area we should also focus on, and I really like to do that.
That's right. So, students, you have an opportunity to ask something to three faculties who are yes, you can ask me also. Now, World Bioproduct Day. What is on your mind? Okay, I will ask one question to Dr. Arvind also. So, when you see gravity, how can we easily simulate this in the That's a great question. So how do we, we have grown for billions of years with this one G pulling us down. How do we break that? There's maybe three ways of doing it. One is you can go to a mine shaft and drop something down for those few seconds when you're falling at zero G, and there are people who use that. But that's for a very short period of time. And then of course you have heard these hyperbolic, the parabolic flights. And that's again for maybe 30 seconds. For certain physical reasons, you do not have G. And that's really are the two ways, and about But 3 or 4 decades ago, so NASA also provides this facility. It's called a 3D clinostat. Okay, there are 2D and 3D clinostats. What does that mean? This is the best, which is essentially the gold standard at this point. Is that at all times, if there is a vector of force pulling you towards the center of the Earth, what if you take a small space, a little, and spin it in multiple directions throughout time? Okay, so you spin it in such a way, and there is a certain physics behind how you engineer these rotation systems. And people are studying this theoretically. But if you essentially have two axes, if you will, one axis is sample is spinning like this. At the same time, there's another axis going like this. And you randomize this with certain ratios. Now, for any given time, the sample is always spinning sometime in space. And it's such that now, over a period of time, the resultant vector of force that is pointing to the center of the Earth is minimized. So we are at 1g, and let's say the moon is about 16% of Earth, and Mars is maybe a little more than that. And what we experience in the International Space Station is 10 to the minus 3g. So now with instruments like this, which we have built, and then how do you know how much g you experience? Your cell phones have an accelerometer, excellent accelerometer actually. Your Apple watches have accelerometers. This is how it knows when you're falling or how fast you're running. And so there are some better military grade accelerometers which are also available. So essentially, that can in real time measure acceleration. So when we take these accelerometers that are available and put it in a 3D clinostat, which we have built, I'm always happy to show people that, because it's taken a lot of effort for a couple of years to build this, that if you actually put the accelerometer and you start using the instrument, at about, right now we want to get it as close as possible, but within an hour, it drops to about 10 to the minus 2. And we're working on trying to get to 10 to the minus 3. So that is how we can do that, and you can see the opportunities open up now, is that if you start putting biomaterials and other things in there, it can over time start experiencing microgravity, and we can study different properties. Now we work on cells. We're very interested in understanding how stem cells act in microgravity, which you can imagine has huge therapeutic implications. So that's how we do microgravity.
That's available at Instagram.
Yes, it's called clinostat.
That's helpful. Well, I mean, I think we are getting close to the allotted time slot of ours. I mean, I'm still hoping that there will be one or two questions from students. If not, then we'll thank the panel members, and I hope you get the study. Thank you.
Thank you very much. Now we will have a presentation by a student in India. So this also showcases one of the technologies that has been developed at ICGEB, which led to form a spin-off company. And the primary focus of this technology this company is to develop ingenious technologies which can be affordable and accessible to enable the research ecosystem in India. So, over to Shirja.
Thank you so much, Praveen. So this is gonna be my first short presentation. I hope I don't cry after leaving this hall. So, hello everyone. I'm Shira Zahad from Professor Praveen Kumar Vemula's lab. And today I'm going to talk about two technologies developed in Sternus Biotech, which is a spin-off company established at INSTEM. wherein our main focus is to develop indigenous and affordable reagents for biomedical applications. And today I'll be talking about two technologies. One is development of transfection agent. Another one will be developing of novel ultra-low attachment plates.
Dr. Mohammed, can you put it in a full
Full
mode?
screen.
Full screen mode, yeah, please.
You have not shared the complete entire screen.
Yeah, yes, yeah.
You can hide the, yeah.
Yes,
Thank
yes. Thank you.
In all the academic labs, what happens, we are heavily relying on imported reagents. But the problem is that they are highly expensive. And often because of this high cost, often just because they are highly expensive, that cost exceed the academic budgets. Moreover, since these are imported reagents, they have long and unpredictable lead times. So due to custom delays, inconsistent vendor response, etc., as a result of which research timelines and throughputs are compromised. Still, people opt for these imported reagents only. Why? Because they do not have enough access to domestic alternatives. Considering all those factors, we have come up with a technology called as knock-in, which is an indigenously developed transfection agent. Now you will ask me why choose knock-in? Because it's highly efficient, it works across various cell types, and it's also low cytotoxic, it's cost effective. This has not only been validated in our lab, this has been validated at different institutes within country. And these are the representative images of our developed transfection agent when we compare it with commercially available lipofectamine 2K. You can clearly see that our transfection agent gives better transfection with less cytotoxicity. And these are the representative fluorescence microscopes of BFE transfection, in which you can clearly see that our in-house developed transfection agent is giving better transfection than lipofectamine in various cell types. And the biggest problem again is high cost in the commercially available transfection reagents. Here we are planning to reduce that cost to 24,999 per ml, which is 60% lower cost compared to the existing products. Another technology that I'm talking about is yoga plate, which is an alternative to ultra-low attachment plates for spheroid or organoid culture. Here you can see ultra-low attachment plates is an established model for 3D organoid culture. And here we are trying to develop plates which will mimic ultra-low attachment plates. And these plates that we develop are available in all standard tissue culture plate formats. Here you can see this is the human embryonic kidney spheroid formation in yoga plates, which are our developed plates. And when we compare them with ultra-low attachment plates, which are commercially available, spheroid formation is more or less similar. And here we try to culture gastroloids, which is a 3D model for studying embryonic development. Here also you cannot see any significant difference between the two plates. Plus, we are also reducing cost to a greater extent. Like if you get six plates from Green and you get it in 30K. Here we are reducing the cost to 800 rupees per plate, which again reduces the cost to greater extent. So that's it from my side. I'm ready to take questions, and since we have these products available in our lab, we are ready to collaborate if you are interested.
Thank you, Shirja. Now I would like to Now I would like to invite Dr. Lata for taking a pledge. You all can stand up, please.
So yeah, now is to the pledge to advance the Bio E3 policy for sustainable future. We, the people of Bangalore, in the state of Karnataka, wholeheartedly affirm our commitment to the vision of Bio E3 policy of the government, a strategic framework to build sustainable, inclusive, and innovation-driven bioeconomy grounded in environmental conservation, economic opportunity, and employment generation. Recognizing our state's unique scientific, ecological, and cultural context and the immense potential of our bioresources, we pledge to implement the Bio E3 policy with dedication, leadership guided by the following principles and priorities. Promote and actively collaborate on bioproduct innovation to unlock local and national potential. Establish and promote biotech innovation hubs that drive a regenerative and circular economy. Enable biomanufacturing hubs and industrial scale-up for clean and sustainable production, generate employment, and build green skills, especially to reduce, recycle, and repurpose waste. Ensure bioethics and equity across all aspects of bioeconomy development, respecting community rights, responsible science, and just transitions. We recognize that the future lies in an economy that regenerates rather than depletes, empowers rather than excludes, and embraces future technologies to co-create with nature. We pledge to lead our state and our nation towards a bioeconomy that is inclusive, climate resilient, ethically grounded, and globally competitive. Thank you.
Thank you. Now it's over to NCCS Pune.
Thank you. Thank you, STEM Bangalore. And now we move on to NCCS Pune. I request Dr. Bhagwat to kindly take over the proceedings. Over to Dr. Bhagwat, NCCS Pune.
So good afternoon. As we celebrate this remarkable event of the World Bioproduct Day, the Bio E3 Day today, I think today we've really witnessed all the voices across the cities so far have emphasized how bold and visionary India's Bio E3 policy announced by the Honorable Prime Minister Shri Narendra Modi ji really is. This is especially because it has culminated in several efforts all over the nation, and all these efforts are channelized towards holding the promise and actually witnessing the promise to advance responsible biotech innovation towards the development of safe, scalable, and sustainable technologies. Over centuries, urbanization has catalyzed the rapid adaptation of technologies and their developments and their applications towards improving the quality of human life. I'm sorry, I'm waiting for my presentation to be available.
See the entire screen that this is YouTube. Stop sharing. Stop sharing.
Log out from the conference. So can you see the presentation? You can see the presentation.
So they go to the field. Look at the three dots. Three dots. Yeah. There is a two schools. They can be for us.
Can you see my presentation?
Yeah.
Yes, the presentation is here. You can delete the small pop-up screen which is coming at the bottom. You can just cross it. Yeah, this one.
It's fine. Check it. It's fine, I think.
It's fine.
This can be crossed. The small screen that is appearing. Yeah, can be crossed. Yes, full screen.
Is it okay now?
And then duplicate slideshow. Yeah, okay.
That is creative.
That is creative. So as I was saying, over the centuries, urbanization has catalyzed the rapid adaptation of technological developments and thereby contributed to a huge improvement in the value of human life. Yet, over the years, we've realized its associated challenges. In addressing these, the most likely to be effective solutions will necessitate an integration of sustainable practices into city living. Towards achieving this, biotechnology in the context of urban biomanufacturing and industrial waste utilizations will play a major role for the creation of resource efficient and environmentally friendly urban ecosystems. So BRIC NCCS has always been committed to addressing societal problems, especially those relating to healthcare. Over the years, identification of innovation gaps has been pivotal in the development of technologies and resources at NCCS. A further step that we now visualize taking ahead is the establishment of a bioengineering research center, or the BRC as we call it, that will actually be useful in leveraging the technical and innovative strengths that we have achieved through partnerships with the academia in the past years, but also by engaging with society as well as industry partners. Now, the industry engagements are especially important in a city like Pune, which is already recognized to be an industrial hub with the chemical industry, the automotive industry, the IT, as well as biotechnology related industries that strongly impact the economies in our ecosystem and play an important role in development of the city. So what we visualize at BRIC NCCS is actually apply our the research that we do in developing and as well as the state-of-art infrastructure and facilities that we house at NCCS. We will actually channelize them into developing specific strengths using genetic engineering and synthetic biology to actually focus on developing some of the leaves that we have from our biobanks, the human and animal cell lines, as well as the microbial repositories that we have as our holdings. Our capabilities in computational analysis will also be pivotal in this towards bioprocess development as well as establishing proof of concept technologies. And these will be possible through the implementation of the classical synthetic biology, biofoundry type of approaches in the form of closed loop projects wherein we will design, build, learn, and test and learn towards establishing these processes.
So the vision that we have to take ahead is the establishment for primarily of a microbial biofoundry that will leverage the holdings in our microbial repository that have been collected over the last several decades. And the purpose of this particular effort, which is funded by the Department of, which has been approved for and funded by the Department of Biotechnology, is the development of chassis organisms, which will be a step ahead in making ourselves actually Atmanirbhar by actually trying to recover some of the or save from the licensing costs that we otherwise are bound to pay. Apart from that, we also have a vision of developing several cell-based diagnostics or therapeutics and drug deliveries. And apart from just establishing a proof of concept, we will also facilitate early scale-up process optimization, wherein our partnership with the local ecosystem of academics, the societal developments, as well as industry, will actually facilitate such a development and engage with processes developed aside those only in NCCs. Now, achieving this, we believe, will create novel products and processes which will be essential for supporting societal requirements towards safer, cleaner, and efficient working ecosystems. Now, apart from enhancing the ecological footprint, what we believe is that these type of endeavors will create new industries, jobs, and markets for bio-based products and several types of economic opportunities. These could help in achieving India's net zero goals by promoting regenerative biomanufacturing and a circular bioeconomy. All this will be made possible through developing dialogues, approaches, and implementation across society, academia, and the industry. So with this aim in mind, actually we have the next feature that we would like to showcase is a panel discussion in which we will actually try to initiate some of these communications and conversations with the different stakeholders that I've been talking about. And I'll hand this over to Dr. Dheeraj Dhotre of NCCS, a senior scientist at NCCS, to take the panel discussion ahead. Thank you.
Yes, thank you, Dr. Bapat. Thank you, Dr. Bapat. So good afternoon, everyone. I'm Dr. Dheeraj Dhotre from NCCS. And on behalf of NCCS and DBT, I warmly welcome you all to this panel discussion on World Bioproduct Day 2025, featuring voices across the cities, one nation, one day, 1 hour per city. Since it is the event for a city, we took a privilege to call experts across the city. So we have 2 experts from the neighboring institutes, 2 of our internal experts, and 1 representing the Pune-based company. So over the next 30 minutes, we will explore how India's Bio-E3 policy, shaped by DBT's visionary leadership, is enabling a vibrant biomanufacturing ecosystem across the country. So it is my privilege, before we start the discussion, it is my privilege to introduce 5 of our distinguished experts who have made significant contributions to microbial biotechnology and industrial applications. So I'll start with Dr. Syed Dastagir. So he's a senior principal scientist at CSR NCL Pune. So Dr. Dastagir has over 16 years of research leadership in microbial systematics and biotechnology. His discoveries of novel microbial species and innovations in biopolymers, such as bacterial nanocellulose, has found industrial applications. And he has several patents on his name related to the bioproducts which he has developed. Then we have Dr. Tushar Lodha. He's a scientist in the bioenergy group at Agarkar Research Institute, Pune, where he leads research on microbial bioenergy processes, including biohydrogen, bio-CNG, and microbial electrosynthesis. His work focuses mainly on translating microbial diversity into scalable, low-carbon bioprocesses for urban biomanufacturing. Then we have Mr. Jagannath Sonawne. He is a chairman and director of AB Source Biologics Private Limited, It is a pioneering company who is engaged in development and commercialization of bacterial cultures used in dairies, probiotic formulation, cosmetics, and even in feed industry. He has over 2 decades of entrepreneurial leadership, and he has founded and led multiple ventures. I will not name all of them, but he has at least 5 different ventures. Essentially, Mr. Sonawane has expertise and experience in biomanufacturing, business development, and creating global standard bio-based products for self-reliant India. Now, I would like to introduce our internal expert, Dr. Avinash Sharma. He is a senior scientist at NCCS, and he has a specialization in microbial ecology, metabolic engineering, and microbial bioproduct development. His research focuses on designing and engineering microbial communities for bioprocess application, with a particular emphasis on production of bio-based chemicals like 2PE and PHB. His work bridges environmental microbiology and industrial biotechnology to develop sustainable solutions for bioeconomy. Then we have our last, but not the least, of course, Dr. Amit Yadav as our internal expert. He's a senior scientist again in NCCS, and he has a specialization in microbial metabolism and plant microbe interaction. His group has made significant contributions to understanding phytoplasma. These are a group of plant pathogenic bacteria. Alongside, he also does a lot of work on understanding microbial metabolic engineering and synthetic biology for bioprocess development. Dr. Yadav's interdisciplinary work bridges fundamental microbiology with applied biomanufacturing. So with this background, I would like to start the discussion. We all unanimously agree that the BioE3 framework and DBT is enabling an ecosystem where biotechnology can thrive beyond laboratories, and we can take the research now to the biomanufacturing scale and for urban applications. So with this, I would like to start with my first question to Dr. Syed. So Dr. Syed, your group, you have published over 70 novel different species across 16-20 years now. So how do you foresee that India's microbial diversity, how it can contribute in developing next generation bioproducts? And how do you see the urban market for this?
Thank you, Dheeraj, for inviting. See, it's irony that in India we cannot patent the cultures, even though India is a big, what you call mega biodiversity hotspot, but we only need to develop a process. Because when you look at the golden era of antibiotic, majority people are very focused, narrow-minded screening the antibiotic. If you look at a classical example of remdesivir, which is not meant for the antiviral, especially on COVID cases, but it has repurposed. But nobody is thinking of repurposing the bugs. So what antibiotic produced in 70s, 60s, still people are looking for the same antibiotic. When you look at any microbe, it produces thousands of metabolites. You have to repurpose the bugs. I will give one of our, you talk about bacterial nanocellulose. Majority people talk about cellulose means it mainly come from plants. There are bacteria which produces 100% pure cellulose. When you talk about plant, you need to do the 40% of your cost extraction of cellulose in plant goes for the pre-treatment. Then the environmental hazard. So treatment with acid and all those. Here, simple process, bacteria produces the cellulose. Downstreaming is simple NaOH treatment to remove the bacteria. Then your material is ready. So we demonstrate, by doing this, single culture can demonstrate. At present, we are getting around 450 gram of hydrogel, which has a 98% water content, but it has lot of potential in medical application.
Right.
So what I was telling is repurposing is needed for the bugs rather than the drugs, what the people are thinking of it. So even we get a same organism in a same environment, but it may be adapted to different ecological niche. It may produce different what it has been reported.
Right. So I completely agree with you. But I mean, to find out, the organism which is, the production is scalable and which can be taken up to the market, probably you will need, lot of organisms to screen first. And for that, I mean, India provides the best platform because we have, such a vast diversity. So how do you, what is your approach usually when you want to find out any, particular product?
See, what we start, when you start isolation, we look at the very standard approach. I'm not looking for a very generic kind of, we'll put a certain substrate, like I'm looking for a cellulose producing, there are certain standard chemicals need to be incorporated in the media. The selective isolation should be there rather than a very routine kind of isolation. Then only one, and obviously students should have patience when the PhD students who works on these kind of projects, they need a patience to look at. The same on bacterial cellulose, from 500 isolate, we got one strain is producing a better cellulose.
Right.
But for 500 isolate, we have to understand all the process to see that which one is the best one. The ultimate goal comes from the student. India both has to have a patience to look into the process, how to scale up those things.
So I agree, and we have Dr. Avinash, Amit, and also Dr. Tushar. We have also worked on novel species, and we have published so many novel species. So what are, I mean, in short, what are your approaches, to take it to final health? How do you screen them, and what?
Yeah, I think like Dr. Nastri said that it's very important to be selective. So when you are selective, that means you are very focused on what you actually need. So that the selection of these particular strains are very, very important. There are millions of cells in the soil if you go like that. But what is the requirement of your project is important. So I think selection of a right strain is very important.
I completely agree with Dr. Dasmini sir that India has a huge biodiversity, and as a human being is a very selfish animal. We always go to nature and try to find the activity of our purpose. We get it into a lab and we try to simulate the same thing in a lab and we try to exploit that. And as the speaker sir rightly pointed out, that there is need of different purpose of the same strain, and selective screening will help for your purpose for what you are trying to isolate the culture. But for repurposing, you have to screen for the existing organism. So here the role of culture collections like NCMR, MCM or NCIM is very vital, because they harbor all the cultures that can be possible in the India. So the repurposing can be, we have to find out a high throughput method for screening this repurposing, because already we know something about those cultures and we want to find out something more about those cultures. So that is what I think we should do, and I think NCCS is already started doing some of such steps, and I think that will really help us to repurpose the same strain for some other applications.
I completely agree with you, Dr. Tushar, and we all, I mean, are quite an expert in identifying and selecting out organisms which has some biotechnological potential. But the biggest hurdle that we face, is to scale up. From the laboratory scale process development to scaling up and taking it to the finally into the market is the biggest gap which we see. So, Mr. Sonavane, from the entrepreneur's lens, how do you see what is the biggest barrier of scaling up urban biomanufacturing in India? Where do you find out the biggest problem?
First of all, thank you very much for this opportunity. This was a very informative statement, like screening the microorganisms for the particular application. After screening, identification, making the proof of concept. After that, the real story starts, the scaling up. As a commercial point of view, scaling up has a lot of hurdles, a lot of barriers. There are all scientific people sitting here. You all are agree that whatever works on the lab scale or shake flask scale cannot work at a 5-liter fermenter or a 10-liter fermenter. And that is what we have gone through from last 10-15 years. The major hurdle is, because if you see, there are 3 major hurdles. One is, of course, every entrepreneur face the same issue of excess of funds or availability of the funds. But before that, I would put that the identification of a right target. Because majority of the time we select the product because we like it, because we have worked on that. We may be emotional on that product. As a scientific perspective, we say, okay, this product works. But where is the demand? Whether really the market wants that particular product. So the process starts from there. So identification of a right choice, right product or right technology, which we are going to take it to the scale up. Because ultimately, if you are not selecting the right product, there is no market, so there is no question of scaling up. So the first thing is identification of a right candidate, whether it is a product, service, or technology. Then the main challenge comes in the scaling up. So scaling up is not only a land, it is not only a building with 4 columns and beams. If you see, the biomanufacturing mainly revolves around the fermentation and related technologies, which has to be in a aseptic clean room environment. The capex is very high. Sometimes people have money, they have land, they create an infrastructure, they put up a 1,000-liter fermenter. Where is the skilled manpower? So first thing is the infrastructure, the capex. Second is the skilled manpower. In spite of having these two, the third major challenge is the consistency. Many of the times we fail in process optimization. We try it out, we get some product, we don't get quality. Sometimes we get quality, we don't get quantity. So it is all related to the commercial viability of the project. After scaling up, we take a first batch, third batch, 10th batch, 100th batch. It goes to the customer. Customer says, "Oh, I'm sorry, it is not like my expectations." We again have to go back and do the reverse engineering. So it's basically the first thing is selection of the candidate product, then infrastructural cost. Second is the scale up. Third is the appropriate manpower. Because many of the times in last almost 14, 15 years of practical experience, many of the times after 2-3 years, people give up. They say, it won't work. Then the project starts. And after that, the last point, which is probably you will say it is not related to scale up, but it is directly, indirectly related to the scale up, is the marketing and the product acceptance in the market. If customer doesn't accept the product, so probably the scale up doesn't make sense. So the major hurdles, access to the funds, then availability of the appropriate skilled manpower. Because superficially, Dr. Saab will agree, everybody will agree, fermentation looks very easy, but it is not like that. So all these points put together, there are hurdles, there are barriers, but there are solutions also. Right. So if you allow me, I can talk about the solutions, or we can go to the next question.
So I think even the time scale is a big factor for, a person who is, starting up in the industry and when they are investing into, scaling up process. So how do you see, you all have, we have attended, several meetings in NCCS, and NCCS is coming up with the bioengineering research center. So how do you see, how you envision BRC, how it can help, in the scaling up process? So probably we can start with you, and we also have, researchers, so they can also.
I think partial discussion we already had in the last meeting during that CPI discussion. So this center probably help us to optimize the processes at a lab scale, or maybe a little pilot scale. But commercial, it's altogether a different ballgame. So probably NCCS or any BRC-like centers may not help startups or entrepreneurs at the commercials. But that collaboration, whether you call it as a PPP model, public-private partnership, or whatever the model, collaboration model you talk about. But under Bio E3 policy, that is going to help the startups and entrepreneurs. See, practically, as an entrepreneur, we do not want to invest on R&D, honestly, even though we like to invest because of two things, the cost and the manpower and the time. So if the technology is readily available with NCCS or XYZ Institute, we can really take up to the scale up immediately and go to the market. Our expertise is with the market. We have the market availability. We know how to get into the market. So we need the support from these kind of institutes like BRC centers. You develop the technologies at a scale up, the pilot scale or a lab scale, give us for the commercialization. So whatever terms and conditions. So there should be a distinct division of work. Right. The laboratory scale technology should be developed by the institutes, and it should go to the industries for commercialization. I think.
So, Dr. Syed, Dr. Tushar, would you like to?
I would like to add. So I, as an academician, I always talk about TRL, technology readiness level, and industry always talk about CRL, commercial readiness level. Right. And I always think of third term, that is MRL, that is market readiness level, because these three things are very important. if you want to go to market and sell a product, each step has equal value and importance. So when we are starting any research in a lab, we should always be associated with a team of industry who are giving input about their commercial value of that product, so that whatever research we are doing in developing a technology, it will not go in vain, or it will be more refined process so that it can be commercialized very easily.
And do you see, I mean, with the Bio-E3 policy, do you see the scenario is changing? You know, the researchers are attaching more with the industry, you know, to see the end target and then started.
Yes, that is happening, because many meetings which are happening for Bio-E3, most of the time academician and industry peoples are sitting together, and there is a lot of brainstorming which is going on, and which is very positive sign, because it was not happening few years back, and that is what I think we are going towards a good way where we can reach to a market and where we can actually deliver a product which can be a societal impact.
Thank you.
See, first thing is lot of challenges comes when you talk to market, means people will thought of comparing with already existing products. Can you compete with the chemical product? Which is highly impossible with the biological product. But if you look at into the sustainability, this Bio-E3 gives the good sustainability. When you talk about the carbon reduction and all those, these are the only product which can reduce the carbon content. But coming to the BRC, sustainability is very much important. One-time investment, infrastructure build-up, how to take up for a longer goal is very much. Funding should be in a sustainable way. Then only we can see the succeed in the BRC. Another interesting aspect, regulatory reforms are needed for the Bio-E3 to succeed. Because regulatory, whatever we have is on drugs and vaccines are very well established. When you talk about microbial products, there are not complete information available. Only probiotic have been well designed. But if you talk about probiotic, nobody nowadays they are coming to next generation probiotic. India is very far from thinking of next generation, because the majorly gram-negative bacteria they are looking for the next generation probiotic. That kind of you have to think a little bit far than the Western people. Now they have already started clinical trials on the gram-negative bacteria.
Yes, completely agree. I want to come back to this point later, but I would like to know, Dr. Bapa's vision. I mean, how you foresee BRC, and what is the role you see that BRC is going to play? I mean, they have commented about how BRC is going to be.
I think every time I'm always enthused by these conversations that come up when we meet across these different stakeholders. I think the most important thing for BRC is to actually, what was said earlier, bridge over identifying a right organism with the right product which will be market available. Over this, we will have to overcome all these hurdles of identifying or scaling up over the different TRLs, the CRLs and the MRLs. And I think in the crux, I think that is the ecosystem that we wish to develop at BRC, wherein through our engagements with the industry, with the academia, who have, say, for example, some lab process that really has potential, but a researcher may not be able to really evaluate its market readiness. So I think on a single platform, if we can provide all these type of things and probably address some of the regulatory issues as well, I think that would be a parameter that would define the success of BRC. And I hope with continuing conversations like these, we would be able to succeed.
Yes, thank you, ma'am. So, Dr. Syed, you said, about the regulatory thing. So, I would like you to share your experience, on technology transfer. So, because you have developed multiple technologies and you are also in discussion with industry. So, what makes microbial innovation ready for industrial adoption, and what are the challenges you face in technology transfer?
When you talk about this regulatory kind of thing, when you develop any product, they ask you at least minimum animal data. When you provide animal data, again, question comes whether those are GMP kind of thing, whether the data is a GMP lab produced. by lab like any academic lab, they cannot give that much of money to produce the GMP lab data to suffice the industry requirement. Certain stage, up to one stage, say 10-liter pilot scale is the capacity of any academic lab. We can demonstrate up to that. Then later, hand holding is very much important in the industry. So until unless they are come in that way, we cannot go beyond that scale. Hand holding from the initial stage is very much important rather than coming in the last stage for commercialization. Because if you tap the problem in the very initial stage, both will be in a win-win situation. That is the.
But overall, I mean, in NCL, you have developed numerous products, and so are there any situations where industry comes and asks you for all the regulatory approvals, everything, the final product ready, so that they can take it to the market? Does it happen anytime, or they handhold right from the start?
Some companies are needed the complete data. Again, they'll ask if I give some CRO generated data, they tell us that you should go with some of the government lab where we can take out some authentic data kind of thing. So right now, they need a complete solution. The next step, they want to start with the manufacturing itself. Until that data, we need to develop what BRC can give that kind of information to that. The next day, they can develop the product and commercialize it.
Right. So along with the role, of course, we know that in a country like India, we need multiple biomanufacturing hubs. But along with that, we also see that there is a growing importance of having microbial or cell repositories. NCL has one, ARI also has one, and NCCs also has one. So, Mr. Sonawde, what is your take on this? How these repositories are helpful for industries and how they can be utilized in more, in a commercial way, or.
So, Dr. Saeed rightly said, selection of microorganisms for the particular objective. So, way back in 2014, our journey started with a collaboration with an institute called India Raikana. They also have the repository for the dairy-related application. So, since one of my colleagues was postdoctorate from the same institute, so using those old connections, we started talking to them. This is a particular example how industry and academia can join hands together and develop the viable product in the market. So they said, this is what the products available, which can give you a code. It's just a simple code. So we took the strain and the basic media formulation to go. That's all the technology was transferred for a very minimal cost. After getting the technology, media, everything got changed 360 degrees. Nothing is remained as whatever the technology was transferred, nothing is there now. It's a total different technology. But the strain was important. They have given the strain and basic formulation of the media. Then after that, we started buying one after one after one. So we have a library of around 125 strains now, which are widely used in the dairy industry. Let it be a low-fat curd or mishti dahi or shrikhand or yogurt or laban, kefir or whatever. So it's a library of 125 strains. This is what we have grown in last 10 years with India Raikana. So the same thing like NCL, we are in touch with each other for different applications. So wherever you go, whether you go to the dairy or probiotic industry or feed formulation, the kettle probiotic, everywhere there is a microorganism. There is a microorganism. It's a basic component or raw material of any formulation.
And since you said, industries do not really want to start from step zero. Repositories like this probably are immensely useful for industries to start with.
And anyway, we cannot patent the microorganisms. So there is a question of inventing or finding out a new microorganisms. But the basic process, as Sir rightly said, at least 10 liter fermenter process, if it is available, it is easy for us to take it to the commercial.
Right. Thank you. So, Dr. Avinash, you have led the NCCS microbial repository for last 4 years, and you are also a curator of IDA. So, where do you see the repository's role in the biomanufacturing era or Bio-E3 policy? First, if you can explain what is IDA and then elaborate.
So IDA is basically it's an authority which give you a kind of privilege, you can say, where any culture which is deposited in this repository is actually recognized through the globe. So whatever ID repository we have, if we have your organism in one other repository, that means it is kind of accessible and you fulfill the norms of patenting any application you have. And coming to the repository, so over the last 4 years, or maybe more than 4 years, because I was working on the NCMR project also. So what I have observed is while talking to the stakeholders and giving services, depositing deposits, that microbial strains are not the scientific assets, to be very honest. They are like the very useful resources. Okay, and why they are important? Because if you look at since we cannot see them and we oversee them, but if you look at the upscale property of these organisms, it's very, very easy for us to upscale a microorganism compared to plant, or we have to upscale any of the animal tissue. So this is the beauty of microorganism, and why microbial resources are very, very important in this situation. Just imagine Taq polymerase, Thermus aquaticus. If the isolator would have missed this organism, where we would have stood actually, right? So that's the beauty. So with changing climate, everything, it's not just the extinction of plant and animal, but also the extinction of microorganisms. So the organism which you can find today may not be available in the ecosystem. Okay? So it's like once you lost it, it cannot be recovered. So that's how microbial resource centers are actually are very important, because they have all the researchers considering the repository of NCCS. Since India's huge ecosystem, I mean, I think we have covered almost every ecosystem, may it be wetland, may it be forest, may it be hot spring, may it be glaciers, may it be any kind of ecosystem. So like there was someone who was saying that each organism which is present in any ecosystem has a different role to play, right? So based on that ecosystem also, we can also strategically plan that what are the organisms, what is the ecosystem basically. I think we have already done that kind of analysis that each ecosystem is more relevant for which kind of enzymes based on our genomic data and all. So I think these are the important aspects of microbial repository, and coming to ID, it's very, very important to have ID facility. Because if you look at the recent advances in biotechnology and especially the IDA, so what is happening now is the patents which are over like 30 years. So now patent depositories are unable to take a decision on that, whether to discard them, whether to put them in the biodiversity, in the general deposit. But if an organism is coming from India or from Indonesia, which doesn't support general deposit without prior information, you cannot do that. So I think with our policies of NBA and IDA being here, it's very important for the Indian researchers who submit it here, so that after repurposing, right? After 30 years, once your patent is over, the strain is still useful. So we can put it in the open collection and still explore.
Yes, very well said. So basically, repositories can help industrial applications. Of course, people can exploit them for various industrial application. Microbial conservation, which you said, first, which again aligns very well with BioE3, sustainable environment, and of course the employment
and protection as well. I'm sorry, I forgot to add that point. So protection is also very, very important. The resources we have generated should not be misused. So all these legalities of being DNR, designated national repository, it's very important that what is going out of the country, so that we have the right on our.
Thank you. So Dr. Amit, I would like to ask you about the AMR repository and how it is helpful. We know that antimicrobial resistance is a global issue, and it is a very big issue. And another next question I'll ask you right away, because we are short of time. Second is we are also developing SRC. So if we can elaborate on SRC.
So to go with your first question on AMR repository, why you are having AMR repository to begin with, I need not to explain how important AMR issues these days at the global level. So there is a lot of research going on in India, across the world, but the repository, AMR repository, will majorly serve as a testbed for all the researchers, those who are working on AMR and they're looking for the organisms which they need. So if you are looking for an organism which is having a particular characteristic of resistance or susceptibility to any particular antibiotic, instead of searching into the wild or instead of searching into and actually going and collect it, you can actually search those organisms in the repository and can procure it from here and use. If you're working on a particular antimicrobial peptide, if you're working on any compound or any molecule which is supposed to be an antipathogenic, you can always use these organisms to test your compound. So this is very critical aspect. Secondly, this particular AMR repository is actually a collection not only from the clinical setup, but we also have the cultures coming from environmental setup. Like we have the actual environmentals from like the wild environment like river sediments or other things, but at the same time the human setups like fisheries or poultries or the veterinary setups. So we have a good collections which represents most of the hotspots of the AMR in India. I hope I have answered your question here. Coming to the second question on Protein repository, there's a lot of discussion which we have done on how urban bionaturing is important. So one of the critical aspects of any bionaturing is to have a strain which is capable of producing your product, right? So, and as everybody knows that the strain should have some certain capacities of having particular characteristic and particularly the secretory nature of the enzyme if you are working on that or something like that, and should sustain all the fermentation growth parameters. So those are called as production strains. So one has to really develop, spend a lot of time invest a lot in actually generating the strain which is capable of sustaining to the fermentation growth parameters. So under the Bio3 policy and with the recent ongoing DBT call, this is already there. So we have a section in the repository called as SRC, Strain Resource Center for Fostering High Performance Biomanufacturing. Now, here in this particular section, we have strains, though we have started recently, we have strains which are capable of having production capacity. So these are the different strains, like for example, there are a couple of bacteria, there is one alga, there is unicellular alga, there is a fungi, and there is a yeast also. So one can choose one of them based on whatever you are working on and use these strains under standard licensing agreement, and they can use for their R&D or directly for the commercial purpose, which is already rightly available on the NCS website.
Yes, thank you, Amit. So to conclude the entire session, what I see, the repository part, which all three institutes have, the actual POC, which all the scientists across the country are developing, and the manufacturing and marketing, all three are are interconnected with each other, and they should work synergistically the way they are working right now. So I think having all these three under the same roof and then developing new processes probably is the future. And on behalf of all of us, I would like to thank DBT and Bio3 policy, how they are fostering the biomanufacturing in India. So Dr. Bapa, you would like to conclude or say something?
No, I think we should hand it over to our next entrepreneur. So thank you all for being here and for these valuable conversations.
Thank you.
I think Dr. Jyoti will introduce today's.
So next we present a local success story. In this section, we are pleased to feature Dr. Ashish Polkade, who is Director of Best Eco Solutions and Technologies Private Limited, a company that has been successful at developing innovative biology-driven solutions and bioproducts in the waste-to-energy and waste-to-value landscape. A quick introduction to Dr. Polkade. Dr. Ashish Polkade has a PhD in microbiology and over 22 years of diverse experience spanning academia, industry, and environmental innovation in institutions like Agarkar Research Institute, National Center for Cell Science, Raj Industries, KF Bioplants, and Rise and Shine Biotech. Dr. Polkade is the founder of Best Eco Solutions and Technologies Private Limited, a company dedicated to sustainable waste management and bio-based energy solutions. He has delivered 9 industry-ready technologies, has filed 3 Indian patents, and has authored 29 research publications and a book chapter. His innovative work in microbial formulations, anaerobic digestion, and waste valorization has earned the National Biotech Award 2023, awarded by the Association of Microbiologists of India. A true champion of sustainable innovation, he has also established and leads other training and outreach activities aimed at fostering a mindset that favors sustainability. He regularly conducts biogas mastery workshops and field expeditions towards promoting circular economy practices. He founded the Environmental Leaders Club, an initiative that has empowered more than 450 professionals across 6 countries through sustainability-focused programs. I invite Dr. Polkare to share his bio-entrepreneurship success stories that lie at the intersection of science, society, and the environment.
Thank you, Dr. Jyoti, for this introduction. On the onset of this program, I would like to thank. Everyone can hear my sound?
Yes, you are audible.
And that's someone's question or something.
Yeah, this is one check. There's some message.
Supply shares and that. Can you answer for the bunny?
You can simply say yes.
So thank you so much for the meeting and National Center for Self Science, Dr. Bapat ma'am and everyone, to allow me to speak on this platform about this World Bioproduct Day. So the topic is microbial solutions for urban and industrial waste management. So before, since this is my current institute, I'm glad to be here again on this platform to talk about these sustainable products and those things. World Bioproduct Day, when I come to know about this, because this program has been not circulated to the industrial scale. So 2 days back, I Googled it for those things and what are the policies and those things. So I found it very interesting and very useful for us to be a part of this World Bioproduct Day. So I wish all of you happy World Bioproduct Day. So byproducts are reasonably, there are 3 factors, which is renewable, biodegradable, and environmental friendly. So these 3 factors will be there when we say about the bioproducts. It's not only from microwave; it can be from a plant also, microorganisms, organic waste, any kind of thing which has been originated from the renewable biological resource. So that's the main thing. So I'm on this platform because we believe that waste is not a waste and it's a resource. And about some sustainable products when we do for. So I think it's a base platform to present on this thing. It's not a very, I have only 15 minutes to present. So what I will do, I will have some story for you all, because you all been hearing from the morning some different sessions. So it's just like a story. I will go along that what I had done and how the process has been, this program has been transformed to now the base technical solutions in technology. So it's whenever we say a biologist and the waste management, if we think about that, there are three things only: biogas, composting, and industrial waste management. So these are the 3 concerns when we start. When I started my career in this sector, from NCCS, I started serving to some societies for the municipal solid waste. Then I slowly realized within a 1 year time only that this is not the right way to go, because it's the financial sustenance was not there. The stakeholders were many and the decision makers were less. So I shifted my focus towards the industrial waste and biogas. So these were the things. So I will go by story. When the major story is the agar waste management unit, so which we had developed. This is whenever the problems are coming to me, I tried to resolve it with the sort of multidisciplinary knowledge, not only biological mode, but yes, as we all know that there is a when the nature exists in a consortium. So whatever things are there, there are multiple roles from the each field. So that's why everything whatever I develop is with the multidisciplinary approach. So it's a cave bio plant. When they come to us with the problem that they are being the largest Asia's largest floriculture industry. It is based in Pune, and they have a problem that the agar agar which is generated in the lab was not degradable, and they used to dump into the ground. And after 5 years also, it is not getting degraded. So for that purpose, we started working on it, and we work on a very small scale, and slowly we move on to the higher scale. And today we are processing this agar waste at a scale of 5 tons per day, means around 18,000 tons per year. So that's the way wherein we convert this agar waste into a liquid, and which liquid can fit into the MPCB norms. So that's the major part which we had developed. So initially we installed 1 ton per day capacity reactor, and now we are installing 2 tons per day capacity reactor for this. And it's wonderfully operated. The water which is generated from this, they are using it for the agricultural purpose. So this is a current protocol. It was slow degraders and those things. These are the things. Herein, as I told you, it's a consortium, and there are multiple processes involved. It's not only a microbiological process. It has to be incubated with the microbes for a certain amount of time, and then it has to be processed with the different kind of methods. So this we have installed in Pune, in a Rise and Shine and Care Bio plant. So both the things. So yes, the second technology is about the food liquefaction technology. So this we are working on this from last 3 years, wherein we are trying to liquefy the hotel waste. The small hotel holders, hotel owners who wish to give up their waste, but they have a norms that they could not do so if they are producing more than 100 kg waste. So they have to process at their own. So for them, we had developed some technology wherein the microbial resource has been used, and the food is converted into a slurry-based model, and that slurry can be utilized for the higher biogas potential is there for that. This is under patent. It has been submitted. Whenever we think about the bioproducts, everything like it's a very wonderful story which is very near to my heart, because whenever we resolve some issue, it gives a pleasure to us that we are serving in some way to the Mother Earth what we could do. So it's like a few years back when we found that this is a Patanjali Ayurved. In Patanjali Ayurved, there was a reactor which was installed from the Pune-based company only, but it was not running from 3 years. Last it was debugged, and in the debug reason was that even if we are thinking now that there are multiple units which are running for the waste management, but the technical know-how is not there. So they have a total 12 organizations, 12 food. This is a food plant. So total 12 companies involved, wherein apple juice, aloe vera juice, or jadi booty, and some Chyawanprash, and those all industries, food waste industries. So whatever waste comes from it, we used to treat it into this digester. But it was not a treatment, it was a dumping, because there was no technical scientific evaluation of the product, that what is going in. So what happened after 2 years, this complete unit, this is a 90 ton per day unit, it is got debugged. And after that, they could not process it. So they asked me to have the different plant, which is a composting plant, and they wish to treat all those waste into composting plant. But when I went there, they showed us this model, and we restarted with the proper technical processes, and standard operating protocols has been standardized, and we revamped this unit, and it was really a good experience, and very nice thing. Now at the present day, they are utilizing complete energy, whatever generated from the biogas. They are utilizing it for their 12 units to run their boilers. So yes, these are some consultancy based products. I would like to go through the products, but it's from my since my company, I will skip some of the slide because of the time. This is vision of my company. There are some core values: innovation, impact, sustainability, clarity, contribution, and collaboration. So these are our clients, which are with whom we are working as present. Our main domain at present is the biogas industry, wherein this product is also wonderful product which we developed from a waste actually. So if you find out, there are multiple kind of tea waste which is generated. So from tea waste we had generated some product. It has been tested and it is already been in a market with a it's just like a booster product, and which can enhance the biogas yield by 25 to 45%. Biogas yields always depend on the TS and VS basis, calculated on the TS and VS basis. So the total, whatever the total solids are there, so on the basis of that total solids, we can enhance the biogas with the 25 to 45%. So it was wonderful. There are two, three things which I would like to mention here, because it's a sustainable product. When we say it should, whatever waste is generated throughout India, so it can be collected and processed in the form of this biogas. So second, a few products are microgain, which are microbial culture for composting. These are a few products. Odor expert for odor removal. This is Odo expert, and scum expert. This is also one of the very genuine problem of biogas industry, wherein the scum get formed after installation of a new plant. After 1 or 2 years later, some solids get entangled, and because of that, scum is formed, and that scum is so hard that you can literally literally stand on those issues. So the main thing which I could found in all these products, whenever these products are formed, actually these are not being designed by me for some like immediate thoughts. But whenever the problems are there, we started thinking on it, and we started to working on it to resolve those issues. So how we could resolve those issues, and from those thought process only we could form these products, and that's how this is a very good product, running product from the industries which are taking it for the scum removal. So and this is one of the things which we could say like in Bharat Swachhata Abhiyan. This would be a very good small product for every individual. We should get it. Is only available on an online platform. So these are the things. Potted food liquefaction system. Some of the trainings programs which we conduct. We have a few projects from government of Maharashtra, with whom we trained 40,000 students. Consultancy, I will skip this thing, time is over, I think. These are a few of the services which we do. Basically for the services are for the biogas industry only, wherein we do a biogas potential analysis and those things. So these are the things. And I would like to say that eliminating waste before it eliminates us, and this is the actual process, because you all know what the condition of waste is. So for that purpose, the scientists and all the stakeholders from this ecosystem need to work on this, and it's a very beautiful platform of bioproduct day from where we could initiate this process to eliminate the waste. Thank you so much. Thank you so much.
Thank you, Dr. Polkare. Next, we will move to the students' pitch section. We have with us Sneha Verma, our PhD student, who will present a pitch on green buildings.
So to share, please, to share.
Is it visible?
Exit sharing.
We need to have we can have the entire did you share?
Can you see it?
Yes, yes. Then it will take 2 seconds.
Shall I start? Good afternoon, everybody. This is Neha. I'm a PhD scholar here. So I will be giving a pitch on bioproduct use, which will be used for addressing urban fire management. Now imagine if the buildings in our cities could breathe, not just stand as concrete blocks, but actually clean the air, capture carbon, and even produce valuable crops. Now that's the power of biointegrated algae buildings. Cities are rapidly.
Excuse me, in the display settings, please go to the duplicate. First click on the display settings.
One sec, please.
And then duplicate slideshow. Yeah. And then hide, which is appearing below. Yes. Now please go ahead.
It hides everything. Okay. Yeah.
Cities are rapidly expanding. Over 50% of the world's population now live in urban areas. And with that comes enormous pressure on air quality, energy consumption, and carbon emissions. Buildings alone are responsible for over 30% of global energy-related carbon dioxide emissions. In countries like India, cities like Delhi, Mumbai, and Kolkata are constantly battling air pollution and heat islands. So how do we respond to this? Now the answer might be simpler than we think and surprisingly green: microalgae. These are microscopic photosynthetic organisms which have the unique ability to capture carbon dioxide, produce oxygen, and grow rapidly using just sunlight, water, and CO2. Now, these are not just green dots under a microscope. They are often considered as biological powerhouses. Unlike larger plants, they have faster growth rates, with some species capable of doubling their biomass within hours. This makes them highly efficient at carbon fixation. In fact, on a per area basis, microalgae can absorb 10 to 50 times more carbon dioxide than terrestrial plants. What's even more impressive is the versatility. Microalgae can be cultivated in compact bioreactors and can be literally installed anywhere, on building surfaces, rooftops, or even vertical walls, making them ideal for dense urban settings where land is scarce. Microalgae also support sustainable solutions across multiple industries through the production of diverse, high-value bioproducts. So what if we just integrate microalgae into our building design? We are not just adding green leaf, we are embedding living bioreactors that actively contribute to urban sustainability. It's biology meeting architecture in the smartest, greenest way possible. Is there any proof of concept? As a matter of fact, yes. There is a fully functional building, the VIQ building in Hamburg, Germany, which was built in 2013 as a part of the International Building Exhibition. This innovative residential building features a facade made up of glass panels filled with microalgae cultures. Now, how does this work? The sun here acts as a primary energy source, powering the algae growing inside flat photobioreactors. These algae use sunlight to photosynthesize and grow, producing biomass. This biomass is then sent to a reactor where it is converted into electrical energy, helping power the algae integrated building. The heat generated during this conversion is redirected to the building's power station, where it is used to warm water for both the building and the swimming pool. Meanwhile, the carbon dioxide released during the energy production is fed back to the algae, creating a sustainable and a self-sustained cycle. There are multiple challenges as to make this plan in India. High initial cost, extreme climate conditions, lack of awareness and technical expertise, space constraints, and low public-private investment are few of them which delay the acceptance of algae integrated research. We need to take few steps in order to tackle this. First, the government can offer incentives and clear policies to encourage adoption. Second, we need pilot projects, real buildings with algae facades to show that this idea actually works. Third, research institutes and startups can work together to create a low-cost, climate-friendly system suited for Indian cities. Finally, we need to spread awareness as well as train architects and builders that will help make the green innovation part of the mainstream urban design. With the right push, our buildings could soon clean the air while looking cool doing it. So in a world where cities are at the heart of climate crisis, algae integrated buildings offer a powerful reminder. The path to sustainability can begin right at our homes. Thank you.
Thank you, Sneha. Now I request Dr. Raman Murthy to please administer the pledge. I request all the NCCS members who have joined in the live feed in the auditorium to please also join in. Thank you.
Not except immediate. Not sharing.
We, the people of Pune, in the state of Maharashtra, wholeheartedly affirm our commitment to the vision of the Bio-E3 policy of the government. A strategic framework to build a sustainable, inclusive, and innovation-driven bioeconomy grounded in environmental conservation, economic opportunity, and employment generation. Recognizing our state's unique scientific, ecological and cultural context, and immense potential of our bioresources, we pledge to implement the Bio-E3 policy with dedication and leadership, guided by the following principles and priorities. Promote and actively collaborate on bioproduct innovations to unlock local and national potential. Establish and promote biotech innovation hubs that drive a regenerative circular economy. Enable biomanufacturing hubs and industrial scale hubs for clean and sustainable production. Generate employment and build green skills, especially to reduce, recycle, and repurpose waste. Ensure bioethics and equity across all aspects of bioeconomy, development, respecting community rights, responsible science and just transitions. We recognize that the future lies in an economy that regenerates and an economy that regenerates rather than depletes, empowers rather than excludes, and embraces future technologies, to co-create nature. We pledge to lead our state and our nation towards a bioeconomy that is inclusive, climate resilient, ethically grounded, and globally competitive. Thank you.
So thank you very much NCCS for bringing in the biotechnologies, how it is important for urban biomanufacturing and industrial waste utilization, and showcasing the fantastic technological value chain in realizing this fact to take forward the biomanufacturing initiative of DBT further. Thank you so much. Now it's over to IBST Impal, and request Dr. Sharma to take over for next 1 hour. So it's over to you, sir. IBST.
Yeah, I'm here. Can you hear us?
Yeah, it's over to you, sir.
Yeah, thank you very much. So on the onset, I would like to wish each and everyone for the World Bioproduct Day with the Bio E3 way. So on behalf of IBSD, I would like to welcome each and everyone present online and also the present from all the centers of IBSD. So as we all know that, can you bring up my slide, please? Entire slide. Aduna team. Yeah. No, second. Make it full screen.
Screen first.
Yeah. Okay, Amit, can you see the full screen?
No.
Doctor, the screen is not visible.
Screen is not visible. Yeah, you can share the screen first. Yeah, share screen. Correct. Yes.
Shall we share it from here?
Yeah, you can share it.
Yeah, we'll share it from here.
Okay. They will share from Info.
Minimize this.
Minimize this.
Minimize.
No, you just go to share screen.
Yeah, we'll do that. Cancel कर दो लालू cancel कर दो. Yeah. Dr. Indira, can you share the slide?
Yeah, we are sharing it from here. Start sharing.
Make it full screen, please.
Okay. Oh, yeah.
Yeah.
Please go ahead.
Okay. So with this, I will just want to brief that what our institute is doing. Our institute is Institute of Bioresource and Sustainable Development, which is one and only DBT institute in the whole Northeast. So we have, apart from the headquarters, we have at Imphal, we have one center at Shillong, one center at Sikkim, and one center at Mizoram. So with all this defined mandate, we have set up all these centers as well as the headquarters. And then the main mission of this our institute is that we want to use the bioresources available in the whole Northeast for the socio-economic development of this region. Because as we all know that we have different bioresources available here in these 8 states of Northeast India. And then it is also spotted as one of the biodiversity hotspots. So next slide, please. So these are the 5 verticals which we are working on. The first is plant resources. As we know that we have different plant resources, starting from medicinal plant and other different endemic plant species. We have a vertical, one vertical of that. And also other one we have a phytopharmaceutical, ethnobotany, and drug development, where we have a lot of different traditional healers which has been practicing for quite a long time, and then for that we do have a vertical to look after that and use them in a scientific way. And the third one is microbial resources and fermented food, which I think NCCS has already told about the microbial repository and other thing. I will have another one slide afterwards for the microbial resources. And also we have animal resources, and also we have eco-restoration, water management, and surveillance. Next slide, please. And so apart from this, apart from the research, we also do a lot of other bio-E3 related programs, like say bio-entrepreneurship, and then women entrepreneurship, and also we do the industry connect. So what we do is that we give the connection of all those startups and other bio-entrepreneur, then we give the link with the industry so that they can directly sell their products to the industry, and also they can make a sale directly without us also. But only thing what we did is that we just made a connection between the entrepreneurship, farmers, and the industry. And also apart from this, we also do a lot of other programs like lavender plantation here in Northeast. We have already tested, and we have already signed MOU with IIIM Jammu, where Honorable Minister Dr. Jitendraji was also there. And also we have started, apart from lavender, we have also started, let's say, low chilling varieties of apple, which we have successfully planted in many parts of the Northeast. Next slide, please. And also, as I said, that we have another center also at ICGEB. So these are well defined that in different centers, say like ICGEB, we are concentrating on evaluation and validation of medicinal plants, and as well as aromatic plants of high altitude, because ICGEB comes under the high altitude. So, and also we do the evaluation and value addition of all those traditional foods which are widely available in ICGEB. Next slide, please. And also in Meghalaya, where I am right now, we are also doing the evaluation and validation of medicinal plants of high altitude, as well as other low-lying altitude also. And also we do the value addition of the traditional food which are endemic to this Meghalaya. Next slide, please. And then we have Mizoram Center, where we do the documentation, because Mizoram comes a little bit farther from other connectivity wise. So we do the documentation and validation of all those traditional medicine, as well as we also do the validation of all those value addition of the fermented food of Mizoram. Next slide, please. And also, this is one of the programs which we have initiated, phytopharmaceutical mission, where we explore the traditional healthcare practices and the bioresources used in this practice and their scientific validation and translational component. So what we actually do here is that, as I mentioned, that we have a lot of traditional healers across the Northeast. So we do the documentation as well as survey documentation and validation. What we do is that we go to them and then convince them to document their knowledges, because the problem is that if we don't do the documentation right now, I think it is almost late, but if we don't do in 10 years, all their practices will go off. There will be no record, there will be nothing, because these are not handwritten, it's not written document. So we go to them, convince them, because it's very difficult to convince them. So what we do is that we make a connection, we call them for the conference and other meeting in our office also, and then we record their with their permission, we record them and do the documentation. And also, being a scientific research institute, we do the validation of all those of their knowledge. So, and also we have already published a lot of paper in this regard. And the good thing is that we have put their name in the paper also, and as well as when we file any patent out of their knowledge, we give their name also, so that they will be happy and they will be more confident to connect with us and then share their knowledge. Next slide, please. Next slide. Okay. And also we have a microbial repository collection center, where we have collected more than 70,000 samples we have, we have in this culture, and this we have collected from different ecological nature, like hot spring, cold spring, and many other, because as I've already mentioned that this Northeast belongs to the one of the hot biodiversity hotspot. So we collected from different niches, and then also we have already started screening, and also we are planning to use for the bioethics manufacturing manufacturing work. Next slide, please. And also we have different collection, different varieties of mushroom which are well eaten here across the northeast. And also we have different wild as well as edible. And also apart from this mushroom as a food, we also extract a lot of nutraceuticals from them, which can be used as a nutraceutical, or as well as we also extract a lot of phytochemicals which can be used as a drug. And also we have filed around 3 patents out of this mushroom, and also we are in the process of developing some product out of this, which can be which we will be connecting with some industry and try to develop as a product. Please, next slide, please. And also, as I have mentioned, that Northeast is very fond of fermented food. Each and every region of Northeast India has different kind of fermented food. So like in Manipur, we have hawaja, which is a soybean, and also we have a bamboo shoot fermented, which is totally different. One you get in Manipur will be different from one you get in Nagaland. One you get in Meghalaya, it will be different. So, and when you go to Sikkim, they use different fermented food also. And also, say like Turpi is a well-known fermented food for Sikkim, which we are working on to develop some starters. And also we have, our scientists has already started producing some starter for the soybean, that hawaja fermented food. Where, because the problem with this fermented food soybean is that many of the people get food poisoning, and they sometimes get hospitalized, and sometimes they get they die. So what we are planning is that we are trying to do in a scientific way to have a starter, so that it can be fermented very fast, number one, and number two, it can be more in a hygienic way. And also this goes for the same with the mushroom. Also we have a different mushroom, as I have mentioned, and also we are trying to have some sensors so that we can test that whether the mushroom is wild or whether the mushroom is edible. So next slide, please. Okay, this is one of the area where I think many people don't know, and many people doesn't work also. We are also working on the edible insect of NER, this Northeast India. So what we do here is that we the Northeast people consume a lot of insects. So we have tested all those nutraceuticals things from the different insects, which are edible insects, which are commonly found here in the Northeast. And also we are trying to develop a form of like a product which can be used, because nowadays all the muscle bodybuilders and all the players use a lot of steroids. So we want to replace them, because insect is very, very much rich in fiber and then protein. So we want to use them instead of all those synthetic drugs and then steroid. So for this we are in the process to set up a center at Kohima in Nagaland, where we will be concentrating only on this edible insect for that center. Thank you. Next. Okay. And also this is one of the slides which my colleague Dr. Pradeep will be explaining in details. So this is where we have a biomass incubator here in Meghalaya, in Riboi district. This is aspirational district of Meghalaya, where we give the employment to all those women entrepreneurship. We encourage them through plantation of the orchid, because here in this area, Riboi is a little bit warmer than other part of Meghalaya, and orchid grows very, very, very well. And then Meghalaya has a very good potential of floriculture industry. So we are trying to take up, we have already taken up this in the very big scale. There are a lot of beneficiaries, which my colleague will explain in details. So next slide, please. Okay, this is one of the programs which we have started recently under the BioE3 policy. What we do here is that we give the training, because we have a very huge 8,000 square feet tissue culture facility, which I'm showing on the right side. This is our campus. Another campus in Imphal, which is 40 acres just next to the hill loft. It's very nice. And then we have a very huge tissue culture facility as well as mushroom cultivation facility. So what we do is that we give the training to all the students and all the bio entrepreneurs we give the training for a month. We have already done the 2 training of mushroom, and then we have already done 2 training of plant tissue culture. So what we do is that we give them training for a month, and then we give them the space for the incubation also. What we do is that we give our facility to them so that they can develop their product starting from the starting to the end, so that they can sell their product to the market also. And also we sometimes we do the market linking also, as I have mentioned, that we have some industry link meeting also, where we call all the industries from across the India, and then especially we concentrate on the Northeast, entrepreneur as well as industrialists, and then we try to connect them with all those industry people so that they can sell their product. So this is one of the initiative recently we have started under the Bio E3 policy. Next. With this, I would like to thank each and everyone, all my staff of IBSD from different center, and also especially the DBT for funding us. So with this, I will hand over the presentation to Dr. Pradeep.
So, thank you. Can you share my slides?
Gosam?
Yes, sir.
So anyway, good afternoon to all of you. Myself is Dr. Pradeep from Institute of Bioresource and Sustainable Development. As mentioned by our director, that IBSD, the main theme for IBSD is ethnobotany and forest-based bioproduct. So as mentioned earlier also, that Institute of Bioresource and Sustainable Development is only the institute under Biotechnology Research and Innovation Council and the Department of Biotechnology, which is established in the northeastern region of India, and we have presence in 4 states of northeastern region. Next, please. As mentioned by our director, that different research vertical on which IBSD is working. So, but the main focus of IBSD is bioeconomy from bioresources. So how best we can utilize all these bioresources, and what is the path for the development of bioeconomy. So if you see here, whether it's documentation or any other verticals, and then we go for mass multiplication of any of the bioresources for its quality evaluation, and then biodiversity conservation. After that, we have this value addition, whether food or any other component. Another one is the capacity building, training, and outreach activity. Then a very important aspect is the industry connect, where we focus on connecting all our entrepreneurs to the industries. And last one is the startups, and we have incubators, clusters, traditional healer farmers group, which can be connected for the in this path of generating bioeconomy from bioresources. And ultimate goal of IBSD is the societal upliftment and livelihood generation. Next, please. So in this perspective, since for this World Bioproduct Day, the bioeconomy, Bio E3 ways, our main theme is ethnobotany and forest-based bioproduct. As all of you know, that northeastern region is known for orchids, and especially Meghalaya is main hub of orchids, with so many species of orchids grown in this particular. And this particular Himalaya is have the moisture in its environment, and that is why huge speciation in the species also. So taking that advantage, IBSD has established a bionest incubator, which is mainly funded by DBT BioRack and in collaboration with the BRDC Meghalaya. So our this main focus is on promoting women bioentrepreneurship through orchid floriculture, especially in Meghalaya. So here we have a hub and spoke model. So we have one hub, and at one village, and 10 spokes are there. So 10 villages, and in each spoke we have 10 women. So altogether we have 100 women involved in this particular incubator. So they are our beneficiaries also. And if I will explain in next slide that how those are startups in their own, and their, I know that this is not a big startup, but if you consider the situation of Northeastern region, these all startups have their own importance. So in this particular this Bionest incubator, our main focus is production of quality planting material, mass multiplication, storage facility, market linkage, incubation, and then finally development of bio entrepreneurship. So this particular, next please. This bioincubator is established particularly in Ribhoi district, which is the aspirational district of Meghalaya, and we have 11 villages altogether from Umsning, that block of that region. And we have provided them the infrastructure in the form of polyhouses and other equipment for irrigation and all. So, and include beside this, we have also provided them the quality planting material. So central hub is 100,000 square meter, and each spoke is 300 square meter, and total together is 4,000 square meter, which we have targeted in this particular Bionest incubator. Next, please. So we have provided them the quality planting material, and then giving them training for how best we can go for mass multiplication and cultivation of this dendrobium species, which is particularly can grow at high temperature also. So we have all together 100 beneficiary with us, and one of our most successful beneficiary sister is here, which she will explain her success story in the next next to me. So next, please. So this is the photographs which I am showing you, that now each of the spoke and even central hub is producing spike of this dendrobium species, and they are selling these spikes in the market, and earning a good amount of this money out of that, and they are moving towards the sustainability out of this particular business. So this is some of the photographs I'm sharing. Next, please. And these are the some of the pictures from our hub, where all these dendrobium plants are in flowering stage, and they are cutting those spikes and then selling into the market. Next. So this is the photograph from each hub and spokes. So where all the beneficiaries are there, and they are getting trained out of us. And now what we are seeing, that they are very innovative among themselves. They are giving so many of the ideas how to grow them, how to get more spikes, what is the season, how to hold that flowering stage, and then selling those in the peak season of the when these flowers are required. Next, please. So these are the some of the photographs I'm sharing, that how best our scientists who are involved in this particular incubator, and also people from DRDC Meghalaya, who are giving training time to time them, and providing the necessary facility to all of them. But you see that some of the those beneficiaries, they are putting their innovation and making these product for the market, so that every tourist can get attracted to most of them. Next, please. And sometime if they are not able to sell their products, so they are not wasting any of the produce from there. So they are collecting those flowers and then drying them and then doing the resin encapsulation for value addition and the utilization of unsold flowers. So these are the all innovators which are coming through our these beneficiaries, and how best they can make a good product out of those things. Next, please. Now question comes that where is the market and how best we can sell those products. So IBSD has established a state-of-the-art orchidarium at IBSD Upper Shillong, which is on the way to this your Cherrapunji. So many of the tourists, they visit our, and this orchidarium is open for tourists also. So many of them, they are visiting this orchidarium. And beside this, we are providing training to our beneficiaries, and then outreach activities. We are showing to the students also that how best you can do the bioeconomy from bioresources, how best you can utilize local bioresources for the development of bioeconomy. And then we display all our produce from our beneficiaries if they are not able to sell from their respective places. So they are sending those flowers here, we display here, and tourists are coming and they are purchasing from those beneficiaries. Next, please. So this is not only we are just focused on this training our beneficiary, but we are doing so many of outreach activities, and we are highlighting the activities of our Bionest incubator to different platform, including your Global Bio India, then Startup Expos, which is conducted by BIRAC, and then India International Science Festival, where it has been proven as a successful model for women entrepreneurship through floriculture. Next. So beside this, now we are developing some women entrepreneurship programs, and then connecting to this Industry Connect program to all those women, so that they can have that vision about how best they can be involved for the development of bioeconomy from bioresources, and how best they can contribute this Bio E3 policy of DBT. Next, please. These are the some skill development program which we conducted both at Imphal and Shillong, so and other parts of northeastern region. Next, please. Now this is the program which we conducted. As all of you know, that India International Science Festival was conducted at Guwahati, and we got that opportunity to participate here, and our beneficiaries got that opportunity, that all the women who were there in our spokes and hubs, so they joined that program and interacted with many of the people, and they got the opportunity that how best and what are the opportunities over there to scale up this particular startups and the incubation they have processed through. And during this particular program, Honorable Minister was there, and he also interacted with our beneficiaries. So everybody appreciated this particular model for the bioeconomy from bioresources. Next, please. Now, if it comes as mentioned by Director Sir also, that what are the initiative of big IBSD towards this Bio-E3 policy of Government of India. So as mentioned by other institutes also, that how best they can contribute towards this Bio-E3 policy. But being a bioresource institute and being in Northeastern region, what are the other initiative which IBSD has taken? So we are involved in this establishment of Bio-E3 centers, biomanufacturing hubs and startups in Northeastern region. then scientific outreach and entrepreneurship development in this particular region, and development of innovative technologies for bio-based product for food and health benefits. And finally, now we are focused on having one national program on bioeconomy from bioresources. So that's all how best IBSD can contribute besides our this bionest incubator, which I have highlighted for the orchid floriculture. So there are many opportunities which can be how best we can link this bioethics policy with the bioresources of Northeastern region. Next, please. So with this, I will stop here. I would like to thank all of you. Thank you very much. Now I will hand over this to Dr. Indra to please proceed with the program.
Thank you so much, Dr. Pradeep. And first of all, I'd like to thank to our director, Dr. Nanauka Sarma, for highlighting the different activities taken up by IBSD, which links to the utilization of bioresources for the development of bioeconomy. So, and I would like to thank Dr. Pradeep Bharadwaj also for presenting the initiative taken up by IBSD on the Bioness Incubator of IBSD promoting the women entrepreneurship in the Northeast region. So with this, we have a very successful entrepreneur who is none other than Sister Marley, who has been benefited from this Bioness Incubator, and she's from the aspirational district, from Rigboy district of Meghalaya. So I would like to request Sister Mary to elaborate about the success that he has developed from this Bioness Incubator. Over to you, Sister Mary.
Everybody, I am Sister Marley Tom, Director for Ando Campus for Inclusive Education. I am basically a special educator for the hearing impaired, working with the children in an inclusive school there. And we have also an integrated farming in our campus. So the setup there is providing opportunities for the young children to learn various things. Even if they cannot continue with their education later on, they can start something. So with that background, when we were looking for things to introduce into our place, IBSD stepped in and suggested about this orchid project. Initially, I was very skeptical about it. I said, how would it work here? But later on, we said, let's try. And we conducted our self-help groups around 10 self-help groups. They came forward. We said, let's all work together and see what we can do. With the hand-holding from IBSD and with the RDC's help, we have been able to make it a successful project. I'm here as a representative of all the beneficiaries of Boy district who is planting orchids, to thank everyone who has contributed for the growth of our project today. So it was a trial and error in the beginning. We tried many ways because in winter we had problems with water. The beneficiaries had to make a lot of sacrifices to carrying water and for watering the plant, because many times we did not have electricity because we are in a very interior places. And so every unit worked very hard to keep their orchids alive, and now they are all benefiting from it. Last year from our hub, we had sold almost 1 lakh rupees orchids, flowers. And we have a lot of people, the tourists and people coming for orchid plants, but we haven't started selling the orchid plants. We start selling only the flowers. Along with, we also started, actually most of the self-help groups started planting other flowers on the side of the poly houses. And so they are also getting additional income from other plants. So they have even the king chili, some of them are planting even king chili. So they are adding more value to their orchid products. Along with the orchid products, they're also getting other things to be sold and increase their income. But now we can confidently say that the orchid plantation, especially the anthurium plants, can be taken up by as a real entrepreneurship program in the district. Many young people can be employed, and it will surely will support the economic improvement. For us, it was not only the income that we get from there. The school, the students in the school had been involved in planting. They had been getting in training, and they have also said, "Oh, now we can get money from the flowers." So they have broadened their mind so that they can also plant flowers and get money. So and people of Meghalaya are fond of flowers, and most of the flowers are coming from outside. So there is a lot of scope for within the state and outside the state for this orchid flowers. I also wanted to take this opportunity to thank everyone who was part of our journey in this orchid project, the officers who introduced us to this project, the women who were willing to take a leap into this new venture, IBSD and Bioproduct for the hand-holding given to each one of us. I would also thank Faranda family who allowed us to implement this project in our campus. And above all, I thank God who brought us together to work for the benefit of our women flock. I hope this project can take us forward and can be very beneficial to many of the women flock there. We are also looking forward, being this orchid project is successful, we are looking for another project if possible. IBSD could help us, or VIDA could help us, is a banana plantation and banana products so that we can move into the today's World Bioproduct Day. As we are celebrating, we can also get into the bioproducts for income generation of the people there. Thank you so much.
Yeah, thank you so much, Sister Madly, for being with us today, for sharing your views and success stories that you have and your team has been benefited through the IBSD incubation. And we are looking forward to see more and more successful entrepreneurs, not only in Meghalaya, but in the whole Northeast states of India. So next we have, as a part of the Youth Innovation Program, there's a presentation from Dr. Konjemgam Sada Devi, the DBT Biocare women scientist. She'll be speaking on the potentials of wild mushroom as source of livelihood, the entrepreneurial ventures and future urban food. So over to you, Dr. Sada.
A very good afternoon to everyone present here today. Myself, Dr. Konjungbam Sarda Devi, I would like to talk on potentials of wild mushroom, a source of livelihood, an entrepreneurial venture, and future urban food on this auspicious occasion of World Bioproduct Day, the BioE3 way. So I would like to start the talk with a description about the mushroom. Mushroom are macrofungi with visible and large fruiting body that normally grow in their natural habitats like forests and grassland, rather than being cultivated on farms. Mushrooms are found abundantly in Northeast India, and Manipur being a treasure trove of biodiversity, various wild mushrooms has been collected. A pictorial representation of a variety of wild mushrooms is given herewith. Coming to the prospects of wild mushroom, I would like to talk about how mushrooms are highly nutritious. Mushrooms are highly nutritious because of its high quality protein, high fiber content, and being a very good source of vitamins and minerals, and having low fat. So it serves as a good functional food as it has various bioactive metabolites, and also it has, because of the bioactive metabolites, it has led to therapeutic properties like immunomodulatory, anti-inflammatory, anti-aging, antioxidant, hepatoprotective, antimicrobial, hypotensive, anti-diabetic, antiviral, anti-cancer, etc. It has gained wide acceptance and emerged as a functional food to complement and supplement a healthy diet. So what is the potentials of wild mushroom? Why wild mushroom as a source of livelihood, entrepreneurial venture, and future urban food? The potential of wild mushroom stems from its ability to meet the nutritional security. In rural tribes, it is an important source of food, so of the food security it provides, and also it is an important source of income for income generation of rural tribes. When the season of the mushroom comes, the localites, the rural tribes, they collect and they bring it to the market and make it accessible for people, thus giving it a very good source of income. It has possible biomanufacturing ability, and it is a potential and it has a potential entrepreneurial venture. So why we will go for production technology? Because this wild mushroom, they have very huge demand, not only in the local market, but also in the national and international market. But the production technology of such valuable wild edible mushroom is lacking, though few initiatives has been started, even in IBST. The picture represents spawn production technology. Spawn is basically the seed of mushroom from which we can grow the mushroom at our level. And in this production technology, it starts from pure culture of mushroom, and from that mother spawn will be prepared. From the mother spawn, the commercial spawn will be formed. The commercial spawn is the spawn that is distributed among the mushroom growers, mushroom farmers. And for this mushroom spawn production, we basically require cereals that are locally available at the region of the growers. Here in Imphal, we usually grow on paddy grains and also wheat grains. And we have successfully made spawn technology of 3 wild edible medicinal mushroom that includes split gill, Schizophyllum commune, wood air mushroom, Auricularia species, and Shiitake, Lentinula edodes. Once the spawn is successfully produced, we have gone for cultivation, and from successful cultivation, mass cultivation technique, and its dissemination to the growers, mushroom enthusiasts. This is a pictorial representation of cultivation technique of a particular wild edible mushroom, split gill mushroom. The cultivation technique of split gill mushroom done using substrate used by mixing sawdust of Magnolia champaca with rice bran and calcium carbonate in the ratio of 80:19:1 on dry weight basis. Usually for this wild mushroom, it has been observed that broadleaf woods are very successful for use as a substrate. So, and one more very interesting thing from this cultivation is that the substrate after growing the mushroom, it is normally known as spent substrate, and spent substrate is an important source of, it can be used as a good source of organic manure or compost, thus making every component of mushroom cultivation an important resource. So now, once the cultivation is done, once we get the fruit, next comes the value addition. Post-harvest value addition or value-added products such as cookies, nutri-chunks, noodles, pickles, papas, chips, etc. are developed from these potential wild mushrooms. Most interestingly, nutraceutical food supplements such as protein powders, capsules, food supplements can be developed from this wild edible mushroom through biotechnological interventions. Thus, this can promote entrepreneurial development. This product can help in improving the health of the people in particular and economy of the region in general. It can be a source of livelihood, entrepreneurial venture, and future urban food. Thank you.
Yeah. Yeah, thank you so much, Dr. Sada, for highlighting the potential use of the wild mushroom, which is readily available in the Northeast region, and how the wild mushroom can be converted, in different value-added products for as a livelihood, as a functional food, and where we can develop many entrepreneurs in the region, especially women and non-unemployed youth, as a source of income also in the Northeast. Thank you so much, Dr. Sada. So now I request everyone to please ready for taking the place of the World Byproduct Day. So I request our director, Dr.
We the people of Imphal, Shillong, Gangtok, and Aizawl.
We the people of Imphal,
In the state of Manipur, Meghalaya, Sikkim, and Mizoram.
in the state of Manipur, Meghalaya, Sikkim, and Mizoram,
Wholeheartedly affirm our commitment to the vision of the Bio-E3 policy of the government, a strategic framework to build a sustainable, inclusive, and innovation-driven bioeconomy, grounded in the environmental conservation, economic opportunity, and employment generation. Recognizing our state's unique scientific, ecological and cultural context, and the immense potential of our bioresources, we pledge to implement the Bio-E3 policy, dedication and leadership, guided by the following principles and priorities. Promote and actively collaborate on bioproduct innovation to unlock local and national potential, establish and promote biotech innovation hubs that drive a regenerative circular economy, enable biomanufacturing hubs and industrial scale up, for clean and sustainable production, generate employment and build green skills, especially to reduce, recycle and repurpose waste, ensure bioethics and equity across all aspects of bioeconomy, development, respecting community rights, responsible science, and just transition. We recognize that the future lies in the economy, rather than depletes, empowers rather than excludes, and embraces future technologies to co-create with nature. We pledge to lead our state and our nation towards a bioeconomy that is inclusive, climate resilient, ethically grounded, and globally competitive. Thank you.
Please be seated. Thank you so much, the director and all the IBSD staff representing all the different 4 states of India. So thank you so much once again. So now we end with the IBSD program. So I would like to hand over to Dr. Amit, DBT.
Thank you. Thank you, IBSD, for highlighting the theme ethnobotany and forest-based bioproduct, showing its alignment with the Bio3 policy on this World's Bioproduct Day. Now, I invite CDFD and ICGEB Hyderabad, who are jointly presenting the theme Biopharma Side Streams as New Inputs. Over to Dr. Sharma.
Good afternoon. Can you hear us?
Yes, audible.
Yes, audible.
Okay. First of all, thank you for handing over the baton to us. I know we are the last, and hopefully we'll win the race. Our theme that we are talking about today is, of course, at the end of the biopharma industry, which is the waste that is generated. So the theme that is given to us to coordinate together is biopharma side streams as new inputs, opportunities in waste valorization. So we have an exciting program that includes a panel discussion as well as presentation by a young scientist as well as students. And to begin with, I hand over the mic to Dr. Taru Sharma, our director at NIIP.
Thank you very much, Dr. Hegde. Good evening, everybody. And I think the stage was set for this important word bioproduct today, the Bio3 way. And perhaps DBT decided we be the showstopper. So I start with it. Can we have it in slideshow mode? Can we have it in slideshow mode? So, well, it is all we from Telangana, both the institution, National Institute of Animal Biotechnology, as well as CDFD, our colleague institute. I shall really present in next 5 to 5.5 minutes biopharma side streams new input. Can we have it in a slideshow mode? It's yet to be shared. And I want the slide changed. He's keeping it with him. Are my slides visible? Are my slides visible?
It was visible for some time, but now it's not.
No, okay.
Now
Is it okay?
Now
Okay.
it's
Yes, now it's okay.
No notes. I don't want notes. Remove
It is
Now
notes.
you can go ahead. We can see your slides.
Give me that slide. We go and we talk about how do we unlock the value of these side streams or the byproducts which is emerging out from the biopharma industry. It's a beautiful recycling life. The cartoon in itself is self-explanatory. And this is what exactly we are focusing. How do we really think about the generating bioenergy, biofuels, as well as other bio-based products? Let's just have a look at it, the important part of biotechnology, and particularly when we think about a circular economy, all the 1 to 5, I shall rather focus on 1 to 4, the ones which are either getting lost or the ones which are biodegradable waste. If one can really think of, taking them away and design some valorization meaning. This slide, when actually, thanks to my team, actually it's a teamwork, when we were all sitting together, it was amazingly, we were surprised. Can you just see that where are we going to reach this global biopharmaceutical market by 2030? And I would like to draw an attention, it's 8.2% of growth. And we need to really be thinking and focusing on ways to valorize it. And these are the just current scenario, what we are really looking at it. Well, this is India's biopharma landscape. This is the output, and this is the side stream. So I like to draw an attention to the side stream. That is, from 24 we are here, and exactly what is the output. So the last potential to be tapped, and this is really increasing. We know we are largest producer. We are number one in bulk drugs, and we from Telangana, Hyderabad sitting, so we understand that we have this side stream wealth which is generated in the town. This is kind of uh, really mind-boggling. So just see the E factor, 1,000 or more than 10,000 of the kilogram of waste generated per kg of final product. And I think I could make my point with that. So what are the factors contributing? I'll just keep it very short. They're all very much self-explanatory. And with an example which has been put over here. So let me just move forward. What exactly is an impact? Since it's a bio E3 way, and we are concerned with, other than employment, we are concerned with the environment as well as economy. So it directly impacts the two arms of our E out of three. And then we got to go to the regulatory stream. And if we just see the economic opportunities, so some of us were really thinking that if this valorization can really be streamlined, put it up in a way, the way DBT has already put it up at ICT Mumbai and so on, a couple of our laboratories already have utilized the hidden power of this byproducts, and then the potential bioproducts we already have in institutions amongst IBRIC Plus. It's a case study of a biocon country, and what is the approach, what is the impact. And there are some other examples also which are very much vocal, and one can understand that why are we with it. And it was very thoughtful of DBT uh, to really think about it. So what all one can think of doing to mitigate, or to optimize the existing processes, or to do the technological interventions. As well as we feel that there's suggestions and the policy suggestions. So this is the way one can think of valorizing it, when it is the waste is full with proteins, amino acids, can be taken out directly from the liquid or from the filters. Depends what exactly we are going to use it. Of course, it goes without saying, the data is loud enough to say it's a bioeconomy powerhouse. When it goes to $300 billion by within next less than 5 years. So rising startup ecosystem, surely country's ecosystem for the startup is the direct mode, and the opportunities unlimited. But nothing comes free. There are linked up flanking challenges with that. Not much of awareness, not only in the general public, I believe as scientists also. And this is the side stream recycling and contributing to all the SDGs, which is put up over here. In last slide, I would like to just focus how thoughtfully, carefully, and in a focused way, DBT has been really playing a role in a Bio-E3 mode. Of course, BioRec stands unquestionable, as I said. But as I was telling, that this is center of excellence has already been put. There's a mission. It's happening in a mission mode, and there's a way forward. We can think of having a national biopharma waste valorization roadmap, and in a mission mode, or else one can think of incentivizing those projects, especially from those biopharma clusters, particularly when we sit in Hyderabad, which is a vaccine and pharma hub. This will be a very lucrative way of doing science and moving ahead, and still sinking in our mandated Bio-E3 way. Thank you very much from Hyderabad. Over to my colleague, Dr. Hegde.
Thank you, madam. Now we move on to the next topic on the agenda, which is a panel discussion. And I welcome our friends from CDFD, and I invite Dr. Kavita Rao to take over, please.
We cannot hear her. We cannot hear her. Kavita, we cannot hear you. Kavita, you're not audible, please.
Okay, this is Abhijit speaking from CDFD. Am I audible?
Yeah. Please go ahead, Abhijit. Please
Okay,
go ahead.
so I think I'm just sort of moderating the panel discussion and just put on the camera so that you can see me. And so in this panel discussion, sort of we are shifting our gaze from the final product to what is left behind, right? And today's panel discussion will explore how these byproducts can be transformed into high-value resources. So sort of we are very thankful to our panels of experts for their participation in this session, and we are very happy to have with us Dr. Ramesh Mathur, Senior VP R&D Biological E, Dr. D.K. Day, Executive Director Immunoreca, and Professor N. Raghuram, Head Center for Sustainable Nitrogen and Nutrient Management in the Indraprastha University. So I hope all of them are logged in. We have time for a 20-minute panel discussion. And I sort of, a starting point could be the sort of experiences of the panelists and the challenges they envisage in this area. And perhaps we can start with Dr. Ramesh Mathur on this, followed by Dr. Day and Professor Raghuram. So over to you, Dr. Mathur.
Thank you. Looks like my camera is not working. However, my mic is working. Yeah. So thanks for keeping me on this panel. But I would quickly share our industry experience regarding this would broadly fall under sustainable and side stream category. We are in a vaccines industry, and all our products manufacturing is highly regulated. So having said this, a lot of waste stream, a lot of wastewater so-called would be there that we reuse, recover a lot of water, and then it is used for, if not for production, but all other requirements, including the gardening. But at the same time, the waste we generate are two or three different kinds. So one is a heavy amount of plastic. After the manufacturing single-use systems, the plastic is generated. The second category is a lot of our wastewater post-fermentation batches. It goes into waste stream, but it is very rich in nutrients. There is a lot of opportunity to convert that into value-added products, but there are certain regulations. Industry regulations or guidelines are very much required for an industry like ours, biopharma as well as vaccines, because vaccines use to some extent microorganisms. They're ensuring none of the organisms are released. Anything has a potential hazard. But after we do follow all those regulations and then release any of the material into the environment under the Pollution Control Board guidelines. So there is a lot of opportunity. It all depends on what kind of a product we would use. For example, food industry, fermentation, and also growing certain plants, value-added plants. And then, like the previous session, they were talking about growing mushrooms, for example, or any hydroponics based. So these are all the side streams that come to my mind at this point.
Perhaps we can hear from Dr. Day on this, please. Has Dr. Day joined us? Uh, uh, is Dr. Day, has he joined us? If not, I probably ask Professor Raghuram, because I seen him logged in, on his views on this.
No, no, my mic is
Thank you very much for having
Just
me on this panel. Okay.
Sorry, maybe Dr. Day, we can have you after Dr. Professor
Yeah.
Raghuram finishes. Okay.
Yeah, kindly unmute me. Okay.
Yeah.
Can you let me share the screen for a minute?
Yes, yes.
You have to give me the permission for it. Any case, thank you. For those of you waiting the whole day for this event, thank you very much for your time and patience. I'm very glad to be on this panel on the World Bioproduct Day, the Bio E3 way. We had some very exciting presentations in the morning from ICGEB and NCCS and a range of other institutions. So the most important issue is the sustainability of biomanufacturing, because we have to deal with the other two sides of E3, which is environment and employment. Now, this is just to give you a snapshot of the triple planetary crisis about which Dr. Sonti mentioned in the morning. The globe is, the green part of it is the safe operating zone, and as each of those abuses to the planet Earth, anthropogenic abuses to the planet Earth, keep growing, radiating towards the outside, it becomes less and less recoverable, repairable, and irreparable planetary damage happens. So as you can see, CO2 concentration is on the top right, which is the climate change discussion. But even more than that, damage has already happened to biosphere integrity. Some species disappearing, some species becoming invasive or changing. And land use change, agriculture and non-agriculture, freshwater change, and more importantly, nutrient change, biogeochemical cycles of nitrogen, phosphorus. Soon we expect sulfur and others to join. These are the various abuses happening to planet Earth. On the right side, I've used as an illustration the leaky pipeline model we show for the sustainable nutrient management, but you can replace the two main barrels in it from primary production and secondary production. I'm showing it as crop production and livestock production because crop output is used as animal feed. Both of them have leakages to the water shown in the bottom arrows or to the air shown in the top arrows. Of course, these are shown as leakages of nutrients, mainly nitrogenous nutrients. But in the case of biopharma or any biomanufacturing, you have a lot of rich compounds, essentially biological components, carbohydrates, lipids, proteins. Proteins tend to be usually predominant in the biopharma or even biomanufacturing effluents. For that matter, even non-biomanufacturing entities also produce a lot of effluents which have a high biological oxygen demand, which means they have a lot of biological components in their effluents. So treating these effluents is possible and desirable. If not, it leads to eutrophication of surface waters and coastal regions, soil pollution. You can see the green tides, brown tides happening in different parts of the world. This is from a UNEP Global Partnership on Nutrient Management, with which we have served. And you can also see the dark red dots in many parts of the world, including in many parts of India, where soil degradation has happened due to nutrient imbalances. Because many of the biological components of the biomanufacturing waste streams or even other manufacturing waste streams, which increase BOD, they contain useful nutrients for microbial bioremediation or for biogeochemical cycles. And it is these nutrients which are otherwise required in the food production system, but elsewhere they are pollutants. So some pollutants are nutrients in the wrong place. and biological industries and biomanufacturing can actually recover them substantially, not only to neutralize the environment footprint, but also to possibly make value-added products, about which some of our industry panelists will tell you. If not, this creates all these different problems. This is a particular illustration for nitrogenous pollution, which comes from the proteinaceous content of the bio manufacturing effluent, vaccines, biopharmaceuticals, proteins, antibodies, enzymes. All of them produce effluents which are usually protein rich, and having them in the environment contributes to all these air and water. The right side panel shows three major air pollutants coming from nitrogenous pollution, including protein, and the left side panel shows air pollution. The right side panel shows water pollution due to dissolved and undissolved organic and inorganic pollutants. Recovering some of these things is possible, at least in the case of nitrogen. It's also possible now in phosphorus. There are technologies available. Pilot plants have been established in Sweden for making industry-grade fertilizer from wastewater. This is, of course, sewage water, but you can also do it from industrial nitrogen-rich or phosphorus-rich, bio-effluent-rich effluents. It is just that I want to come out of this to just highlight the point that the issue is not the lack of technology or lack of manpower or lack of interest in DBT in promoting sustainable biotechnology. Bio3 is a very good example of bringing environment at the same level as biomanufacturing for employment or economy. What we really lack is the proper harmonization of the environmental norms, whether the effluent norms, the emission norms, which are aligned with the sustainability goals of the DMs and of the Ministry of Environment. Unless we have very stringent norms for effluents and emissions, not only for biomanufacturing, but for all manufacturing, there will not be enough incentive for the industries to introduce all these sustainable technologies, either to neutralize the environment impact or to produce value-added products. The worst example is now bioethanol. We are producing grain ethanol. I don't know why we are producing, but it is generating a lot of effluent and lot of emission. There are right now cases in the National Green Tribunal and in the Supreme Court, and industry is continuing with business as usual, largely because the norms have not been very stringently enforced, or sometimes have even been diluted to an extent. So I'm sure the intent exists in the policymakers to ensure that we move towards our sustainability goals and net zero goals. What we need is the alignment of the policies between environmental enforcement and the biotechnology and other related agencies. These are the point I wanted to highlight, especially on the policy aspect. Thank you.
Thank you very much, Dr. Day. I hope you can hear me, and would like to hear your opinion on this, please.
Yes, yes. Am I audible to all of you?
Yeah, I can hear you.
Yeah. Good evening, and thank you the panelists for involving me in the discussion. And I represent Indian animal health industry and my company. I'd like to be very specific on the topic about biopharma side streams. During the upstream and downstream process, we do have products, byproduct like enzymes, amino acids, and it's a huge potential because, of course, we are directly in vaccine business, but then we are also in nutraceutical. And believe me, it is the 70% of the input cost in dairy and poultry is feed, and feed is certainly supported by good enzymes to improve the nutrient absorption. And 70 to 75% of the amino acid and enzymes are imported to India. Now, what I'm trying to say, if you cultivate research, I'm talking about process research and the scaling up, I would say it is the technologies within the reach. We can not only scale up the business, generate employee, and it is going to lead to a huge import substitution. So I would say, let us invest on enzymes, let us invest on amino acids, and we are definitely going to fulfill the dream of improving the farmer's income, if not doubling within a short span of time. And we are well within the reach, only intent is required. And policy enablement takes place. We have NIB to support us, but it's a very specific need to the industry where we can cater to. Thank you so much.
Yeah, thank you so much. I sort of like the panelists to dwell on this question is that do we envisage a potential for industry academia collaboration for development of novel processes for side stream validation? Do we envisage this in the future?
We should, we can.
I believe there is a lot of potential with the mutual discussions and how you would utilize the value of it. How do you convert the waste into what sort of a value added product?
Yes.
And sort
Absolutely,
of
I think.
Yeah, please go ahead.
Yeah, we have to create a strong incentive as well as the necessity for industry to seek deployment of the latest available technologies, or even seek academia partnerships for meeting their sustainability goals. Right now, the emission norms and the effluent norms are either weak or on paper, and even weaker when it comes to enforcement. So the industry does not see a strong incentive in either deploying the latest technologies or seeking academia collaboration. But once that is there, that's why I'm repeatedly stressing the policy environment. Once that strong policy environment is there, we have the capacity, we have the expertise. If necessary, we can acquire it.
Yeah, thank you all. Another point we can sort of talk about is we did hear Director NIAB talk about a success story, but what are the success stories that come to mind in this area? Any that come to mind? Or still a testing bed?
Let me respond from my side.
Yeah. It's
So from the vaccine side, sorry,
right.
It's difficult to find a success story, and I cannot think of any, mainly because the regulatory aspect with which the vaccines industry operates. But there is a lot of potential. That's the point I want.
Okay. Another point I was thinking about was how do we see the market for valorized biopharma bioproducts evolving over the next maybe 5-10 years?
Yeah.
What is your view on that?
Sir, can I respond here? Now,
yes, please.
Since my domain is animal health, currently it is 27,000 crore, and it's one of the fastest growing animal health market is India, 8 to 10% CAGR. Now, as I said, let us make a clear case of business objective. What is our target? And if you see all these products, these amino acids and enzymes were either produced in Western world, now shifted to China. Now what happened? I would still say there is an environmental norms, but I think if we make a business case, we can also talk to the Ministry of Environment and Forest to have a this thing proper environmental norms, and we can attract investment. I'm repeatedly telling that India has the technology. It's a question of it's intent. So there has to be objective where there's industry academia collaboration, and then we make a business case to the ministry, which involves incentive, production link incentive, process development, as well as policy enablement. I can tell you, we can be there as a big field on these enzymes and amino acids are sold all across the animal species across the globe. Why should China have a monopoly? We do have the strength, we have the skill, but I think with the collective effort, we can achieve it.
Any other comments from other panelists, please?
I have one comment to make.
Yes. Please go ahead.
We are discussing about the waste stream, side streams. The one thing to convert into a value-added product is the volumes and need to be transported. Meaning, wherever the conversion of this so-called waste for the biopharma or vaccines industry is there, it needs to be converted into a value-added product within the same site, not too far away from, because it will add a tremendous amount of cost to the product.
Professor Raghuram?
Yeah, the market is huge, but it's really the incentives that are lacking. For example, I mean, biopharma, of course, you have the other experts. I can tell you about an area which I am more familiar with. In the agriculture sector, which also generates a lot of side streams of biologically intensive byproducts, manure management is a very, very important area. Our current urea subsidy is 1.5 lakh crore per annum. And urea can replace, manure can replace urea, but manure utilization is only 25%. Urine is a rich source of urea, but urea recycling is close to zero. Because the livestock sector does not have strong enforcement of effluent norms. They directly release all the manure and urine into the groundwater or surface water. So if the producer sectors, I'm just giving the example, the same thing applies to pharma. The scale is there, the effluent is there, what we really need, and of course the technology is there, market is there. What we need is the policy connect that makes it necessary for both. And of course, in the case of any sustainability initiatives, you have to make it economically viable. So sustainability initiatives cost money, and industries, if required, have to be given a required support, maybe some tax elimination or maybe some other kind of incentive, in order to help them in meeting these norms. Enforcement of the existing norms have to be strict. We have to increase our norms in terms of effluents and emissions, not reduce. Right now we are seeing dilution, whereas we should see strictening of these norms, coupled by incentives and disincentives. It will automatically force the industry to look for available technologies, seek nearest available partnership from academia, and sky's the limit for the amount of value it can add to all of us.
Okay, thank you. We are coming to the end of the sort of time slot that is being allotted to us. However, very welcome to take any final thoughts from the panelists. If not, then thank all the panelists for their very kind participation in this event, and thank you very much.
Thank you.
Thank you.
We go on to the next, I think, item. I think this is local success stories. So we've got Mr. Abhinav Chauhan, founder and CEO of Promisence Ento Systems. It's a startup in the CDFD Technology Incubator, and they're going to make a presentation for about 10 minutes. So can I just request Mr. Abhinav to start his presentation, please?
Sure.
Abhinav, you can hear me?
Yeah, I can hear you. Am I audible?
Yes.
Okay. Thanks for the opportunity to share the screen here. So today, my name is Abhinav Chauhan. I'm the founder and the CEO of Promisence. So today, I'm honored to present how Promisence is transforming biopharma waste into a driver of sustainable innovation and economic opportunity. Promisence is incubated at the CDFD Technology Incubator, which is a business incubator of the DBT BRIC, Government of India. And since our incubation at CDFD from May 2024 onwards, we have received invaluable support that ranges from access to advanced facilities to scientific mentorship that has also accelerated our progress in this mission. So basically, what the waste in biopharma is, it's the it's the biopharmaceutical industry, which is central to the global health, but it also responsible for generating enormous volumes of waste. So to put this into perspective, each year biopharma operations generate about 94,000 to 200,000 metric tons of plastic per year. That is from a single-use systems alone. And across the pharma supply chains globally, the total waste footprint can exceed around 300 million tons annually. And with regard to that, the laboratories contribute an additional 5.5 million tons of plastic waste per year, which is mostly incinerated or landfilled, that drives the CO2 emissions and compounding environmental harm. So beyond this, the environmental toll that is taking place, that represents a significant economic cost in the form of disposal fees, regulatory compliances, and the lost material value. Let's consider the example of a single use bioprocessing, where increasingly common in the biologics production. That is from a single 2000 liter disposable bioreactor run that approximately utilizes 760 kgs of plastic, that ranges from bags to the tubings to the filters and to the connectors. So all of this material is destined for disposal after just one production cycle. That is a problem that is emblematic of the linear and the take, make, discard approach that has long dominated the biopharma manufacturing. When I some the science element to it, there is a hidden value in terms of these side schemes. Uh, these so-called waste are anything but also they are valueless in terms of, take the spent the microbial biomass that is the common product of the fermentation. This material itself comprises around like a 40 to 60% of the protein, which is rich in amino acid, nucleic acid, lipids, and the biopolymers. And instead of the sludge, there we are looking at a nutrient and energy rich resource. So by valorizing these streams, we can recover a portion of the energy, nutrients, and materials invested in their production. That dramatically improves the economics of biopharma manufacturing. Then the various types of biopharma side streams. So the firstly is the microbial fermentation residues. These are the ones that are leftover biomass from the processes producing antibiotics, enzymes, or the vitamins that are basically rich in proteins and structural polysaccharides. The other one is the cell culture bioproducts. That's the spent media and the debris from the vaccine and the monoclonal antibody manufacturing that uses the CHO cell lines or the similar cell lines. Then comes the plant biomass and the extraction waste. That is governs the residues from the plant-based systems or the herbal extraction processes that often contains bioactive compounds, fibers, and the structural carbohydrates. Then comes the insect and the other biological residues. There's the exoskeleton straws or the pupae from the insect cell cultures or the whole insect bioprocessing. So why these resources remain untapped is because of the regulatory and the safety barriers, because these side streams are typically classified as biohazardous or chemically contaminated, that mandates their disposal via incineration or autoclaving. The second one is the celluloid production processes. Those are the manufacturing process that focuses tightly on the primary product, and anything that is beyond that is remitted and treated as a waste rather than as an opportunity. Then comes the technical challenges or the complexities that I can talk about. That the composition of the side stream can be variable, and also it contains the solvents, antibiotics, or the inhibitors that pose challenges for reuse, and also the awareness that comes because until recently the value hidden within these streams were neither quantified nor prioritized. So what's possible is the radical new inputs. We can see circular bioeconomy, where biopharma waste becomes input for new high value processes. Secondly is the nature has shown us the way where the waste from one organism can be used as a resource for the another. Then with the biotech on the biotech recycling processes, the spent media that contains the sugar, amino acids, and the glycerols, they can be regenerated for the new fermentation processes. So, and finally, by unlocking these streams, we can move beyond the dependence on petroleum or other traditional agricultural feedstocks and instead creating novel biomaterials and inputs for the industries of the tomorrow. Then the global trends that favors the valorization is first of all the sustainability imperatives that the government worldwide are tightening the regulations on the industrial wastes. Then comes the investor ESG's pressures, where the major asset managers or the overseeing authorities that comprises of around like $10 trillion are demanding transparency and progress on the waste reduction. Then comes the technology proof points where the startups and the industrial players are successfully upcycling the food waste, agricultural residues, and more, proving that the waste valorization is both physical and profitable. Then comes the circular economy culture, where the consumers are increasingly demanding for sustainable products and companies are responding with upcycled ingredients and circular business models. So there comes the opportunity for Promisence. At Promisence, we are building the bridge between this challenge and its solution. We convert the biopharma side streams into high purity, high value biomaterials with the likes of melanin, antimicrobial peptides that creates the new revenue streams while reducing the disposal cost. Our outputs can serve multiple industries from pharmaceuticals and cosmetics to the semiconductors to textiles and the agriculture. So this approach basically unlocks the breakthrough production innovations that set Promisence apart. Also, there are different new product horizons that we are currently developing. Is the one is the self-tuning biothreads, living seal dust, and the biocamouflage skins. Then the technological advantage is because we use the nature-inspired biofactory platform that applies biological engineering to efficiently process complex waste inputs. Our proprietary IP and extraction technologies gives us a unique ability to convert challenging side streams into refined functional products. The platform delivers multiple product synergies. That's from a single input waste, we extract pigments, isolate polymers, and harvest antimicrobial peptides that maximizes the value extraction, and that we achieve the quality and consistency for demanding industries like pharmaceutical, cosmetics, and the electronics. The strategic path forward can be the securing the feedstock partnerships with the biopharma companies and research institutions to ensure reliable access to side streams and co-develop solutions that are tailored to their waste profiles. Advancing R&D on novel materials such as self-tuning biothreads, biocamouflage skins, living seal dust, and protecting these innovations with robust IT. So to realize this vision, we are seeking strategic investment and also policy support to accelerate implementation and scale. In conclusion, I can say that the biopharma side stream represent a tremendous, largely untapped resource, and at Promisence, we are proud to be at the forefront of this opportunity, and we invite you to join us, the investors and the champions of these important missions. Thank you.
Thank you very much, Abhinav. We now come to the youth voice segment of this session, and I invite Mr. Chayan Bhattacharjee, PhD student from BRIC CTFT, to make a short presentation. And after that, we'll hand it over to NIAB to continue forward. Thank you.
Hello. ठीक थी सुनी ठीक थी
I think there's a technical issue. Chayan, can you hear us?
Sir, am I audible?
Yes, audible. Yes.
Now we can hear you,
Okay.
but we can't see your presentation.
Oh,
Yeah, please speak so that we know that we can hear you. Slides are visible. The issue with the voice.
okay.
Yeah, now
So,
it's better.
I am Chavan Bhattacharjee, a PhD SRF working in BRIC CDFD. So, firstly, I thank for such a wonderful program. This is a learning experience for me. And as I am a microbiologist, so I feel for this pollution and waste management, microbiology has a great potential to solve those problems, whatever the panel specialists have thrown at us. So today's topic is biopharma side streams as new inputs.
Can you go to your next slide, please? I think.
Yes, sir. Just a minute, sir.
Yeah.
Okay. So biopharmaceuticals are any products that are derived from biological sources and that might mimic biological molecules and used for therapeutics and diagnostic purposes. So hence, it is different from the pharmaceuticals where the products are all chemically synthesized. Therefore, biopharmaceuticals provide us with the environmental sustainability and they are less harmful to the planet. And the biopharmaceuticals include plethora of different kinds of products that are starting from vaccines to recombinant hormones and etc. And during their production, we come up with the different kinds of side streams. Now, side streams include either byproducts or the waste streams. So the idea is if we can rechannelize these things and come up with a beneficial product, a high value product. So there will be one thing is this material can be recovered and utilized whatever have been used for the main product. And there will be some cost saving. We can optimize the resource and obviously the end product that will be beneficial for us. So here for biopharmaceuticals, one process that has been extensively used is the fermentation process. So here in fermentation, the main products antibiotics to so many things. So here we'll talk about the side streams which are important. So like the biomass residues after the fermentation process, whichever biomass is there, that can be either bacteria to fungi. So these biomasses we can utilize for biofertilizers, and these are rich in protein, therefore we can utilize it for a protein source also. The media that has been still there, the spent media, so there by fermentation there will be some from complex sugar, there will be some leftover simple sugar. So these sugars we can utilize for different types of cosmetic industries and this, and in for this algae cultivation. Then other than that, the metabolic byproducts that these organisms have left behind and other processed chemicals, organic acids, alcohols and detergents, those we can use for various sectors like agriculture, soil conditioning and pharmaceuticals. And other than that, this filter and chromatographic waste, those we can reuse for any other non-critical steps after some pre-treatment of those used resins and chromatographic wastes. So apart from that, there are other kinds of side streams from different sectors with different diverse kinds of chemical molecules. So here we can take the benefit of the biotechnology. There are already some bacterial strains present and now been discovered, and we can bioengineer some bacterial strains also. Those we can use against these biochemical streams and come up with some value-added products. Like for example, very interesting one product is the bacterial cellulose. So this bacterial cellulose we can use. This is very much like a plant cellulose, and this celluloses we can use for different industries like food industries, textile industries, cosmetic industries, and we can take the benefit out of that. Apart from that, we can come up with we can synthesize by bacterial activities propionic acid. It is a short chain fatty acid and can be used as a preservative. So therefore it has a opportunity potential for utilization in food industry, pharmacies and so on. Apart from that, the vitamin B12 we can use as a supplement, we all know. Other than that, there is this component PHA and PHB. These are polyhydroxy alkanoids and polyhydroxybutyrate. These are actually biodegradable polymers. Okay, so these are very good candidate to use in place of the plastic that we use. So environmental sustainability is also there. So I will to a very important part of this plant molecular farming. So from the early 1980s, from emerging of these bioengineered proteins to still now on, mainly for the biopharmaceuticals, the main system is the bacteria or animal cells. So, but now we idea that we can use plants also for the production of the biopharmaceuticals, like some small proteins or some small chemical molecules. So here we will get the advantage that this trial condition is have to be not to be maintained, and there is it is less time consumable, and we no need to worry about this contaminating animal pathogen. This plant biomass after utilization, whatever is left behind, the residual biomass, the side stream, we again reutilize this plant biomass for production of some other value-added products like lignocelluloses, fats and oils, other small molecules and proteins. And after all of that, when everything is extracted out, then again this biomass we can reutilize as a biofertilizer and grow the next batch of plants for itself. So in that, and most importantly, there is less biological waste and no plastic. We are already worried about this plastic wastage that has been metric tons of plastic being generated, as previous speaker told. Plastic free.
Just a minute. Dr. Jayanta, kindly mute yourself. Dr. Jayanta, please mute yourself. Thank you.
Yeah, please do that, sir.
And we take the we can take the advantage out of this plant-based system. So I'll conclude that biopharmaceutical side streams hold significant potential as a valuable source for important products, and for getting the full benefit out of that, we need a strong collaboration between the research and development institutes and the industry stakeholders. Otherwise, it will be little difficult. And such partnerships can drive innovation, enhance sustainability, and unlock new opportunities in the circular bioeconomy. So here I'll thank everybody for patiently listening. Thank you.
Thanks, Chayan. I sort of hand over this session to NIAB because they are having two presentations from their side. Over to you. Thank you.
Thank you. We'll shift gears a little bit, and we have two presentations, two short presentations, one by a student and one by a young investigator. The presentation by a student is by Sagar, and he's going to show us the actual recycling of certain waste that is generated in the laboratories as well as elsewhere. So over to Sagar from Dr. Sonu Gandhi's lab.
Yeah. Good evening, everyone. I am Sagar Narlawar, working as a PhD scholar under the guidance of Dr. Sonu Gandhi at NIB. I would like to thank Director Ma'am for giving the opportunity to present the work which we have done at BNBL at NIAB. So in day-to-day life, we do generate lots of bio waste, plastic waste in the lab, such as pipette tips, centrifuge tubes, and these pin columns. Can we use these materials to fabricate some functional materials or the biosensing systems? The answer is yes. Yeah. So what we have done here, yeah. So we turn this pin column, the waste pin column, into the partition cartridge for the selection of aptamers against the pesticides molecule. Aptamers are one of the excellent biorecognition molecules for the biosensing fabrication purpose. So here what we have done, this waste pin column we have taken, we have removed out the other components and filled with the graphene oxide and the graphene nanoplatelets. Those adsorb the non-specific ssDNA during the SELEX procedure. And it solves the complicated procedures of SELEX, and it gives the specific target bound ssDNA in the flow through of partition cartridge. So we can recycle these plastic materials for the aptamer generation, and these aptamers can again be used for the uh, fabrication of biosensors. In the next, yeah. So next, what we have developed is the chromagrid light box based monochrotophos detection system. So here again we utilize the waste spin column, especially the O-rings from the spin column, to fabricate this chip-like assembly, which we term as a chromagrid. And using the waste styrofoam box, we have fabricated the light box, which is having the LED light source. So using this light box and chromagrid, we sense the monochrotophos pesticide. So how we sensed is, we just took out the O-ring from this waste spin column, mounted over the PVC sheet, and filled it with the chromogenic substrate, which are required for the sensing of monochrotophos pesticide. And then under this light box, this the image of this chromagrid captured, and the monochrotophos pesticide was detected using the smartphone. So here we utilize this waste spin columns and this PVC sheets and styrofoam box for the biosensing of monochrotophos pesticide. Next, what we have done here, we utilize the waste printer cartridge ink for the development of magnetic selects, which we term as a OCB selects. So we usually throw this printer cartridge, but still some amount of ink used to be there. So what we did, we extracted this ink. This ink is made up of carbon black. This carbon black we turned into oxidized carbon black, and this oxidized carbon black and this carbon black has a magnetic property which adsorbs the non-specific DNA during the SELEX procedure. So we developed here the magnetic SELEX procedure for the development of the aptamer for monochrotophos pesticide, and also build the fluorescence-based biosensor using this approach. So here we recycled this base toner cartridge for the development of OCB-based SELEX. Yeah, thank you.
Thank you, Sagar. We've actually seen, how to recycle some of the waste that we generate ourselves in our offices and the laboratory. Now I hand it over to Dr. Yash Pal, who's going to talk a little bit about circular economy and recycling.
So good evening, everyone, and thank you so much for this opportunity to present my work on World Bioproduct Day. So I'm Dr. Yash, working as a scientist at BRIC and IIB. So today I will be talking about yeast-based feed solutions for sustainable livestock nutrition. So So if we look at the livestock landscape of India, India has the largest livestock population in the world, with over 534 million animals that include cattle, buffalo, sheep, goats, pigs, and other. And it is the leading producer of milk globally, contributing significantly to the world dairy supply. And India produces roughly about 240 million metric tons of milk annually. So these numbers are quite interesting. So, but do these numbers truly reflect our success? So let's see the next slide. So if we look at the livestock or milk production capacity of US, it takes about 9 million cattle to produce 99 million metric tons of milk. While in case of India, it takes 125 million cattle to produce 208 million metric tons of milk. So that is roughly a cow in the US produce approximately 6.61 times more milk than the cow in India. And if we calculate the efficiency percent, so they are like almost 600 times more efficient than Indian dairy farmers. So apart from the breed type, the major factor for low milk production in India is due to suboptimal feed quality or poor feed quality. So what is the real problem? So it is estimated that by the year 2050, the global population will rise by 2.5 billion, and we have around 534 million population of cattle already, and that is expected to increase by 34% by the year 2050. So there is a and if we look at the fodder deficit, so the demand is almost 1,183 metric ton, and the supply is only 843 metric ton. So we have a deficit of both demand in dry fodder as well as green fodder. And the challenges the fodder industry is facing is the land, or will face in the future, is land scarcity, water scarcity, low productivity, seasonal variability, and storage and preservation. So we have all these combinations like limited resources, high demand, fodder crop production will become more expensive. So can we do something about it? So can we use some novel strategies to efficiently utilize and upscale existing resources for ruminant nutrition? I guess we can actually. We can use some raw materials that do not compete with our own food production. And we can also use microbial population to improve nutrition quality of existing feed materials for livestock feeding. One such material or raw material that we have is the oilseed cake or the oilseed industry. So the edible oil, if you look at the stats, so edible oil consumption in India has almost doubled in the last 10 years. And when this industry produces this oil, the spend which is remaining, that comes out as meals or oil seed cake. So if we look at the soybean or mustard seed cake, they have roughly about 1% to 7% of oil residues left in them. So can we do something about that? And if we look at the composition of fatty acid in both the soya meal and mustard seed cake, they have very high percentage of oleic acid and linoleic acid. So what is so special about these oleic acid and linoleic acid, and how it is important for dairy industry? So for that, we have to look at the composition of the milk. So if we look at the fat composition of milk in a normal cow, so this saturated fatty acid concentration is roughly about 60 to 70%, and that kind of constitute the major percentage of fat in any dairy cow. And these the good fat or the unsaturated fats are very less in percentage. So one of our aim is to how can we improve the good fat in the milk or produce a fortified milk. But these seed cakes doesn't come along with benefits only. There are some challenges also associated with them. So they have anti-nutritional factors. They rapidly are digestible in the ruminants, unsuitable for young calves. They can cause diarrhea, intestinal villi shrinkage, increased mucus production, ultimately leading to reduced digestibility. So we need an integrated solution. So can we have low fodder availability, and how can we improve it? And how can we increase the saturated fatty acid concentration in milk also, and do waste valorization? So we are using an integrated approach by using yeast cells. So these are nothing but these are miniature lipid factories that can also accumulate more than 20% of fats in them. They have lipid diverse profile, which are mostly unsaturated fat that are good fats. They are sustainable biorefineries. They are human protected and robust and fast growers. So it has already been established that the yeast feeding can increase the average daily gain and feed efficiencies in smaller ruminants. So what we are doing at NIAB, we have tried to isolate oleogenous yeast from different sources, and we were able to identify a lot of oleogenous yeast, and we have characterized and screened these isolate for their lipid accumulation potential on different substrates. And when we visualize them on microscopy, we can see these beautiful images where they are accumulating fats or lipids. So these are the images, like 10 images where you can see this lipid globule that is present. So they are accumulating fat on different sources. So the next step was that we also wanted to use or biotransform these oilseed cake with the yeast culture that we are using. So We used a solid state fermentation technique where we took the mustard or soybean seed cake as it is, and we kind of poured this material or yeast cells directly on them, and then we saw that they are nicely growing and dividing on solid states, and they are accumulating fats on solid state. And we were surprised to see that the yeast cells that were growing on solid state were accumulating more fat rather than the controls that we have put on. So these are some of the images where yeast cells are growing on substrate and accumulating fat. So these red dots, you can see there, they are lipid which is being accumulated inside the yeast. So we were also interested to see that these solid state fermentation can also reduce the anti-nutrition factors in oilseed cake. So we also found that they have the capacity to reduce anti-nutrition factors, especially phytic acid. So they were able to reduce that. And we also checked the in vitro adaptability because they had to pass through the humans. So they were also human protected and only disrupt in case of when pH goes down very little, like pH 2 to 3 though. So so the yeast cell wall may aid lipid release post ruminant digestion. So that was the aim for that. So the way forward is that we will use these yeast cell, which we did in the pilot trial in the in vivo study on large ruminant, to study the effect of yeast drive lipid on milk parameters, rumen digestibility and growth parameter, and ultimately give ultimately move forward for the large scale production of these. So the expected outcome we are speculating from this, that we will have a higher concentration of unsaturated fats in the milk, increase milk yield, low cost biomass and lipid production through solid state or submerged fermentation, bring biotechnological innovations to larger population and especially to the dairy farmers without any complicated process, improved animal health and productivity. And at the end, I would like to thank Director NIAB, DBT, my collaborators at ICGB, NIPGR, IBST, NIAB, and my PhD student. Thank you very much.
Thank you, Yash. I think with this, we come to the end of the presentations as well as panel discussions, etc. Now we're ready to take the pledge. And I request our director ma'am to lead the way.
Thank you very much. We, the people of Hyderabad, in the state of Telangana, wholeheartedly affirm our commitment to the vision of Bio-E3 policy of the government, a strategic framework to build a sustainable, inclusive, and innovation-driven bioeconomy, grounded in environmental conservation, economic opportunity, and employment generation. Recognizing our state's unique scientific, ecological, and cultural context, and the immense potential of our bioresources, we pledge to implement the Bio-E3 policy with dedication and leadership, guided by the following principles and priorities. Promote and actively collaborate on bioproduct innovation to unlock local and national potential. Establish and promote biotech innovation hubs that drive a regenerative circular economy. Enable biomanufacturing hubs and industrial scale-up for clean and sustainable production. Generate employment and build green skills, especially to reduce, recycle, and repurpose waste. Ensure bioethics and equity across all aspects of bioeconomy development. respecting community rights, responsible science, and just transitions. We recognize that the future lies in an economy that regenerates rather than depletes, empowers rather than excludes, and embraces future technologies to co-create with nature. We pledge to lead our state and our nation toward a bioeconomy that is inclusive, climate resilient, ethically grounded, and globally competitive. Thank you very much. We thank DBT for recognizing the importance of our state and giving chance. Thank you very much. Over to
So,
DBT.
yeah, thank you so much, ma'am. Thank you, CDFD and NIAB Hyderabad for bringing in, insights and youth voices on biopharma side streams as inputs and biomass valorization and relevant events. From morning to till now, we have completed fantastically all the sessions from all the BRIC institutes over, came forward to take it and really aligning to the whatever objective or our voice across the cities and we have taken it in a completely synchronized hour and we have celebrated this national dialogue. So we have discussed from coastal biomass, marine bioproducts from ILS Bhubaneswar, then taken forward by BIRAC on industry academia partnership, and they have fantastically showcased the innovators who are working on, on the lines of biomanufacturing. That is really important, and further the importance of enzymes in, transforming and translating the biomass-based products really is important for bioeconomy. And from INSTEM Bangalore, Bioproducts, the second life of science and industry, an important panel discussion has been organized that has clearly surfaced out the importance of these technologies, urban biomanufacturing, industrial-based utilization, algal-based photobioreactors, or trees that how can it can translate, can be important for eco and sustainability. IBST Impal has highlighted ethnobotany and forest-based bioproducts. So all the sessions were very much informative and in lines with the biomanufacturing initiative of Government of India. We thank you, all of you, for connecting, the peoples, connecting stakeholders, students, innovation community, and entrepreneurs with actual, science-based, evidence-based solutions that can really be important. And on behalf of Department of Biotechnology, we thank you, each one of you, for joining the event for today and making it successful. Thank you so much, all of you.
Thank you. Thank you. Bye
Thank
bye.
you, sir.